Teams chat, only for technical difficulties. If you need to message because something is wrong, like you can't hear, then you can let us know there. Thanks very much.
One, two, three, test. 1, 2, 3, test. One, two, three, test, test.
Good morning, everyone. We're going to get started in just a couple of minutes here, but first I'm just going to run through a few sort of housekeeping items. My name is Alex Baer. I'll be Commission Counsel today, so if you have any questions throughout the day, feel free to come up and find me. First, a couple of items just about what happens in the event of an emergency. We have a wall-mounted phone near the elevators. You can press the silver button to talk and it'll connect you to 911. There's also an automated external defibrillator over there, and in the event that we need it, hopefully not today. There's a bright orange emergency preparedness kit back by the IT table there. Again, hopefully not something we'll need, but just in case. There are emergency stairwells just through that door in the back, also out past the elevators and to the right. So in the event of the need to evacuate, use those, not the elevators. And our emergency assembly area is down at Granville and Nelson, near the Flamingo Cafe. On to non-emergency items. In terms of the allocation of the conference and breakout rooms, we have 2 rooms designated for BC Hydro staff just out here near the elevators. Those are conference rooms A and B. And there are also 3 rooms designated for intervener use during breaks. Those are breakout rooms A and B and conference room C. There's also signs on the doors just in case there's any confusion about that. Washrooms, including an accessible universal washroom, are just through the doors here, as well as a water filling station. The mic at the podium is push to talk, so there's a button on the right there, just press that, and when it's red, you're live, so just be mindful of that, and please turn it off when you're finished speaking. All attendees should have a lanyard like this one, so collect that at the front, and on your last day at the workshop, just return those as well. We'd appreciate that. And Wi-Fi login details are on those as well. A reminder that coat racks and closet space are available near the elevators in case you need that. And lastly, I understand there's coffee and tea at the back and possibly cookies, so keep us all fueled up for this week. One last thing, the panel, who I'll be going to grab shortly, has indicated there's no need to stand when they come in, so don't worry about that. And I'll go grab them now, and we'll get started in just a minute. Thanks.
Oh, wrong button. There we go. Good morning, everyone. Welcome to the BC Utilities Commission. My name is Mark Jackard, chair of this panel, and with me are Commissioners Tom Losky and Rose Murphy, and the matter before us today is BC Hydro's 2025 Integrated Resource Plan. I'd like to take a moment to welcome and introduce the Utilities Commission staff team who are sitting in the first few rows. Phil Stallard is the project manager, and with him are Jillian Sykes, lead staff, as well as Viviana Burrison, maybe just raise your hands, and Suri Gasuri, Avery Jones, Billy Van Sice, and Shane Zakowski. And our hearing administrators, Lindsay Bedard and Kate Kaw, and Alex Baer is the BCUC's legal counsel for this proceeding. I'm now going to very briefly summarize relevant aspects of the procedural history of this matter. The full details are available on the BCUC's website. BC Hydro submitted its application regarding the 2025 Integrated Resource Plan, or IRP, to the BCUC on October 31st, 2025. In the application, BC Hydro proposed a workshop to address the key issues in that IRP following one round of written information requests. In responding to information requests in March of this year, BC Hydro explained that the recently completed 2026 reference load forecast indicated an increased near-term need for new energy and capacity resources. BC Hydro noted it had started to explore a broad range of potential new resource options and subsequently proposed that the workshop be deferred from April to June to allow for these evolving issues to be explored in the most efficient way possible. On March 24th of this year, 2026, by Order G-66-26, the panel deferred the workshop from April to June. BC Hydro provided a pre-workshop submission on May 28th, and interveners have had an opportunity to provide written questions to BC Hydro in advance of the workshop. The workshop is intended to focus on key issues that have emerged during the proceeding. Namely, first of all, the load scenarios and sensitivities included in the 2025 IRP, additional load scenarios raised in IRs, and BC Hydro's 2026 reference load forecast. Secondly, the implications of planning under uncertainty, including trade-offs between earlier versus later action and the consequence of over or underestimating future load. Thirdly, an assessment of the viable resource options to meet these load scenarios. And fourthly, information on BC Hydro's timeline for considering updates to its planning criteria. The panel intends for the workshop to follow the process outlined in Order G-66-26, and for reference, that's Exhibit A-9. If needed, we may modify this process as things unfold, but our intention at the outset is to follow it. So, following my remarks, Commission Council will call for appearances, starting with BC Hydro and followed by interveners. Parties in the room should come up to the microphone on the podium here to introduce themselves and indicate who is attending the workshop on their behalf. And parties online should unmute themselves and do the same. Following appearances, BC Hydro will give its presentation. The panel expects that BC Hydro will indicate appropriate opportunities for interveners to ask questions. And during such opportunities, we will not be calling interveners in any particular order to ask questions. The panel asks that interveners in the room who wish to ask questions come to the podium or at least get the attention of Mr. Bear, and he might list down so that you can be seated again while awaiting your turn. And interveners online who wish to ask a question, please use the raise hand function on Microsoft Teams, and someone will make sure that we get you on our list as well. The panel and BCUC staff may also have questions for BC Hydro. I'll be looking to Commission Council to keep an eye on the room and participants online, and I'm confident that we can make things run smoothly. Following BC Hydro's presentation and responses to questions, we'll provide an opportunity for closing remarks from BC Hydro, if any, and I may make some final remarks at the conclusion of the workshop regarding next steps. Although we have not established a time limit for questions, we expect this workshop to be efficient and focused. We will ensure parties have a fair opportunity to pose their questions, but we may interject if necessary to ensure that workshop time is used efficiently. The panel wishes to flag that, as outlined in Order G-66-26, the panel has excluded several topics from the scope of the workshop, and we remind all parties that any questions at this workshop must be within that scope. The panel also expects that parties' participation in the workshop will be consistent with the guidance provided in Order G-299-25, which is Exhibit A3, in particular the level of detail and granularity which is pursued in this workshop should be consistent with the strategic level purpose of a resource plan and the BCUC's resource planning guidelines. I note that 3 days, today to Thursday, have been made available for this workshop. However, depending on how long questions and responses take, it is possible that the workshop will conclude earlier. I also want to briefly address the use of documentary evidence during the workshop. As noted in Order G-66-26, interveners may not file documentary evidence in this workshop. The purpose of the workshop is for BC Hydro to present its evidence and for parties to seek clarification of the 2025 IRP. So, regarding the scheduling for the day, we plan to take a break mid-morning and mid-afternoon at an appropriate time, and we will pause for lunch break around noon. We also may take further short breaks as needed. Let me know if panelists need a sudden break or anyone else for that matter. Okay, I will now hand it over to Mr. Bear, our counsel.
Thank you, Mr. Chair. Good morning. So for all parties' awareness, this workshop is being transcribed and broadcast over the BCUC's YouTube channel. I'll shortly be calling parties for the order of appearances as the chair indicated. And in order to ensure accurate transcription, please speak clearly into the microphone, identify who you represent, state your name, and spell your last name and first initial for the record. Finally, as there are some parties appearing virtually via Microsoft Teams, I ask that all virtual attendees mute your audio and camera unless and until you are called upon to speak, so as not to distract others or those within the hearing room. If a virtual attendee is dropped, there are call-in instructions in the email you should have received with the link to the proceeding today. In the event that it may be required, we can temporarily adjourn the proceeding to allow you time to reconnect. And with that, I will now call for the order of appearances, beginning with British Columbia Hydro and Power Authority.
Good morning. I am Ian Webb, IANWEBB, representing BC Hydro for the 2025 IRP. We'll leave it to the BC Hydro presenters to introduce themselves during the presentation. Thank you.
Next is Fortis BC Energy Inc. and Fortis BC Inc.
Oh, thank you. Good morning. Daniel Hall, Fortis BC Energy Inc. Last name, yeah, Hall, first initial D. Looking forward to today.
Nathan Howe, Fortis BC Energy Inc. Last name AU, first initial N.
Next is Movement of United Professionals.
Good morning, Jim Quayle. That's J as in Jim and Quayle as in the bird that flies around. Here representing Move Up, Movement of United Professionals, which is the union that represents the inside workforce of the utility.
Next is BC First Nations Energy and Mining Council. Next is Clean Energy Association of British Columbia.
Good morning, Mr. Chair and panel. I'm Travis Lusney, Director of Power Systems with Power Advisory, representing Clean Energy BC. I'm joined online by my colleague Peter Wang, Director of Transmission and Grid Connections, as well as Jack Magnus, Director of Engagement and Operations with Clean Energy BC. We also have legal counsel Sabrina Spencer from Airbnb. Thank you.
Next is Statimk Chiefs Council.
Good morning. My name is Ann Muter for Statliam Chiefs Council. The last name is Muter, first initial A.
Next is Association of Major Power Customers.
Good morning, it's Michael Manhas, MANHAS, first initial M, counsel to the Association of Major Power Customers of BC. With me today is Melissa Davies, TAVIES, first initial M, and she's a consultant to the Association of Major Power Customers.
Thank you.
Next is West Coast Climate Action Network.
Good morning. Bill Green, West Coast Climate Action Network, green the color and B the initial, and joined online by Robert Gunn, GUNN, and R. Thank you.
Next is City of Vancouver. Not hearing anyone. Next is Council of Senior Citizens Organizations of BC, Active Support Against Poverty, Disability Alliance BC, Tenants Resource and Advisory Center, and Together Against Poverty Society.
Good morning. My name is Irina Mis, MIS, first initial I. I'm a counsel on behalf of COSCO, Council of Senior Citizens Organizations of BC for All. And with me online, my co-counsel, Leah Worth, WORTH, first initial L. Thank you.
Next is Commercial Energy Consumers Association of BC.
Good morning. Name is Patrick Weaver, first initial P, last name WEA, F as in Frank, ER, legal counsel to the Commercial Energy Consumers Association of BC. And joining me online are David Craig and David Ince. David Craig is DCRAIG, and David Ince, D, last name INCE. Thank you.
Next is Residential Consumer Intervenor Association.
Good morning, Peter Helen, representing Residential Consumer Intervenor Association, P, last name Helland, HELLAND. Online with me will be counsel for our CIA, Nancy McKenzie, and joining tomorrow will be the director of our CIA, Michael Bain. Thank you.
Are there any parties either in the room or online that wish to make an appearance and I have not called? I'm not hearing anybody. I'll pass it back to you, Mr. Chair.
And I am to do what? To pass it to BC Hydro?
I think, yes, probably time for BC Hydro's presentation. Is there anything arising from Hydro's council? No. Yeah.
Yep. Please go ahead.
Good morning, panel, and good morning, audience. Thank you for the opportunity to be part of the IRP 2025 workshop. I'll first introduce the panel, and then we'll go on with the proceedings for the presentation. My name is Ajay Kumar. That's last name KUMAR, first initial A. I'm the Senior Vice President with Integrated Planning at BC Hydro. I'm joined on the panel with Anthea Jubb, last name JUBB. Initial A, she's the Director of Energy Planning. Also on the panel is Sanjay Desoya, last name ZOYSA, initial S. We also have Chris Sandby in the audience. He's the Chief Regulatory Officer for BC Hydro. Before we get started, I do want to acknowledge that we are gathered here for the workshop in the unceded traditional territory of Musqueam, Squamish, and Tsleil-Waututh. As a student who came to Canada in the early 20s, I am actually privileged and to actually enjoy the lands that we live in, and I think it's always something that I cherish every day. We also have people calling in from different locations that are located on other First Nations traditional territories also. It is an exciting time for utilities in Canada, and there's a lot of emphasis on growth and investment. And today in our conversation and our slides, we will actually give you an overview of all the different things that we're looking at in BC Hydro over the next 20 years in terms of how we are going to meet the energy and capacity needs in the province. And we'll give you insights in terms of what are the near-term actions that we are planning for as we go forward with that. As far as the agenda is concerned, as the panel mentioned, we have set scope for the proceedings, and the agenda is actually structured around those 4 topics that the Commission had laid out. I'm going to start off by talking a little bit about the IRP overview and how we manage uncertainty in this IRP, because this IRP is a little different than the 2021 in terms of the asymmetric risk that we talked about in our plan. After that, we are going to actually move over and talk. Anthea is going to talk about the reference load forecast, which Mr. Chair, you mentioned in your opening comments that we do have a new reference load forecast, and we're going to spend some time talking about that. We will also talk a little bit about the additional load scenarios that we have laid out in the plan, and then we'll move on to talk about the different resources that are going to allow us to meet those load scenarios. And Sanjay is going to spend quite a bit of time talking about those. And then he's going to end his presentation talking about the 4th topic that was part of the workshop, which is talking about the planning criteria that we use for our IRP analysis. After that, I'll come back and talk about some of the closing remarks, and then we'll open it up for any detailed Q&A. Couple of things before I move on. You'll see there's a red icon at the top of the slide. That red icon actually signifies the questions that were submitted before the workshop, and we will try to address those as we go through the presentation, and we'll have some numbers that outline which questions we are referring to. Also, as discussed with the BCUC staff, we will stop after each agenda item and take any clarification questions that might have on those topics, but the detailed question will be at the end of the presentation when we finish them. So in terms of our overall plan, as you will recall, yesterday we had a big announcement where our minister and our CEO announced the Powering Growth Plan for BC Hydro, and this was actually quite a watershed event for BC Hydro, and the plan that was laid out is actually quite foundational for us in terms of meeting our energy and capacity needs over the next 20 years. And you would have seen in that plan that there are 3 pillars that we are focusing on. We start off by looking at the conservation side. Then we look at the optimization of our existing assets, and you'll see there's a number of opportunities that we've identified both on the generation side and on the transmission side that allow us to optimize our existing assets. And it's quite timely because a lot of our assets are aging. So that gives us the opportunity to actually optimize our generation and transmission to meet the future requirements as we go forward. And lastly, we will talk about some of the build analysis that we've done, both on the transmission side in terms of the infrastructure that we need as we go forward. And we'll also talk about some energy acquisition infrastructure as well as the capacity infrastructure that we need. So I'll spend time on all those 3 pillars in the next few slides and give you a quick overview in terms of what are the things that we are exploring under each one. As far as Power Smart is concerned, in BC Hydro, we launched that program 35 years ago, and we are quite excited with all the benefits that we've been able to accrue from that program. And it has been something that has actually allowed us to work very closely with our customers to reduce their energy and capacity needs, and that has a very positive impact on the investments and the regrowth that we see on our system. And if you look at our plan for the next number of years, as outlined in the IRP, and also in the Power Smart 2.0 announcement that we did in May, there's a number of elements that we are exploring as part of our DSM programs. And if you look at all of those in totality, in terms of the 21 IRP as well as the 25 IRP, we are expecting about 800 megawatts of savings on the capacity side and about 2,800 gigawatt hours on the energy side. To put that in perspective, if you look at our new John Horgan generation plant, that 800 megawatts is just over 70% of the capacity of the John Horgan Dam. And if you look at the energy numbers, we just finished our 2025 call, and I'll talk about that in the next few slides. But the net energy that we are going to be procuring through that 25 call is actually lower than the 2,800 gigawatt hours of energy that we expect to save as a result of our DSM program. So I think that gives you the amount of benefit that we think will accrue from all the capacity and the energy savings, and it is part of the resource stack that we look at as a first option when we start looking at our load resource balance. And Sanjaya will talk in more detail around some of the elements of those as we go forward in terms of how this meets our overall requirements. The second thing I want to talk about is optimization of our generation assets. And going from the left to the right, we are moving forward with the Unit 6 at Revelstoke, which will provide us with about 500 megawatts of capacity. And this was outlined in our near-term actions in the 25 call. In addition to that, we also outlined in our plan that we have a project for the GMS generation plant, where we can actually upgrade some of the circuit breakers and iso-phase bus that allows us to get another 100 megawatts of additional capacity. So I think those are two examples of how we are optimizing our assets to get more capacity from our system. And in addition to those two things that were outlined in the 25 IRP, in the May 28th submission that we made to the Commission with respect to our update on the IRP, we actually outlined two additional opportunities in there. One was with MICA units 1 to 2 turbines, and the second one was 7 Miles unit 1 to 3. And these two examples actually really epitomize the approach that Hydro is taking towards its existing assets. And both these projects were driven by end-of-life replacement of our assets, but will give us additional capacity, about up to 90 megawatts for MICA units 1 to 2, and about 40 megawatts for the 7 Mile. So I think those are two examples that we are exploring. And again, in some of the subsequent slides, we'll talk about the whole portfolio of our optimization for generation, and you'll see there's quite a few opportunities going into the hundreds of megawatts of capacity that we can get from our existing systems. There was a question that was submitted as part of the pre-workshop submission that talked about the timelines and whether we have any ability to expedite those timelines. The timelines that you see on the slide are actually the expedited timelines that BC Hydro feels that can deliver. And we've looked at all the different options. We worked with suppliers. A lot of the lead time is driven by the equipment that we have to order, and that's driving some of these timelines. But we are going to keep on exploring those as we go forward. And a number of those applications, especially for the MICA and the 7 Mile units, will be coming to the Commission as major project applications. And through that, we'll be exploring other options for accelerating those projects. The second pillar of our plan is energy acquisition. As you will recall, we actually haven't had a call for about 15 years. And then in 2024 and 2025, we had two back-to-back energy acquisition calls. And they both were very successful in terms of the interest we ended up getting from the market IPPs. In the 24 call, we actually awarded 10 energy purchase agreements. And most of the projects in that call are actually progressing quite well. And we are quite hopeful that those will be online as per the expectations and commitments. For the 25 call, we just recently awarded 4 energy purchase agreements, totaling about 3,500 gigawatt hours. And we are expecting that we'll be filing Section 71 application to the Commission in August for those energy purchase agreements, and there'll be more detail provided around the pricing around those. So again, quite excited with this energy acquisition plan. I think one of the lessons we've learned from this energy acquisition is that we now have the process and the structure and the skills to replicate this as we go forward. So as new energy needs are identified as we go forward, we feel that these two calls have given us the foundation to launch additional calls if and when needed. There were a number of questions with respect to the energy acquisition and the level of acquisition we were doing with the 25 call, and I want to quickly address those as part of the opening comments. One question was around, we have acquired 3,500 gigawatt hours, which is less than what we had initially outlined in our IRP plan. And the question was, where does the rest of the energy come from? And there are 3 avenues we are pursuing in addition to the call. One is we have active discussions with First Nations around partnerships that are driven as part of our capital projects that are moving forward. So those partnerships will give us additional energy and that will allow us to actually move towards that target of 5,000 that was outlined in the IRP. We also have plans to launch a new call if and when required. So that'll give us the additional energy that we need. And thirdly, I would say is hydro is also exploring opportunities for building its own wind. That is something that we have not actually leaned upon historically. It's been provided by IPPs ever since we started doing calls over more than 30 years ago. But it's an avenue that we are exploring, and we feel that we need to get an indication in terms of our ability to move forward with that and the competitiveness of in terms of the energy cost. So those are the three avenues that will allow us to meet that requirement. There was also a question regarding self-sufficiency, whether that's driving these needs for energy, and that is true. We do have to meet that requirement as per the Clean Energy Act, and these resources that we are acquiring allow us to do that. And then there was a question around the risk in terms of, do we see any risk in terms of acquiring this as we go forward? In our mind, we don't see any risks. I think we are well positioned to acquire this energy. We've got an amazing response from the IPP community for the 24 call and 25 call. So that gives us that confidence that we can actually acquire this energy as we go forward in a timely fashion. Moving on to the transmission side of our portfolio, you'll see that this one has both a build component and an optimized component. And let me first talk about the right-hand side, the North Coast transmission, and then I'll go towards the other two columns. And in the North Coast, we are taking an approach of both optimizing and building. So as you know, we currently have a 500 kV line that serves the North Coast. We are moving forward with a project called the PGTC, which is Prince George to Terrace capacity project that will give us about 500 megawatts of additional capacity by optimizing that system, by putting in series compensation. And that is a great win for us because we can actually get quite a bit of additional capacity beyond what the current line can provide. In addition to that, because the load growth exceeds that capacity that the first project will provide, we are also moving forward with a new build, which is the North Coast transmission line that is also moving forward, and that will double the capacity in the North Coast as we move forward. If you look at Vancouver Island, given the fact that we actually need to supply some of the load on Vancouver Island through transmission, we are moving forward with a reinforcement in that area by building the Vancouver Island transmission reinforcement, which is going to be a cable connection to the island, which will give us another 600 megawatts of additional capacity to serve the island. In terms of the South Coast, currently we have 500 kV lines that actually connect Nicola and Cali Lake in the interior down to our South Coast to serve the load. Those lines, we are optimizing those by putting in series compensation and voltage support to allow us to actually have additional capacity through those lines without building a new one. That again is going to be quite key for us. The first phase will give us about 750 megawatts. The second phase, which is still in the early stages of being planned and discussed, will give us another 400 megawatts for that additional capacity. So very key for us to meet the load both in the lower mainland as well as Vancouver Island through that South Coast reinforcement. Lastly, in terms of the capacity, as outlined in our growth plan that was discussed yesterday, and we've actually talked about this in some of the IR responses, that one of the near-term actions of our plan was to actually do a request for expression of interest for capacity. And we did that in parallel with our clean energy call that was happening for energy, because we knew that the need for capacity would be starting to show up in our future years. And we wanted to get a head start to start evaluating what the opportunities were. And we were quite excited. We got 106 submissions last year for the expression of interest that closed officially in December. About 19 gigawatts of potential capacity and about 37,000 gigawatt hours of energy that was identified through this. Now, we have to keep in mind these are submissions. They are not actually submissions from an RFP perspective, but just high-level submissions in terms of the prospects that exist in that area. And we got a mix of number of different technologies. There was biomass, geothermal, batteries, as well as large hydro that the proponents put forward. We are in the process of analyzing those submissions, and we will be coming up with a plan of how we want to move forward with those. And We got a glimpse of that in the document and the announcement that the minister and our CEO had yesterday, but there's more work to be done in terms of assessing those as we move forward in the coming months. I also want to talk about the utility scale batteries. This was a near-term action identified in the 2021 IRP, and we are actually making very good headway in terms of that. We have put forward a procurement approach that we'll be launching in the next month, and we've identified a site on Vancouver Island at one of our existing substations, which will be ideal from a transmission perspective to put some high batteries in there. And then we are exploring opportunities to look at higher level of batteries also as part of this procurement. So this is a new approach for us, new capacity resource for us, and we are quite excited that this is going to become part of our portfolio in the coming years. Before I hand it over to Anthea, I just want to spend a little bit of time on talking about uncertainty. And I think there was an interesting IR that Mr. Quayle had asked as part of the first round of information request. It was, I think, move up 1.1.1. And it said, how do you compare the 21 IRP versus the 25 IRP? And I think one thing that really stands out in my mind is there's risks and uncertainty in both those IRPs that we were trying to establish and cover. But the asymmetric risk of the 25 IRP is what differentiates it from the 21 IRP, because we feel that given where we are in the geopolitical climate, where we are with our economic development imperatives in the province as well as on a federal level, the consequences of not having enough energy and capacity versus the risk of having a deficit are far outweigh each other. So I think that is something that has been a theme of our IRP, and we've outlined that in our application, and we've also brought that out as part of our responses to the IRs that came up. And I think there was a Commission IR BCUC 1.4.5 that outlined in terms of what are the steps hydro can take if we need more energy and capacity. And in that response, we actually talk about solutions we can do from an energy standpoint. If we have to accelerate things, we outlined things we can do on a capacity standpoint that we can move forward, and also on the transmission side. So I think that really sums up how we look at this IRP in terms of the asymmetric risk. And I think the near-term actions that we have taken allow us to move forward with a number of things on the transmission and the generation side, but also we have other things that we can explore if and when we get the indication that more load and more capacity needs to be served. And I think the other thing also to keep in mind is a number of the interveners asked about if we will be in a surplus if the load doesn't materialize. And I think in our response to those questions, what we have said is the near-term actions in the IRP are things that we are pursuing, but they have off-ramps. And we have the ability to actually pull back on those near-term actions if we feel that the load is not materializing. And as we saw from our 2026 load submission to the Commission as part of our IR responses, load is actually starting to move higher than what we had initially envisioned in the IRP plan. So we think that the risk of that under load materializing is very low at this point, and the IRP and the near-term actions actually position us well for meet the future needs of capacity and energy. With that, I'm going to pause and see if there's any clarification questions before I hand it over to Anthea.
And maybe just in terms of the process, anybody in the room that wants to ask a question, just come up to the podium. If somebody's speaking, just come to me and I'll put you in the queue. And likewise, anybody online, just use the raise hand function and we'll put you in the queue as well. I believe Clean Energy BC.
Thank you. Thanks for the presentation update. You mentioned that BC Hydro is considering pursuing wind generation. I don't believe that was disclosed in any of the previous stuff. Is part of the disclosure for that included in terms of development capital requests for BC Hydro to go and look at that? And then a further kind of clarification on how that fits with the First Nation equity minimums that were outlined in the calls and how it would interact with the potential 2028 call.
Yeah. So that is something that we actually are in the very early stages of having discussions with the developer. So I can't get into those details at this point. Again, the thinking behind us doing this was trying to get an understanding of what that potential is for us, because we've got some indication from a price perspective on the 24 call and 25 call. And as BC Hydro, it behooves us to look at what that option would be if we were to develop that from a pricing standpoint. So that's what we are exploring right now, very early stages of discussions with the developer. And that will be, if we do move forward with it, it'll be part of our capital plan, which is in the midst of being developed. So there'll be lots of opportunities in terms of looking at what that cost implication would be for BC Hydro's plan.
Okay, thank you.
I think we have a question from the Association of Major Power Customers.
Thank you, Mr. Kumar, for your presentation. I just had a question about slide 11, where you discuss the uncertainty. And on the right, I note that you've considered dampening effect on economic development and electrification as part of one of the concerns with being in a deficit. Has BC Hydro done any similar analysis on the surplus side in terms of the economic impact or the impact on economic development and electrification from having higher rates as a result of a surplus?
Yeah, I'm going to let Sanjay or Anthea speak to that.
Yeah, I can speak to that, and I'll get into more details when I do my presentation. But the short answer is yes, we've looked at the potential for increased cost as well as rate impacts, and we've also done that across a range of market price scenarios as well. So I'll get into more details during my presentation.
Okay, perhaps I'll save my questions on that for after your presentation, sir. Thank you.
Any other questions in the room or online? So I'm not hearing any. I believe.
Oh, there's a question.
And I think, is that Mr. Ince?
Yes. So in terms of our future capacity needs, Mr. Ince, we do see a requirement that shows up in the latter part of our 20-year load resource balance. And as part of the RFEOI submissions, the Butte Inlet project was actually submitted as part of that process. And we do see that there's an opportunity for us to look at large hydro, because that does provide us with that level of capacity that shows up in the latter part of the 20-year plan. I think one thing I would like to say is there's opportunities for large hydro that could be over 10,000 megawatts of additional capacity in the province. And currently, if you look at the Clean Energy Act, a lot of those opportunities are forbidden, and we can't move forward with those. And I think what we are doing over here.
I think there might be somebody online.
Someone online probably needs to mute.
Okay. And the approach we are taking is we have looked at all those opportunities, and we've landed on these to move forward in terms of a high-level assessment, both from a technical perspective and a financial perspective. So no decisions are being made around those two projects, but given the fact that these are multi-billion projects that take over 20 years or sometimes longer to develop, we want to make sure that we can actually do some assessment before we can make any decisions. So we've identified those two as the leading candidates for us to look at and to sort of evaluate those, and those are outlined in that announcement that you talked about, Mr. Ince.
So any further questions from interveners in the room or online? I see Not hearing anyone, and I understand there's no questions from the BCUC staff team on this portion. Anything from the panel?
And there's nothing from the panel.
Thank you. I'll hand it over to Anthea to talk about the load forecasting.
Is that one yours? Thank you very much. It's nice to be here today. I'm going to start my segment talking about the planning context as it relates to load forecasting and provide some of the information behind our 2026 reference load forecast. After that, there's a pause for clarifying questions, and then I'll get into the additional load scenarios that we've discussed through this IRP proceeding. I'm going to start with a planning context looking North America-wide at the history and forecast for electricity consumption. We've obtained this information from our load forecast service provider, Itron. They provide load forecasting expertise, benchmark, and software. They're the leading provider across North America, and they've got more than 100 electric utility subscribers, including many Canadians. And what this chart shows, I'll just walk through how to read it. It goes back in history to 1974, and it shows electricity sales in energy. And then it goes out in the forecast period from 2025 to 2035. On the y-axis, those are total electricity sales. And if you look closely, you can see it's in 1,000 gigawatt hours. And going back to 1974, the total sales for this representative group of utilities was almost 2 million gigawatt hours. So it represents much of North America. But if you zoom out and don't look too closely at the y-axis, this looks a lot like BC Hydro's history and forecast. We also had steady growth of electricity sales in the 70s, 80s, 90s, and into the early 2000s. And like our peer utilities across North America, that really slowed down in the early 2000s and for about 15 years. Across North America, what was happening, and here in BC as well, was both an increase in energy efficiency and also a loss of electricity intensive industries. Here in BC, it was forestry. Across North America, we are coming out of that period of low load growth, and we're starting to see load and forecast load in particular really pick up and moving back into a growth period. And that is driven by electric vehicles, data centers, electrification of home heating, and other large loads. Another interesting change that's happened is the return of a correlation between electricity growth and economic growth. Those two used to be very correlated back in the 70s, 80s, 90s. Electricity and GDP were in lockstep. And then in the 2000s and early 2010s, that correlation broke down as the economy shifted more to services and the impact of energy efficiency. And now we're seeing that correlation come back, and it's back around 85% as the relationship between electricity and the economy are coming back, with electricity being an enabler of growth. I'm going to move now into BC Hydro's load scenarios. I'm going to spend a bit of time on this chart just to walk you through how to read it, because a number of the subsequent ones use the same format. The next ones will go faster. So starting with the x-axis, we're going back in history to 2005, and then we've got the forecast going out to 2050. The y-axis in this case is energy, so this is an energy graphic. The solid blue line are historic actuals. So in all of the graphs that come, the solid blue line is always the historic actuals. And then the forecasts are the dotted lines. And there's a range of forecasts. These are the load forecasts that are the planning scenarios in our IRP. The bottom one there, the bottom dashed line in green, that's our low load scenario. the top dashed line in red is our high load scenario. And then the reference load forecasts are in the middle, the 2025 and the 2026 reference load forecast. And looking back in history, just going back to that history, you can see that flat load that was observed across North America represented in our actual sales as well. In terms of the forecast period, a key finding for BC Hydro with the update of the 2026 reference load forecast is that it is now approaching a high load scenario, particularly in the near term, out into the early to mid 2030s. And we'll talk more about why that is shortly. The next chart here shows peak demand, and again you can see the history going back to 2005. Our peak demand was about 10 to 11,000 megawatts, and peak demand is it's a critical part of resource planning because it drives the need for capacity, and peak demand represents our customers' highest need for power over the year. You can see the forecast scenarios there again and the range of scenarios, and the reference load forecast almost touching the high load scenario over the near term. And just to put into context the growth in peak demand that we are expecting now, between 2025 and 35, so over 10 years, we're expecting a 3,000 megawatt increase in peak demand, which is a tremendous increase considering our historic peak demand hasn't exceeded about 11,000. Peak demand is the driver of capacity, and it's a critical input to our planning. In most of the slides that follow, though, I am going to talk about energy, and I'll just walk through why in the next couple of slides. It's not that peak demand is not important. It's really important. It's just about how our forecasts are built up. We discussed how the forecasts are built up in the 2025 IRP application in Appendix A, and this graphic shows how the energy forecast is built up. Energy forecasts, of course, they're very important to integrated resource planning. Another key use is revenue and rates forecasting. And for revenue forecasting, you need the rate class. So our energy forecasts are built up by rate class. We've got tremendously high quality data and sophisticated models to forecast these customer sectors, and that's what's most needed for revenue. So on the energy side, we do have a lot of insights into what's going on with our customers to help explain the changes. Peak forecast, the other main client group, in addition to long-term resource planning, is distribution and transmission, asset planning and capital planning. Or for that use, it's not particularly relevant whether it's a residential or a commercial customer. It's about how much of the service is distribution or transmission served. So our peak forecasts are built up by distribution and transmission, not by individual customer sectors. So for that reason, most of the slides that follow are on an energy basis, because that's where we've got more resolution into what's going on with our customers. This slide shows what's happened to our large industrial sector and the changes going forward. I'm going to start by walking through the graphic that's called 2025 reference, and members of our technical advisory committee might remember this from last July when we presented it. And it shows the y-axis is energy, and the solid fill, that's our large industrial sector. So this is all of our large industrial customers, which are transmission connected load customers. Goes back to 2005, and then the forecast period starts where that line is. So just starting with the history, if we go back to 2005, the bottom green fill, that is forestry. And back in 2005, forestry was by far our largest customer subsector. It was almost 25% of BC Hydro's total electricity sales. And we also had mining. Mining is the light blue fill above forestry. A little bit of oil and gas. There wasn't much oil and gas load at that time. And then that other sector, which is everything other than forestry, mining, oil and gas, and LNG, and it was pretty small at that time. You can see moving forward to 2025 what's happened to large industrial forestry. BC Hydro's lost 10,000 gigawatt hours of sales to large industrial forestry, and that really tells the story behind why our load was flat in the 2000s and early 2010s. The types of customers that we lost were a lot of the large pulp and paper mills that were large energy consumers. We still have a forest industry in BC, and we still expect that to continue, but these are not large purchases of electricity. They either have self-supply or they're just not very electricity intensive, such as a sawmill or a value-added wood processing facility. Looking at the forecast, when we did our 2025 forecast, we expected large industrial load to recover back where it was in 2005 at 15,000 gigawatt hours. We expected that to recover in a couple years and then reach 20,000 in total, with most of the growth being from oil and gas, LNG, and some from mining. Now, if you look at the 2026 forecast graphic, the key changes there are instead of reaching 20,000 gigawatt hours, we now expect the large industrial load to reach 25,000. And you'll see a lot more growth in oil and gas, LNG, and this other category. And I'll talk a little bit more about those now. Oil and gas and LNG is the steepest load growth area that we are expecting over the near term. What's shown here is the 2025 forecast. That's pretty faint in my view, but it's the bottom dash line. And then the 2026 forecast is the top dash line. And those of you who are familiar with our large industrial forecast method will know that we assess all potential new projects, and as they become more certain, so they move through key development milestones, more of the loads reflected in the forecast. And that's what's happened with oil and gas and LNG. We've got a number of major projects that are now either reached in operation or well under construction, and the certainty has increased. And we are now projecting really steep growth in this sector out through until the 2030s. We did get a question from Move Up about the impact of the global situation on LNG and our forecast in general. Where it's most pronounced is in this LNG sector, oil and gas sector. And what's presented here is our market experts, Wood Mackenzie, their outlook for BC LNG last year relative to this, and they're seeing an acceleration and momentum behind LNG. They also highlighted long-term downside risk of the potential for demand destruction if the price and the supply of oil and gas continues to be disrupted. Moving on to mining. Mining is an area of tremendous potential in BC, and there's a lot of potential growth there. We were seeing that growth and that potential back in 2025, and we're still seeing it in 2026. Not a lot of change between the mining forecasts over the year. Large industrial others, where we've seen the biggest change between the 2025 and 2026 forecast, and I'm going to spend a little bit of extra time here to talk about that change, and also because it was the subject of some questions from the BC Utilities Commission and also Move Up. This sector includes loads, institutional loads like ports, universities, airports, municipal sewage treatment, and historically it's been quite stable. It also is where we've put all the emerging industries. You can see that stability until about 2022, and then that increase is our first large transmission-connected cryptocurrency customer coming into service. Shortly after that large project, that customer with several projects energized, the BC government put in the cryptocurrency pause in place, which meant that BC Hydro was relieved from our obligation to serve new cryptocurrency customers. And this sector appeared pretty stable when we were developing the 2025 forecast. which happened back in winter 2024 and very early 2025. And then in summer 2025, we had a large increase in requests for service from AI data center proposals across transmission and distribution service, some of them up to several hundred megawatts in size. AI data centers are a challenge to forecast, not just for BC Hydro, but really across our entire industry. We have a proven method to forecast large industrial loads that we've talked about before. That method benefits from some characteristics that we don't have for AI data center loads. So for both types of loads, we've got interconnections information on their progress through our queue. But for large industrial loads in the resource sector, we also have observable milestones such as environmental assessment certificates. We've got deep market expertise on experts that can assess the financial viability of individual LNG and mining projects. We also have a cycle from concept to production that can be 10 years or more. With the AI data center loads, they are able to reach concept to production in as short as 3 years. There's few observable milestones because they don't go through environmental assessment, certificate process typically, and other public processes. And because they're not tied to a natural resource, AI data centers have developed a practice North America-wide of submitting duplicate electrical service requests to multiple electrical service providers, which makes this a difficult load to forecast. Various utilities have taken a range of approaches to deal with this emerging sector. We can get into that more in the Q&A if there's interest. Moving on back to BC Hydro, as forecasters and planners, we're very glad to have the policy mechanisms in place here in BC to manage this emerging industry. I mentioned the cryptocurrency moratorium that has now been made permanent. So BC Hydro is permanently relieved of our obligation to serve large new cryptocurrency. And then in 2026, the BC government also enacted the Data Center Facility Power Regulation, which provides an allocation of up to 600 megawatts total, but divided over 2 tranches, the first being 400 megawatts for AI data center load. And in 2026, after this forecast was finished in March, BC Hydro launched the call for demand for AI data center loads for up to 400 megawatts. With this background, I'll summarize how we forecasted AI data center loads in the 2026 reference forecast. There's 3 categories of these loads. The first one captures facilities that were already operating or proposals that were sufficiently advanced to not be subject to the call for demand, which meant they had paid the design deposit or facility study agreement. This is the largest category. There's 350 megawatts in the forecast from this group. The next category, these are potential new data center AI proposals that would be subject to the call for demand. When we developed the forecast, we didn't know, it was before the call for demand was issued, we didn't know who might apply for it. The call for demand's underway right now, and it won't be done till the fall. So the way that we approached it is that we looked at all of the potential proposals, and we've assumed that 50% of the 400 megawatt cap will reach operation. So there's 200 megawatts from the calls for demand in the forecast. Category 3 is all other AI data center loads, and it largely captures smaller proposals that are small enough to be exempt from the call, so below 10 megawatts. And there's 30 megawatts from category 3. Hydrogen is also in this subsector. We did get some questions on hydrogen. It's not very active right now, so I'm not going to spend much time on this slide, but I'm happy to come back to it in the Q&A. Forestry, we've talked about what happened with forestry. This just shows the forecast, not a big change in the forecast between the years, but a continued decline expected. I guess the good news is that it is expected to level out, so I believe we've largely seen the bottom for forestry. Electric vehicles, still an area of growth that we're expecting at BC Hydro and North America wide. Over the long term, our forecast is down about 1,000 gigawatt hours from last year because of the change to the electric vehicle policy and targets, both provincially and federally. Over the near term, though, we were seeing a bit more momentum in vehicle sales with incentives back available and also expected availability of some lower cost imports. This is a busy slide. I'm not going to go through it all. It's here to address questions from the Costco parties about our electric vehicle forecast and its key inputs. So I think I'll park this one for if people want to get into it in a question and answer. It just is a schematic that walks through how we build up our light duty electric vehicle forecast and the key inputs. We also had some questions from the Costco parties related to electric vehicles. This slide just depicts the really amazing data we have available now on electric vehicles. There's been a huge progression since I got involved in load forecasting a few years ago in the quality of data that we have on electric vehicles. We've got very high resolution data on the type of vehicles, where they are, how they charge, the load profiles, and some of that's reflected here. I'll save further discussion of this for the Q&A if there's interest. Residential, we have experienced and we are forecasting growth in residential. The growth is from home charging, so any electric vehicle charging that's done under a residential service rate is in this forecast. We've also got electrification from zero carbon building code reflected in this forecast. And although we've experienced a short-term population decline, over the long term, we are expecting population to grow and accounts to grow. We did get some questions from the municipalities about space cooling, and there's a fair bit here. I won't go through it all. We can cover it in questions and answers if there's interest. I'll just mention these are actual space cooling shares based on our end use survey, and space cooling has increased. We have seen an increase in the use of space cooling for our customers, and we are forecasting increases in space cooling. It's still, though, quite a small part of our load, and our cooling season is pretty short. It's only a few weeks. So we've put some stats there about how much cooling load is for a typical account. It's not a material driver of growth over the currently or over the forecast period. Of course, that could change. It's possible it could change. This is the view or the information we have right now. We also had questions from the municipalities about whether we were seeing our customers leave the gas system. And this is, again, from our end-use surveys. We're not seeing existing customers leave the gas system. We do have new accounts forecast to be, on the residential side, 50% of them to be all electric, but we're not seeing existing customers choose to leave the gas system at this time. What we are seeing is more secondary electrical heat and cooling. This would be portables and also ductless heat pumps. But as far as we can tell right now, people are not giving up their gas service if they've got it already. The commercial sector is interesting primarily because it is so flat. It's really flat over the history and the forecast. So it's got a lot less dynamism than the other sectors, and there's a few reasons for that. Even looking at the forecast, that already includes any charging of electric vehicles under a general service rate, so workplace, public, fast charging, the common area of multi-unit residential, and it's got electrification from zero carbon building code, and it's still barely growing. One of the reasons for that, and this speaks to some questions we got from the BC Utilities Commission about the impacts of codes and standards, is the impact on load, and the impact of codes and standards is most apparent in this commercial sector. the graphic that we're showing here is again from Itron, our service provider, and it's a North America-wide view of what's happened to electricity use intensity in the commercial building sector. So that's kWh per, they're an American provider, so it's square feet, but it could be square meters as well. So it considers the total electricity use per square meter. And you can see since 2000, goes back 10 years, decline in electricity use intensity of about 10% over that period. And that is driven in large part by improved efficiency for lighting, ventilation, and building codes. There are some parts of commercial, some end uses in the commercial sector that are increasing, in particular computing power, that end use is increasing. But we're seeing the gains from energy efficiency, at least up till now, outweigh those other areas that are increasing. And this continued improvement in energy efficiency is expected to continue through the forecast period. And it's bringing that curve down for commercial. Just also following up to the BCUC question about codes and standards, we do have a well-established, long-standing practice of evaluating the codes and standards savings at BC Hydro. We do file these evaluations with the Commission, and we have been doing that since an order from the 2004-2005 revenue requirements application. So these evaluations, a summary of them, are filed every year with the Commission if people are interested in reading them. And they measure the effectiveness. They don't attribute savings to BC Hydro activity. They just measure, did the efficiency occur? And if so, how much relative to what we expected? And what you can see here, there's variation between the line items. Some performed better than expectations, some performed lower, but overall, they performed about 93% relative to expectations. So a reasonable performance relative to expectation. The codes and standards in our load resource balance, another reason that we feel reasonably confident with the energy efficiency there, our own evaluations, of course, what we've seen from the industry as well, and also the fact that we only reflect codes and standards in the load resource balance if they are enacted or approved. So we don't have proposed or under consideration codes in there. I'm going to wrap this series up just by talking about load forecast accuracy and monitoring, because we did get some questions from the municipalities about this. We do have a very well established practice for monitoring the accuracy of our load forecast and assessing it relative to a benchmark, again from Itron. They also collect load forecast accuracy from all their member utilities. We assess our load forecast accuracy every month, and we compare it to the benchmark on an annual basis. We do this to improve our forecast, to look for things that we're missing. We also do it because forecast accuracy, it is important for near-term planning decisions. It's important for revenue forecasting. It's important for next year operational decisions. And this slide here has the accuracy, annual accuracy for our forecast going back to 2008. This is relative to domestic sales, so it doesn't include losses. And accuracy has been reasonable and within the industry benchmark. Although I'm proud of this, and it's something we put a lot of time into it, in my view, it's not tremendously important for a long-term resource plan, because this is a 20-25 year plan, and no forecast is going to be accurate that long. Somewhere around 7 or 8 years, the forecast accuracy it's not going to be strong. We have good certainty going into the early 2030s, and then beyond that is highly uncertain. And that's why we plan 2 scenarios for long-term resource plans. And that's why it's important to be prepared for higher load scenarios as well as the reference.
We have a question from Move Up.
Let's have a couple first on the issue of AI loads. Oh, sorry, thank you. First on the issue of AI loads, and I think you can agree we can look at cautionary tales from south of the border about the way that this has been rolled out. and try to learn some lessons. And to sort of frame my question, part of this was sort of poked at in the workshop questions that we submitted. Perhaps two different strategies to deal with these, what might be problematic large loads, site loads. One would be a focus on individual loads, dealing with siting, scaling, other issues to rationalize their integration of the grid. And the other might be sector-wide strategies, probably not mutually exclusive. And focusing on that, has BC Hydro contemplated proposing a new customer class, including AI data centers or other large volatile loads, or other rate design type strategies to help insulate other customers from the impact of these loads?
I don't know that that's an IRP issue, but what I will say is that for long-term planning, we do have this policy. It is specific to AI data center loads. This is the provincial regulation. It does treat them distinctly, and it provides an allocation as to how much we can serve. It also has a competitive process, and this is for the new customers. To bid through that process, the proponents are assessed on impact on the grid, so the interconnections, as well as there's a premium over the standard tariff rate. They're curtailable. They have to be willing to commit to curtail. So this process, although it's not a rate class per se, they're still considered transmission or general service customers. They are treated distinctly on location, rates, and interconnections. There's also a economic development and community benefits portion to it.
Yeah. I probably agree that the arrangement put in place now isn't going to be there 10 years from now. Very likely. We could speculate. Just wondering, assuming that they're not going to be contained in this little package in the longer term, and I do think it's an IRP issue, frankly. Are you contemplating different kinds of rate design tools? Is BC Hydro looking at what will follow this? Are there strategies that will outlast the sort of interim things that have been put in place by the government to try to restrain the impact of these loads? I don't want to go on too long, but also bearing in mind the federal government has also announced an AI strategy. Maybe there's a bubble that's going to burst next week and all this will collapse in rubble, but perhaps not.
Yeah.
The chair wants to speak.
Sorry, go ahead. I think, Mr. Quayle, what I can say is this is an area that is in the stage of infancy in BC. And what the government has done is put together a very practical and thoughtful framework that allows us to actually explore these loads in a measured fashion. And as Anthea talked about it, from a load forecasting perspective, it's challenging because historically load forecasting is based on industries that can take 10, 15 years to develop. And these loads are showing up in a period that doesn't align with the traditional planning processes of the utility. So I think this 400 megawatts of allocation is actually a very practical approach of doing things. And as Anthea mentioned, it also tests the premium level that the customers are willing to pay for that service. I think beyond that, it's still up in the air in terms of, I think we still are in the very early stage of doing the studies for those submissions that we received. We hope that by the end of the year, we'll be able to award those agreements to those customers who have submitted. And then as the 2-year comes to an expiration, then we'll have to figure out what the future framework looks like. So I think at this point, that's a policy discussion that has to happen between with the government, and maybe we'll see how that evolves as we get the experience of the first call.
Great, thank you very much. Second thing, a specific question about residential cooling loads, and this was slide 34. I don't think you need to turn to it, but talking about the relatively small proportion of your residential load that's cooling. You'll agree with me, though, that as the entry of electric heat pumps into the residential market takes over, and so people's homes are equipped with cooling facility, where people now might just sweat through the hot summer nights, they will be engaging their heat pumps, and your cooling load will become proportionally larger as heat pumps displace current systems. Is that a reasonable assumption?
Just before we leave AI data centers, it's my understanding of the regulation that there is only up to 600 megawatts allowable under that regulation. There's no, that prohibition continues after. So there's no, at this time, there's no policy framework for another big wave beyond 600 megawatts.
No, I understand that, but sort of seeing this elephant lumbering into the room, I assume you're giving some thought to what's going to happen when it doesn't fit in the room anymore. That's really what I was wondering. Are there issues of cost allocation, rate design, things like that that might help to provide tools to deal with stuffing the thing in there before we all get squished under its enormous weight? Anyway, just the other question is the
okay. Don't go too far into the poetic side of it.
That's it. And it's early in the morning for me. No, but on the question of cooling loads, we could expect that to become proportionally a larger load as electric heat pumps become more ubiquitous and as climate change becomes more and more significant.
We do have here the forecast shares for cooling, and we are forecasting in the reference forecast that 32% share for portable air conditioner and 21% for heat pump. Portable air conditioners really are where the uptake has been. You know, they're relatively cheap. You don't need to rewire your home. They can make one room or two rooms comfortable. And that's where we've seen the big increase. And so, yes, we definitely are seeing them increase. As I mentioned earlier, they're not a huge impact on energy overall because our cooling season is quite short. The exception being the South Interior, where there's a lot of central air conditioning, at 50% central air conditioning in the South Interior. But in the South Coast, we're seeing more of these single unit cooling, like ductless heat pumps and portables. And it's only about, on the residential side, about 3% of load of energy. And because we are a winter peaking utility, it's not showing up as an impact on system peak. All that said, yes, people are definitely getting more of these cooling technologies.
And I gather that all of the economic forecasts that your IRP is founded on predate the military adventure undertaken by the Americans and Israelis in the Persian Gulf. That is the data that your analyses rest on. I know you have a February 2026 forecast, for example.
The Wood Mackenzie, are we taking this question now?
Oh, I was going to answer it for you, but that's all right. But I'm just thinking about slide 22, where you do try to talk about Wood Mackenzie.
Yeah.
You must be aware of that.
We had an interesting session. Am I going the wrong way? Sorry, I'm going the wrong way. We had an interesting session from Wood Mackenzie also last week that reflected some of what's shown in their outlook here about the impact of the disruption to oil and gas on our LNG sector. Okay, I'm back to it now. And so their knowledge and the information here is very current, and it's considering the situation with the global supply of oil and gas. And they are seeing that situation put a lot of momentum for BC LNG and make it a lot more attractive. And we're seeing milestones on BC LNG weekly now in terms of progress. They also mentioned the potential over the long term, though, of this demand erosion. And if the disruption continues for an extended period of time, countries that rely on imports are going to be highly motivated to find alternatives to importing oil and gas. So there's a long-term risk.
So right now, everybody's looking for other sources. You're stuck with natural gas as your system. So suddenly North America is sitting pretty. Meanwhile, all working to disengage from reliance on fossil fuels. So swing between the short and medium term. I pity anybody trying to forecast anything today. Good luck. That's all.
Thanks. I may just jump in here. Oh, you're fine, but it's a follow up on this very area. So sorry if I'm cutting in on other people, but Mr. Quayle took us right to the area where I had was hoping would be explored, and that's on this slide. And it's just so I had a different take on this slide from Mr. Quayle. In forecasting, a term we use is called immediacy bias. Maybe you're familiar with that. And so, the idea that whatever just happened drives us to change our forecast. And there's a few cases where, we see this happening. And I know it's a difficult question because should you change? Should you ignore completely? For example, the federal government changes a policy on electric vehicles. What's going to happen next year? And so on. But in this one here, I was troubled by the Wood-Mackenzie, your downside risk. It didn't work for me logically, and I'd love to have it clarified for me to be corrected, because first of all is the assumption that we could have extended disruption of global oil and gas trade. So I'm wondering how you define that, or how they define that, because, for example, we've had oil price, and in some cases natural gas crises and disruptions in 73, 79, 91, 2003, 2022, 2026. Do you consider that to be an extended disruption of global oil and gas trade? Like, in other words, we have these things all the time. I'm just curious.
The way that Wood-Mackenzie described this, they developed at least three different outlooks for the oil and gas sector for BC. The chart here, the one that I'm showing, is their kind of expected outlook, which is that the conflict in the Middle East resolves this year. They also developed this other scenario, which is that it lasts for years, that conflict in the Middle East lasts for years. And as a result of that, prices for oil and gas continue to increase. And then countries start looking for alternatives, and there's a cost motivation to develop domestic resources more. And it could even be things like domestic coal or domestic coal bed methane, or it could be clean resources such as solar, wind, and batteries. So that's Wood-Mackenzie's view, that they didn't see that demand erosion. That wasn't their likely scenario, to be clear. That their expected is what I'm showing on the graph here, but they were flagging it as a possibility.
But extended high prices globally for oil and gas, I mean, isn't that the narrative that our federal government and others are using right now for why we would expand the development in Canada and British Columbia, or Canada, of oil and gas resources? In other words, yes, globally, you might have higher prices, and that's good news for Canada because we're less disrupted than others. So I just had trouble with the logic here. It seemed to me it should be the opposite, that an extended disruption of global oil and gas trade would lead globally perhaps to reduced demand, but actually could lead to increased demand for Canadian supply. And in fact, that's the narrative I'm hearing from the Canadian oil and gas industry and the federal government. So I'm just saying that, and this isn't a critique of you, I'm just trying to figure out how Wood-Mackenzie put this together, because it just has trouble for me as a former forecaster myself.
And they are a global forecaster, so I certainly could have taken their text here out of context. The forecast that they walked us through is a North America forecast. So this downside risk, they didn't specifically peg it to BC. So yeah, it's certainly possible that the higher prices, we only have so many proposals in BC for LNG. There's only so many, right? So it's not there's a small number of proposals, and if they can benefit from the high prices and they can lock in customers, then we can expect them to proceed.
Yeah, or more of them will even happen over the long term that you're talking about, because it's euphoria. Alberta says, let's go build another oil pipeline, and other people want to build another natural gas pipeline across British Columbia. Anyway, I won't dwell on that anymore. Thanks for your time on that, and I'll let it go back to the sequence, Mr. Bear. Thanks.
I believe we have a question online from the Clean Energy Association of BC.
Yes, we can.
This slide here shows our reference load forecast. Later today, we'll talk about the other load scenarios. The other load scenarios use various approaches to large industrial load, and some of them explore higher mining load futures and also lower. The reference load forecast method for large industrial is described in Appendix A to our 2025 IRP. And I don't have my binder with me, but if you go there, what you'll see is a table that walks through the probability that is assigned based on milestones as a project proceeds through those milestones. And they include interconnection status, environmental assessment certificate, construction delay risk, etc. And that's the method that goes into the reference load forecast.
I'm just, because we've seen how you adjusted the process for AI to account for the uncertainty, the increased focus on AI at the moment. So I'm wanting to dig into why that approach hasn't been applied to mining, and or if you did consider things like the expedited environmental assessment processes, the permitting support, the sort of all hands on deck focus that we're seeing from the province and Canada in terms of moving these projects forward, and if there was any consideration to how realistic, I guess, sort of that traditional focus on development milestones was, and if there was any accounting for the extreme push for expediting these types of projects that we're seeing.
In the next section, I'm going to talk about our higher mining study and our additional load scenarios. And certainly mining is an area where growth could be greater than what our reference load forecast indicates.
So it sounds like the reference load wasn't adjusted in any way to account for what we're kind of seeing on the ground in the mining space with respect to expedited permitting, significant numbers of projects trying to come online kind of in the next 3, 5, 7 years.
For the reference load forecast for mining and for the other large industrial sector looks at every single project proposal, every existing project that we're serving right now, and every single proposal that we have is assessed individually based on its progress through milestones, and including any fast tracking that might have happened that could accelerate its progress through those milestones. That method is well established for large industrial. The reason that we moved off it for AI data centers is because that sector moves much faster than a mine, much faster. A mine isn't going from discovery to production in 3 years, but AI data centers are. So we did miss AI data center load in the 2025 reference forecast, and we needed to address that. Mines are an area of tremendous potential for BC. There's a lot of upside load potential, and we do illustrate that in the higher mining study that we provided in our May letter and in the higher load scenarios. And certainly mining is an area of a lot of growth for BC.
But again, when you're looking at the forecast load, I mean, was there any discussion with like the critical minerals office? Because, you know, completely agree. I don't think anyone would disagree that from discovery to development to production, that's a long timeline in mining. But we are seeing a lot of projects that are closer to development than the discovery stage. And a lot of those may not have submitted the studies request to BC Hydro, but are in a very advanced discussions with the province on the permitting space. So again, was there any work done with the province there to identify, again, these projects that might not have hit BC Hydro's radar, but are going to come at you fast and furious and with a lot of momentum and support from the province and the feds?
Yeah, we are very excited about the mining sector, and our higher mining study considered some of the mines that are pre-interconnections. So those are some proposals that haven't yet made it into our interconnections process, but we are aware of. Did you want to add?
Okay, perfect.
I think the other thing I would. Yes, done, yes. I think the other thing I would add is, as Anthea was talking about the reference and the high load forecast. If you look at the near-term actions in our IRP, they allow us to actually look at both the reference as well as the high. So we can pivot to the high depending on the load forecast that sort of we see and the progression of it. The second thing I would mention is load forecast is an exercise we take on an annual basis. The IRP has a multi-year cycle, but the load forecasting and the capital planning that BC Hydro does internally is on a yearly basis. So if we do see things moving in a direction that's different than the last load forecast, it's reflected in that next version, and we do take appropriate actions around that. So I think the key point we want to make over here is the near-term actions in our IRP are not purely driven by reference. It's driven by a combination of reference as well as what's required for the high load forecast. And I think the last thing I would say is, you mentioned about some of the mining proponents have not done the studies. I think my encouragement would be to put those studies forward to BC Hydro, because actual interconnection of those mines happens through a study process where we look at the interconnection of those individual projects onto our regional system, because typically they'll be supplied to that. So I think that picks up the fact that we actually have to do some reinforcements. And that's a capital planning process that is driven by the actual requests that we get, whereas this is a more of a planning process around the load forecasting that drives the overall bulk system requirements. But the regional transmission system is affected by those actual requests that we get from the different proponents, whether it's mining or LNG or oil and gas and others.
Perfect. Much appreciated. Thank you so much.
Mr. Chair, I'm just mindful of the time. I see we're about 10 here. We have a few more people that are looking to ask questions. So in your hands as to when you'd like to schedule a mid-morning break.
Right. So we're going to break at noon, about around noon. Yeah, maybe let's take one more question and then take our break.
Thank you. Next question is from Mr. Craig with the Commercial Energy Consumers Association.
Thank you. I've got two quick areas to discuss. I'll try and be efficient in the process. First one is slide 20. Dealing with the impacts of large customer loads. I'm interested in whether or not BC Hydro recognizes the potential for these big loads to have rate impacts on the residential, commercial, and other industrial loads when they come in, and whether or not you are looking at those impacts and anything that might be done to limit impacts or otherwise manage them.
BC Hydro has an obligation to serve new customers, with the exception of those restricted by policy, such as cryptocurrency and AI data center beyond 600 megawatts. We have an obligation to provide non-discriminatory service, and our forecast considers all of our customer requests on that basis. We do know that the cost of marginal supply is higher than our embedded costs, and there will be costs of growing the system. Affordability is very important to BC Hydro, and through the segments that follow, we'll discuss how we're managing and trade and off rate impacts.
I'll switch to the second issue is data centers, maybe slide 24 or 27. And when it comes to adding data center loads, has Hydro been considering the risk of obsolescence of those data centers when it is likely that the more cost-effective data centers will eclipse any land-based data centers when data centers are largely being provided from space?
This is a challenging sector to forecast, and I'll just walk through how we treated cryptocurrency because it's relevant to this, and we got it wrong. So we and the whole industry a few years ago thought that cryptocurrency would be temporary. We all assigned it, not just BC Hydro, but broadly across the industry, a 3 to 5 year life, and our expectation going back to 2022 was that that load would be temporary and would go away. And that's why you see, if you look really closely at the 2025 reference forecast, you see that drop. That's our expectation, a probability that cryptocurrency would not have longevity. So here we are today, and obviously that proved wrong. The industry is very strong. If BC Hydro was required to provide service to cryptocurrency, there would be a lot more. So we don't know, obviously, what the future is going to hold. But assuming that the customers will close, unless we've got expertise or indications that they will close, which we do use for our existing customers, where we've got market expertise and we understand their viability and their economic outlook, we'll put a probability of closure. And we've got insight of that nature for forestry, for mining. We don't have that for AI data center. We really don't have visibility into their individual business model, profitability, and long-term outlook at the individual customer level. So given that, for now, we are assuming that those loads stay.
Thank you. I just think that these issues are quite substantial issues with some big strategic impact, and I'm looking to explore them more over the course of workshops and anything that we file with the commission.
Yeah.
Thank you for the opportunity to speak to that.
Thank you, Mr. Craig. Okay. Not sure what's caused that. So yes, let's take a 15-minute break. Is there a clock here somewhere? I don't trust my watch. Oh, okay. So we'll start at 10:30. Should reconvene. Thanks.
just a minute here. I just wanted a quick reminder, when speakers are finished speaking, it'd be great if you'd be able just to turn off the microphone so we can hopefully avoid some of that feedback that we were experiencing. And with that, I can call the next party for questions, Mr. Chair. Next is WeCan, I believe.
I do have 2 points of clarification that I would like to make before we continue with questions, if that's okay.
Yeah, go ahead, but you can stay there. Yeah, go ahead.
Thank you very much. In the opening exchange with CEBC, it was commented that the BC Hydro Build Wind, or at least what I heard, was that the BC Hydro Build Wind was not disclosed. We would like to go back to the record to clarify that it was. Our near-term action in the 2025 IRP states the 25 element to prepare to acquire and or build additional clean or renewable energy resources to meet the need indicated by subsequent load resource balance updates. We also addressed BC Hydro Build Wind in 2 BCUC information responses, 1.12.2 and 1.12.6. I also have a clarification from my own comments. I was talking about the higher mining study, and I recall I mentioned that it included projects that had not yet entered BC Hydro's interconnections queue. I think that's what I said. I want to clarify that all of the projects considered in that study are projects that have been in communication with BC Hydro. They might be at very early stage of development, but they've been in communication with us, so we do know their location and their expected load. Thank you.
That's it?
That's it.
Please identify yourself again and go ahead.
Thank you, Bill Green, WeCan, West Coast Climate Action Network. Thanks for the excellent presentation and, of course, the excellent underlying forecasting. I have 3 areas of question. I think they're pretty simple and straightforward. One is pertaining to 22, to 30, and to 40. So question with respect to 22, and the reason for the underlying reason for this question is that, of course, LNG, the forecast load growth for the LNG sector is a very huge contributor to overall load growth, so important to understand that. I think my questions don't push into commercial confidentiality because I think it's all information that's in the public realm, but want to just clarify what I read into this graph and what you presented. One is that one of the assumptions is that 5 current projects are proceeding either certainly or highly probable in the case of 2 that are pending FIDs. The second underlying assumption is that per policy and commitments that all are electrified liquefaction with the exception of possible exception of Canada 1. And thirdly, this graph that no additional LNG plants beyond the 5 are currently in the forecast.
I do not confirm that. This slide 22, this is Wood Mackenzie's outlook. There's a market expert that we work with to get their expertise on what their view of what's happening with BC LNG. They also do global LNG. So slide 22 is not BC Hydro's load forecast. It's information from a market expert that we've provided to in response to the move up question. Our forecast for LNG is on slide 21. Our approach to forecasting LNG and other large industrial loads uses a risk adjustment. We consider the probability of projects proceeding based on the certainty of that, considering milestones such as their position in our interconnections queue, whether or not they've started construction, they have their permits. In the case of LNG, there's also a lot of information from market experts and others on the status of their offtake agreements, their financing, pipeline construction. So LNG projects in our forecast are risk adjusted.
Okay. Can you say anything about the electrification per policy and commitments that have been made publicly? can you say anything about the liquefaction trajectory, if you will, or the electrification of liquefaction?
Well, I can comment on what's already public about the large LNG proposals in BC through the environmental assessment process for those proposals. They have indicated the approved technology as per their environmental assessment process, and that information is available. So LNG Canada has permits for electrification of balance of plant for both phase 1 and phase 2. They are permitted to go ahead with balance of plant, which means it would be natural gas for the liquefaction. Silicims also has on the environmental assessment process their design approved, and the same for cedar and wood fiber. So that information is available for your interest.
But maybe I can help out here. Do you assume they will all be electrified then? I think that's what you're trying to get at.
Yeah.
We do not.
Okay, and that you put a probability on it, is that how?
We consider our starting point is the request for service that they've asked from BC Hydro. So how much power have they asked for? And that generally aligns with their environmental assessment approval. And that's what we've generally seen. So in case of LNG Canada 1 and 2, they are fully permitted for electricity service for balance of plant and gas for liquefaction. And for Silicims, it's public knowledge that they've requested 600 megawatts, which would be an electrified full facility. So we start with the request for service that they've provided to BC Hydro, which doesn't always quite match the environmental assessment because their design could have changed. But broadly speaking, the designs are consistent with the environmental assessment approvals.
Thanks. Second question pertains to slide 30, light-duty electric vehicles. You noted in your comments several, I think, very recent upsides. One is cheaper vehicles, and two, well, just observed recent uptake. I just want to clarify that those recent upsides are not reflected in the February 2026 reference, given the date of it and what's happened subsequently.
Well, if you look, you have to look quite closely, but you'll see that over the near term, the 2026 reference is a little bit higher than the 2025 reference. You kind of have to squint to see it, but it is there. And that higher forecast over the near term does reflect some improvements to the economy relative to our outlook back in 2025, some expectations of these incentives coming back, and the lower priced electric vehicles. The forecast was completed in February, by which time the federal policy was known around the change to the import tariff and the change to the targets. And there were a number of questions, I believe, on that topic.
Okay, you have to point me to it because February 2026 shows 10.4%. May 2025 shows 11.3. So I'm trying to understand that.
That's the average growth rate over 50 years.
Okay.
And it's the 2026
right.
forecast is lower than the 2025 because the ending point is lower.
Right.
If you look at
I see that. Yep. Thank you. And finally, with respect to 40, I'm just trying to understand whether comparison between the load forecast and actual temperature normalized. So the load forecast here is DSM adjusted load forecast, or that is load forecast pre-DSM?
This forecast would be done for financial purpose, so it would be after demand side management, and we'd be comparing the forecast after demand side management to the sales. Because the sales are after demand side management as well. They reflect.
Okay,
actuals.
just wonder if they were
It's before
comparable.
losses.
Right. Thank you very much.
Thank you.
I believe the next question is from Mr. Lesney at the Clean Energy Association of BC.
Thank you.
because you gave a clarification, before I get to my question, I might come back to it. And I'll have to review the record to make sure I understand. I think maybe a misunderstanding a little bit when BC Hydro says build wind. Are they talking about the full development cycle? So this would include partnerships with local communities and First Nations, the planning of the project, the development, the procurement of both long lead items and the build, and then service agreement over the whole time? Or is it just looking at the back end build as in like physically construct and operate? And the reason why this kind of question comes in from an IRP point of view is these are very different capital requirements from a resource. There's rate regulated capital, which has a lower risk because it is looking at longer term, versus development capital, which has a higher risk and a higher return, and also needs to have, in this province, a very strong partnership with First Nations and local communities. So just trying to understand that, and I'll go back and review the noted comments too. So when you're saying build, it's the full gambit from early development right to operation, maintenance, decommissioning.
That's right. So it'll be something similar, akin to our capital project that we do in BC Hydro. So if you are developing, let's say, a generation resource that is not wind, this will be a similar approach that we will take towards the wind project, where we will take the lead in it, we will plan for it, we'll execute it, and it'll be BC Hydro's capital that goes towards it, in partnership with potential developers who have insights in terms of where the wind potential is.
Okay, thank you. One of the areas that we're seeking clarification on is when looking at the forecast and what's going forward, and this kind of ties somewhat to the asymmetrical risk that you talk about. Is the forecast kind of derived to what is connectable in terms of the regional power system and the bulk power system's ability to connect the load requests? Or is the load forecast kind of divorced from that and saying this is what the desire to connect is, that we're trying to build out the system, and therefore the plan in the IRP is trying to meet that desire to connect? And there just seems to be times when we're reviewing the details that we get a little confused on, is this low growth waiting for a major transmission line to come into service, or is the low growth what is asking to get there, and the transmission is a solution to meet that low growth?
So I think it depends. So if you look at the load forecast that Anthea talked about, in some cases that load forecast may not drive any transmission requirements because we may have capacity for that load forecast. In some cases, the load forecast that we are putting forward may be in areas where we have a regional or a bulk transmission constraint, which will drive that upgrade. So I think it all depends on how the load forecast impacts the existing transmission system. And maybe I'll just give you an example. In terms of as the load forecast for North Coast evolved, and we had a North Coast scenario that's outlined in the plan, we quickly realized that the transmission system is not able to actually deliver on that load forecast. So that's why I talked about those two projects on the North Coast. One is an optimization of our existing 500 kV line, which was our starting point. So which took the capacity of the existing line from 800 to about 1400 megawatts. The load forecast is actually higher than that. So we knew that we can't optimize this line to a point where we can serve that load forecast. That's why we proposed the second line. So I think it almost thinks you have to think in terms of the load forecast is what it is based on our best understanding of how the industry is going to evolve, both on the commercial, residential, as well as on the large industrial side. And then we translate that into an impact on our transmission system, and we figure out whether an upgrade is required or the existing system can actually serve that load.
Okay. That's helpful. I guess the other then clarification that leads to, and it was part of my colleague's questions on mining, but going further, is talked about how the reference scenario, high scenario load, the planning's done to all of them, but given some of the pre-workshop submission updates, seems to be a little bit more reactionary to, we have a new update, now we need to do this. For example, extending of agreements for gas-fired generation in the province to meet peak demand and operability challenges, some of the upgrades to other BC Hydro equipment. And so it doesn't seem, it's not clear how there is what is the typical kind of viability and scalability of solutions. So for example, back to your North Coast, the transmission system can't keep it. Would not BC Hydro, in kind of meeting the objectives of connecting these customers and supporting the economic growth, look at scalable solutions that might be transitory? So whether it's non-wire solutions, local generation and stuff like that, while which is probably the biggest difficulty of any electricity system, one being the load growth and forecast being off, but the other being it takes time to build this stuff, and therefore need to have almost like a stepped, again, scalable solution in terms of where it's going.
Absolutely. And I think, again, let's use the North Coast as an example. I remember when I joined planning almost 20 years ago, the planners actually showed me the plans for the North Coast, which required a second 500 kV line to be built in the 70s or early 80s. So the planning is always there. The question is, are you going to invest billions of dollars on something that may not materialize? Because the load in North Coast is starting to materialize now, as opposed to when we planned for it in the 70s and 80s. So I think from a planning perspective, we have a lot of options on our transmission system as well as on our distribution system that allows us to actually look at different scenarios. We have to be very prudent in terms of our investments because we have to balance that against the affordability and to make sure that the impact on our ratepayers can be managed, because that's a objective that we have as part of our organization, and making sure that the planning doesn't impact that in an adverse fashion. If you look at North Coast, we started off with that series compensation project that I talked about in the early 2010 because we knew that the loads were going to materialize. Unfortunately, the pacing of those loads slowed down. So we had to pull back on that project. And when now the loads are starting to show up again, we are moving forward with those projects. So I think it's a fine balance between knowing what those options are versus when do you actually move forward with that project. And I think we are finding that balance in this IRP because historically, when Anthea showed that graph, most of the utilities in North America had a flat load growth over the last 10, 15 years. So it would have been imprudent on our part to actually invest in capacity when the load was not growing. And as the load is starting to grow, we've taken a very proactive approach towards our load forecast. The reference load forecast in the IRP that we initially submitted did not meet the expectations as the load has materialized, and that's why we had the update. So I think it all depends on where the load is going and how quickly we can maneuver to that. But the planning solutions are very well understood. It's a question of actually making that investment towards those updates.
And I thought actually on the previous section, the explanation on where the forestry has gone and kind of buying time for the inherent load growth in the system was a great example. I guess the last one, just on clarity, is you talked about managing those risks of overshooting or underbuilding. And I think there just probably needs to be more clarity on how BC Hydro looks at using risk assignment between rate regulated investments, which you're essentially stuck with throughout, but can be very beneficial because it comes at a lower cost of capital and is publicly owned, versus pushing some of those higher risks onto private capital and onto the actual consumers themselves. And we've talked about AI and LNGs and maybe looking at longer term demand contracts and whatnot and helping that. So just trying to understand in terms of how this all interacts with your uncertainty and ensuring that risk allocation between the two is done properly. Thank you.
Yeah, we were wondering if there was a question there, but I must say I enjoyed it because it was in the 1990s. I did two inquiries, one as a commission and one as a task force for the government, in which we were just talking about risk between private investment and public, and it's an issue that's still with us today. I don't. So I was interested in you raising it, but I agree that it's not something we can go into great detail in this BC Hydro IRP process, but it's a legitimate question. Okay, next.
Next is the City of Vancouver, and I would also ask that the speaker introduce himself before asking his question.
Hi, apologies, I was late this morning. Matt Horn, City of Vancouver. I'm here on behalf of the local government interveners. I had three questions related to the air conditioning slide, which was 24, I believe. Yep. Oh, 34. Yeah,
34.
Sorry. Yeah, I read that wrong. First, maybe if you could just elaborate a little bit on sort of what's going into that forecast. It's saying, I guess, 53% of households would have air conditioning in 2050. It seems low to me. Like, I think last year Hydro published some survey information saying 70% of British Columbians have access to air conditioning already. So I'm just trying to understand what's informing that forecast.
The way that the forecast is built up, which is a little bit different than when you report on how many people have an AC, is it looks at the overall account, the average account, rather than the number of units that you've got. So considering an average account across our service territory, on average, there's 32% portables and 21% heat pump on average. So it's a little bit different than the number of people who have purchased a unit.
Okay, maybe just make sure. Can you what percentage of households would have access to air conditioning in 2050? Is it possible to sort of flip that around that way, or?
So in this forecast in 2050, 32% have portables, 21% overall have heat pump.
Okay. Second question, the numbers there in terms of the 200 kilowatt hours and 300 kilowatt hours, are those forecast to increase over time as temperatures get warmer?
So the way that our forecast works with respect to temperature is that we use the most recent 10-year period as our temperature normalization, and we forecast based on the most recent, that's what we define as normal temperatures. We do know that summertime temperatures are warming, and it is certainly possible that the need for cooling could increase. One thing that some utilities are starting to do is to put a temperature trend into the forecast. That's still early stage of forecast practice, and we are not doing that at this point, but it's something that we're keeping an eye on. But for now, at least for the forecast that we're presenting today, it is the so-called normal temperature. The average temperature is the average of the last 10 years. So it does, every time we do a forecast, it does update as it's a rolling average, but it's still reflecting the most recent history.
Okay, thanks. That's clear. And then on the heat pump air conditioner part of that, the 21% by 2050, just trying to understand how this relates to heating. Are those same heat pumps also being used for heating? And how does that connect on the heating side of things?
They are. So I could use my binder at this minute, if you don't mind. I'll leave my All right, so yes, we do have, the question was about whether they're used for heating. So we have, we have assumed that for zero carbon building code, that's where we're seeing, we have assumed it's 100% heat pump for households that are under zero carbon building code. And yes, they are used for heating and for cooling in that instance. And generally we do see heat pumps used for heating and for cooling both.
So this 21% share is largely being driven through new construction?
We have currently heat pumps across our whole service territory at 8% penetration. So the increase to the 21%, that is, sorry, sorry, I misspoke. That's Lower Mainland. It's 12% currently across the whole service territory for heat pumps, and it increases to 21%. And that, yes, that's primarily due to new construction. Vancouver Island is interesting. Vancouver Island, it's at 27%. So heat pumps. So we have seen a great increase in penetration of heat pumps on Vancouver Island, but across the whole system, we're currently sitting at 12% and expected to go up to 21%. And yes, that is it'll be used for heating and cooling.
Okay, thank you.
Thanks. I'll just follow up on that then to be clear. For residential space cooling, you're not yet forecasting, including in that calculation, a rising temperature to the year 2050, a rising ambient temperature, and likewise for commercial cooling as well, commercial HVAC. So I'm just curious.
Yeah, that's correct. Our normal temperature that we use for residential and commercial is based on the last 10 years for energy. We haven't built in a temperature trend. The temperature trend is not widespread in load forecasting. We are aware that some utilities are starting to do it, but it's not widespread. The 10-year average remains the most common temperature normalization period, so it is the industry standard. But we are monitoring the temperature trend because we know, in particular, summertime temperatures are getting warmer, and we could see the need for space cooling go up.
Yes, and always the challenge with forecasting is whether you just look in the immediate past or actually interact with scientists and others who might give you other information. But anyway, back to Mr. Bear. Yeah.
Next is Mr. Manhas for the Association of Major Power Customers.
I just had a couple of questions, perhaps on the other side of the coin of Ms. Spencer's questions to you earlier this morning. And it's on the question of interconnections. I understand from some of the BC Hydro IR responses that the load forecast takes into account interconnection timelines as part of the forecast. Is that right?
For large new loads that are seeking to connect to our system, we do consider the status of where they are in the interconnections process. So that is one input. And we do start, though, with their requested time to in-service and consider potential for delays related to construction or legal risk, for etc.
And does that assessment include BC Hydro's estimates of how quickly it can allow the interconnection to proceed within its own processes?
The time to interconnection can be a consideration for some of the projects, yes.
And in making that assessment in terms of future load growth, has BC Hydro made any adjustments based on the significant amount of both new load and new generation that's coming online over the next 5, 10, 15 years?
We assess every proposed new project individually. There isn't a bulk adjustment. It's an individual project by project assessment.
And so at this point, the load forecast is not tied to any sort of assessment of BC Hydro's own timelines that it expects to be able to interconnect this new load up in the coming years.
The reference load forecast does consider the customer's status in their interconnections queue, how far, this is for a new customer, how far progressed they are through that interconnections queue, the most likely expected in-service date, considering both their proposed in-service date as well as any construction delays that might arise or legal challenges or other things that can delay a large industrial project from reaching service.
So for projects that are fairly long in the queue process, you have fairly good certainty about timelines. Is that fair?
Well, customers can have their own timeline considerations independent of BC Hydro's interconnections queue. And, we do have a number of projects that are through their queue, a number of them, but they have not made their final investment decision to go ahead. They have their own commercial considerations that they have to take care of and their own decisions to make. So there are a number of large projects that have completed our interconnections queue and have not proceeded to final investment decision because they have their own business decisions to work through.
Okay, so I understand that timelines may be extended if businesses have their own business reasons to extend those timelines. But I'm asking, I think, the inverse of that, which is, to what extent is BC Hydro accounting for its own timelines when assessing whether a customer's in-service date is a reasonable timeline to connect?
We always strive to meet our customers' requested in-service date through the interconnections process. And when we examine large new load requests, we do look individually the status of the progress across a range of factors, including interconnections. If there is a project that is proposed but very remote from the system and might require a lengthy interconnection, that will be part of our consideration, among other factors such as the customer's time to construct and make their business decisions.
When you say that's part of your consideration, can you please explain how you consider that as part of the process?
We would make an assessment. Every time we do a forecast, we'd make an assessment of the status of a proposed new project and when we realistically is probably not the right term, but when is the expected in-service date, considering the status of their final investment decision, the status of construction, and the time to interconnect, if that's relevant.
And is it your understanding then that project, or flip that around, in your experience or in your analysis, have you considered the extent to which projects are delayed by interconnection timelines with BC Hydro?
We're certainly aware of a lot of projects that are ready to connect that are not yet ready to go on the customer's side. So there's a number of factors that impacted a customer's decision of when they're ready to start operating. Interconnection time can be one factor, but there's a whole broad range of other business decisions as well on the customer's side.
I take your point on that, but my question is, are you aware of situations where the customer is ready to go and BC Hydro was not in terms of the interconnection request?
I'm aware of situations where interconnections has taken longer than the customer's initial request.
And how has BC Hydro accounted for the significant increase in demand on its interconnections process arising from the new generation and new load that it's anticipating will be coming online in the next 5 or 10 years in that assessment?
Well, we look at every project individually, and we individually assess based on its location and its status through the interconnections queue and its construction. So it is an individual project by project assessment, and some locations are going to face more constraints than others, and some businesses are going to face more delays or time to construction than others. So it's not a global process or a global adjustment. It's very site and individual project specific.
And so, with respect to some of the very early stage process projects that you've discussed, is that just BC Hydro's judgment that's being applied in the load forecast? And that's the basis on which you establish the timelines?
Our large industrial load forecast method, it was discussed at length in the last IRP, and I'll just summarize it a bit for those who didn't go through that process with us briefly. For large industrial projects, we rely on a range of information sources. We've got our own internal information sources, such as our interconnection status, our key account managers, and our business economic development team that connect directly with the customer. We've also got market experts, such as I mentioned, Wood Mackenzie. These market experts look at the prospects for individual natural resource projects, so individual LNG terminals, individual mines, individual natural gas plants, and they have their assessment of when it will come into service based on the market conditions and the outlook for that business. That's an input to our forecast process. We also consider observable external milestones such as the status of permitting, any outstanding lawsuits. So we use a range of information sources to assess the most likely or the expected time to in-service. We update the forecast every year, and if a project moves through those milestones and becomes more certain, then the forecast load will increase, and that's what we've seen happen on LNG this year. Some projects drop out. Many projects drop out. They enter our interconnections queue and they don't complete it. And that's, I guess, the nature of taking the risk on a new business. Not every venture makes it to operation.
Is it fair to say that as part of this load forecast that's presented in the current IRP relative to what was done in 2021, there's been no change on BC Hydro's approach to assessing its timelines to interconnect in evaluating impacts to the load forecast?
I'm not sure about that, because we are looking, it's very project specific. So it's not that there is a global measure, it's very project specific. And one project may take longer now. It might have been a different project in 2021, might have taken shorter. So it's a very project specific assessment. And even within one project, a lot of projects will have multiple stages of interconnection, and we look at each individual stage and we assess it individually in terms of its timeline to connect. So that method of assessing each proposal, each stage, each interconnection request individually, that hasn't changed.
Have you adjusted in the current forecast the timelines to interconnect relative to the forecast that was presented in the 2021 IRP, given the significant increase in demands on BC Hydro's interconnections team as a result of new generation and new load that's anticipated?
Well, there are hundreds of service requests in our queue, and some of them may be taking longer to connect, and some of them may be moving faster. So I can't speak to, and I won't remember every one of the hundreds, but there's no global adjustment in the sense that we're not saying globally we're assuming it takes X years longer. It really is an individual assessment, and the time to interconnect is going to vary based on where that project is, what's going on around that project, and the state of the electrical system there.
Okay, thank you.
I believe we have a question online from Mr. Ince with the Commercial Energy Consumers Association.
Yes, thank you, David Ince. Thank you to BC Hydro for the excellent presentation materials and answers so far. I've got a couple philosophical questions regarding the load forecast. And Ms. Jubb, I'm glad you touched on the subject of climate change and the effect on the forecast. And I note that BC Hydro is not considering a trend at this point in terms of how the load forecast would change with obviously increasing temperatures. But 2 years ago, and this is in the Technical Advisory Committee meeting number 2, BC Hydro presented some very detailed climate projection studies. This covered both temperature and precipitation. And yes, the major outcome of these studies was that temperature was going to increase, and mostly in the winter. So that would decrease the load and the peak loads in particular, so the capacity requirements. And the second major outcome was that BC Hydro's precipitation inflows, both on the Peace and Columbia River systems, would actually increase. So there would be periods in the year, particularly the summer, where the precipitation might be lean and there might be more seasonal droughts. But overall, the precipitation would increase, which would lead to more hydro inflows, which would lead to more generation capability. Can BC Hydro reconfirm these study results? Again, these studies were done 2 years ago, although they were done, they seem to be very detailed. Thank you.
I don't have those studies in front of me, so I won't be able to walk through them unless my colleague does.
Yeah, I don't have the studies in front of me either, but what I can comment is on the references that you made to the inflows. Just a clarification that we did not say in those studies that the inflows are going to increase with certainty. It was that there was some uncertainty and that it was not dramatically different to the inflows that we were expecting right now. Additionally, I think on the peak load, again, the study shows that there's a warming trend in the winter, but again, not necessarily that the extreme temperatures would be different. There could be warm winters, but there could still be very cold days.
So a follow-up question, is BC Hydro considering revising these or updating these studies?
Maybe I'll just jump in terms of David. As you know, we have an alliance with the Pacific Climate Change Consortium that BC Hydro funds. It's based out of Victoria. And they do all the modeling studies for us for our reservoirs. You're absolutely right. The last one was done in 2024. And I think we talked about that in one of the IRs for Metro Vancouver Regional District. It's IR number 1.6.1, where we talk about the modeling and the impact on our reservoirs. I think the summary of that study was that we did not see in the 2024 study any increase in risk of our inflows for the reservoirs. And I know there's a lot of discussion around drought over the last 3-4 years, but we don't see that as a long-term trend. Just as an example, this year our reservoirs in the Columbia and the Peace region are actually much higher than they were in the years before. And there's a discussion around we might have to actually take some action in terms of the high levels of reservoirs that we currently have. So I think at this point, we don't see any concerns from a modeling standpoint, at least the last study that was done. We periodically do update those. I'm not sure when the next one is, but we can look into that. But the modeling that has been done through the BCUC is giving us the comfort that we don't see any long-term trends in terms of the modeling of our reservoirs. The second thing I would mention is we do take a diversification approach towards our energy resources. And I think part of that has been the strategy for the clean power calls that we've had, where we are looking at wind and solar as a diversification for our large hydro plants. And I think that gives us that comfort that geographically, as well as from a technology standpoint, we do have diversification on our system. And the last thing I would say, it's not IRP related, but from a power system asset management perspective, we do look at the climate change trends and come up with scenarios in terms of how do we manage the resiliency of our transmission system. And if you look at some of the new standards that are coming from NERC around the mandatory reliability standards, that talk about the impact on the power system from a temperature perspective, both hot and cold. And we start analyzing those from a contingency standpoint. So I think there's a lot of thinking around climate change that's becoming part of our decision making, not only from how we manage our existing assets, but also the long-term impact from a modeling standpoint that we have to be quite cognizant of.
Thank you. Excellent. I've got one more brief follow-up question on very high level load forecasting philosophy. Now, obviously, utilities need a planning reserve. They need a reserve margin in the event of high demand events or emergencies. And BC Hydro has a capacity planning margin of 12%. So the reserve is actually built into the planning criteria. But there's some utilities in which the load forecast includes a reserve. So, for example, the load forecast for a utility that I work for, they plan to a 1 in 10 year extreme temperature event. So again, there's two ways of doing this. You could put it in your capacity planning criteria, or you could embed a very extreme event within your load forecast. Can you tell me if BC Hydro forecast is what we used to call a P50? That is the load forecasting group 20 years from now. There would have been an equal chance of the forecast being too high or too low. Is it a forecast down the middle, and all the reserve margin or the extra padding required, is that built into the capacity planning criteria?
The forecast is not a P50 forecast, and one of the limitations or difficulties with trying to do that forecast is when much of the growth is large industrial. Those are statistical methods don't work very well when you've got 100 or 150 large customers and maybe 10 or 20 that are very high load. So the statistical methods, they work well on residential, well on commercial, and less so on large industrial. So we have an expected forecast, which is the reference, and that's to normal temperatures. So we don't do a temperature extreme in that. And then we have load scenarios to consider the other range of possible futures.
Right. So back to the question, do you think there's an equal chance 20 years from now that BC Hydro's 2026 forecast would be too high or too low?
I don't know the answer to that.
Okay.
I don't. Our forecast is it's reasonably accurate over the near term, and it has it's our expected forecast certainly out the next 10 years. Beyond that, it is hard to know from where I sit today with what I've seen going on in the industry, and going back to the opening slide for this section. It appears the pressure on load growth is up, and that the possibility of higher load growth is much more real now than it would have been going back to that period in the 2010s and the 2000s. We are seeing across the industry, just for context, our reference load forecast long-term growth rate of 1.6%. That's in the range, but in the low end of the range of peer utilities. And we did present some of that information in the May letter, that broadly across the industry, the long-term forecast growth rates are close to 1.9. So with that indication, it makes me think that the chance of higher loads materializing is more likely than lower loads over the long term.
And that gets into the question of, I know BC Hydro was reluctant to assign probabilities to the different scenarios and forecasts, but would you say that the reference forecast is the most likely forecast, and the bounding forecasts are, shall we say, less likely to occur?
Over the near to medium term, certainly out to the
long term.
Over the long term, it's hard to say. Certainly over the near to medium term to the early 2030s, our reference load forecast is our expected forecast. Going out beyond that into the future, that's why we use load scenarios. And it is important for us to plan for higher load scenarios, because the lead time for new electricity supply is long. It can be 10 years or more for some types of new resources. And that is too long to be ready if the high load scenario does emerge. So that's why we need to plan to higher load scenarios. Did you want to add?
Yeah. I think, Mr. Ince, in terms of the long term, one thing that we all have to realize is that in energy planning, it's not about predicting the future. Because over the next 20 years, it is so hard to predict the future. And one of the examples that comes to mind is like maybe 10 years ago, we were doing scenario analysis in BC Hydro for the next IRP. And we had different scenarios that had been outlined. And one of them was borders rising that we talked about. And everyone thought it was an asinine scenario, because why would the borders rise in the geopolitical situation we had 10 years ago? And we dismissed it. And look at it right now, we are 10 years down and we are talking about borders rising, and we are talking about geopolitical risk. So I think from a long-term energy perspective, it is impossible for us to say what's going to happen in 20 years. I think what we can say is we have scenarios that will cover all those outcomes that could happen, and put forward a plan with the near-term actions that allow us to actually move towards those if those become a reality. And I think that's the fundamental thing that we want to leave with you is, if you look at the actions that we are moving forward, they're not just aligned with the reference load forecast. They're aligned with the fact that the load forecast could be higher. And what is BC Hydro doing for transmission? What is BC Hydro doing for energy and capacity for us to actually align ourselves with that future scenario if and when that transpires upon us? So I think that is the fundamental challenge that we face, is that it's an uncertain future, and it's very hard for us to predict what that future would look like in 20 years, because if past is any prediction, we would never have been able to predict what we are right now here 10 years ago.
I totally understand. It's as I was BC Hydro's load forecast manager for 10 years, and I can agree it's a difficult challenge. But on the flip side is the low load forecast. That would obviously, if BC Hydro fully built to meet the high forecast and then the low forecast came to pass, that could be significant stranded assets and ratepayer impacts. So
I would
yeah,
actually, I would think that our processes are actually very flexible around that, because if you look at the near-term actions that we have put forward, there are many, many off-ramps in those decision making that we can actually take to if the load is moving towards the low forecast. And I can give you a number of examples that BC Hydro has started projects in the last 15 years where we thought the load was going in a certain direction, and we actually ended up stopping those projects from moving forward. And one of them I shared about the North Coast transmission line. We were going forward with the series compensation project 15 years ago. We saw the load did not materialize. We actually paused on that project. So I think there's a number of things in our capital planning process, in our decision making process, that allow us to be flexible even if the low load scenario happens, and so that we are not left with the risk of stranded assets.
thank you. That's very prudent. I'm going to leave it to the commission now. So I've got one question on LNG and one question on electric vehicles, and whether or not someone else should get a chance to ask questions, or should I keep going?
No, go ahead. Keep going. I was
Okay.
just going to say, though, that the questions you just recently posed, I don't remember the numbers, but there are quite a few BC Utility Commission questions, IRs posed to BC Hydro on this, and so staff can help you to find the answers to those as well.
Thank you.
So go ahead.
Question on EVs. And so there has been recent changes in the EV targets, and the province seems to defer to federal targets. Has BC Hydro considered that there are ways of meeting both the provincial and the federal targets without actually selling EVs? And going back to the ZEV affordability program, that the sellers who do not meet the compliance targets can get credits that are, can replace EV sales for doing the following things: lowering EV costs, offering zero to low interest in financing, providing home and public charging support, or investing in charging infrastructure. And also, they can meet the EV sales targets by paying penalties. And my best information to date, it's a $20,000 per vehicle. So has BC Hydro considered, and this is BC Hydro's second biggest area of load growth, 5,000 gigawatt hours a year for over the next 20 years, considered that there are alternative methods of meeting these targets that may not actually involve selling EVs?
One of the improvements that we made to our load forecast recently was to better reflect the potential for plug-in hybrids, recognizing some of the changes that were just mentioned. They allow greater credits now for plug-ins and for lower range vehicles. So we did bring that into the forecast, and subject to check, we do assume now that 30% of the electric vehicle sales will be plug-in, not pure electric. So that is a change that we made, considering maybe a moderation of the approach in BC.
But I think the question wasn't about the stock mix that gets you to the target of compliance, but it's actually there are a whole bunch of mechanisms that don't involve purchasing a vehicle. So I think, but I'm not trying to correct your question, but am I right that that's what you were trying to ask?
Absolutely correct. Yes.
So I think your answer doesn't help us.
Okay, sorry about that. We do forecast an increase in the purchase and adoption of electric vehicles. We do not assume that the targets would be met entirely by other means. We have seen continued increase in electric vehicle purchases in BC generally over time. We do know that the incentives, the federal incentives, are available, and we've seen a relationship between the incentives and purchases, and we do expect the purchase price for electric vehicles to come down given the changes to imports, tariffs, and policies. So we do not assume that these targets would be met entirely by, or even partially by, other means.
Right. Okay.
Thank
Please
you.
go to your next question. Yeah.
And liquefied natural gas, our interpretation is this is the biggest growth area in the forecast. Obviously, LNG requires a huge amount of electricity for the refrigeration loop, about 85% of the total plant demand. And I think Ms. Jubb indicated 600 megawatts on one of the facilities requested. It's public information that LNG Canada and its environmental assessment application was saying it could either go gas or electric, but 500 megawatts of electricity demand could be required there. And that is, it's a very flat load factor. So 500 megawatts translates into over 4,000 gigawatt hours a year just for one plant. And so here's the potential paradox in serving LNG with electricity. I think, Ms. Chubb, the last time we talked about LNG in person, there's two facilities in the world out of dozens that work off of electricity. Overwhelmingly across the world, natural gas serves LNG demand because it's relatively cheap and it's obviously right there. So if you look at a 4,000 gigawatt hour demand from one LNG plant, and assuming that the market rate for electricity or BC Hydro's tariff is about one half of what the marginal cost of electricity is, that's a $200 million a year extra cost per plant to the ratepayers. And so the paradox is that if these LNG facilities would have to pay the full marginal cost of BC Hydro electricity, it would render electricity very much out of the money. And so, yeah, how does BC Hydro, justify serving LNG with electricity versus natural gas, given the cost difference?
BC Hydro has an obligation to serve customer requests unless restricted by policy, as in the case for cryptocurrency and the limits on AI data centers. We do have an obligation to provide non-discriminatory service and to reflect, and we do reflect load requests in our forecast on that basis.
Okay. Yeah, just one final follow-up on that is that obviously Bond Bright's cost allocation principles indicate that cost should be allocated to the rate class. And if a FACO study is done in the future, these LNG costs could be allocated to the transmission sector, which is now only 30% of the total load. And that could significantly be concentrated in that sector and cause a much bigger rate increase across the board. And so the paradox being is that by adding these significant additional loads, it could cause rate increases that could then render even rate 1830 cost ineffective.
But is there a question in there?
Yeah, how has BC Hydro considered that these rate increases could invalidate the use of electricity for serving LNG load?
I think you're going to give us the same answer. That you're all obliged to serve? Is that?
We're obliged to serve. We do consider price elasticity of demand in the forecast, so price response. And our customers' business decisions, particularly for large industrial, they know their business best. And they've made their detailed analysis in terms of deciding if they have a choice, deciding the fuel choice that they're going to make. So we do rely on their proposals and their requests for service to us.
And in any case, FACO studies and so on are out of scope for this hearing. Thank you.
Thank you.
Next is Ms. Davies from the Association of Major Power Customers.
Good morning. Just a quick follow-up to Mr. Entz's. Well, actually, it might have been something you said. At this point, I'm a bit confused, but you kind of mentioned the long-term growth rate benchmark that you included in, I believe it was Exhibit B8. being around 1.9% long term, and you compared it to the 1.6% February 2026 reference. I couldn't actually find the 1.9%. I did see 2.15, but was there a different?
I wouldn't describe it as a benchmark.
Okay.
Rather, it is what other utilities' long-term load forecasts are showing, and I'll just pull it up. I could have misspoke. It's on page 4 of 13 of our May letter, and the text there indicates that the average forecast electricity load growth from 2035 to 35 is 2.15% per year. So it's a 10-year forecast, it's not as long a forecast period as BC Hydro's, which is 25.
Okay, I understood that to be kind of a benchmark figure. So if you wouldn't classify it as a benchmark, how did you use that figure?
If I described it as a benchmark, that I misspoke. It is a comparison of what other utilities across North America are forecasting. So that's what we're seeing across the industry from Itron's member utilities. That's their forecast growth rate over 10 years. So it's interesting for sure. We have a different mix of customers than other regions, but we are also seeing an increase in growth rate. Some of those regions do not have the benefit of the policies that we have here in BC for AI and data centers. We really are in an excellent place here in BC relative to a lot of jurisdictions with reflect the policies in place to pace AI data center loads. This is ahead of most of the industry. And across the US, there are very few such caps on the amount of AI data center load, and they're responding with other approaches such as higher rates or higher thresholds for service. And here in Canada, in terms of caps on AI data center load or allocation, the only other one that I'm closely aware of is Alberta. They have 20,000 megawatts of AI data center load, and they did a phase 1 allocation for 1,200 megawatts, and it's fully subscribed. Ontario, which is dealing with a really large run-up in AI data center loads, they are now considering a policy such as what BC already has, but to my knowledge, it hasn't yet been implemented. So we're in a good situation here in BC to manage these AI data center loads, and that's one of the reasons why our growth rates are where they are at.
Honestly, you kind of got right ahead of what I was going to ask. So I was going to kind of just mention or kind of ask if you had considered that other North American jurisdictions have kind of the opposite in terms of tax subsidies to support that type of load. So if that was a factor in your comparison.
Well, the load forecasts are an aggregate. The information we cited about the 2%, that's an aggregate of all of the forecasts. And different regions have their own drivers of growth and their own approaches to large load interconnections. And we're seeing approaches on AI data centers really evolve across North America to try to manage the load growth. So as an example, in the US, which has been attractive for AI data centers, in just last summer, Texas, they introduced a bill to require AI data centers to submit proof that they weren't putting in a duplicate service request, because this duplicate service request has been confounding to forecasters across North America. So they're now asking for proof of that. They're asking for proof that the AI data center has land. In other places such as Oregon, they're applying a higher rate of up to 30% higher than tariff for AI data centers. So regions across North America are taking steps now to try to manage this load growth. And here in BC, we're in a really good place to already have this allocation framework in place.
So just two small follow-ups. One is, are you aware of any other jurisdictions that include price price, marginal cost pricing or that sort of thing in their policies for AI, or is BC kind of alone there too?
Well, the Oregon example that I cited, I'll just check that I've got that number correct. So just this year, the Oregon Public Utilities Commission and PG&E, so that would be Portland General Electric, in June, apparently, they've introduced a new rate structure that would increase data center rates by 29%. And our allocation framework here in BC, it does include a component of the part of the assessment is the extent to which the proponent's willing to pay a higher rate than tariff.
Okay, then just finally, the slide there goes to 2028. Are you aware of any longer term discussions on what will happen after that? Because the IRP goes.
So my
further.
understanding of this regulation, I'm not a lawyer, but my best read of this regulation on data center facility and hydrogen production facility power supply regulation is that the total cap for AI data center load is 600 megawatts, 400 megawatts this year, and then up to another 200 megawatts subsequently, and then that's it. There's no allowance for future additional loads unless the regulation is changed. So that's a legal matter for interpretation, but that's my understanding of it. So it's 600 megawatts total. It's not that in future it's open again unless the regulation is changed. It is worth noting, though, that we don't have 600 megawatts of AI data center load in our reference load forecast. I walked through how much is in there, and it's not 600. So it is possible that the load could be higher than the reference load forecast if those allocations are fully subscribed, and if every proponent that wins the allocation makes it into operation. So this is a reason why BC Hydro needs to prepare for higher load scenarios and the possibility of higher load scenarios.
When you say reference load forecast, you mean the 2026 update?
I do,
okay.
Yeah.
Great, thank you.
I believe we have a question online from Mr. Craig for the Commercial Energy Consumers Association.
I do. A couple of questions about the interaction between what BC Hydro does and what the Commission does in regulation of what BC Hydro does. When we're looking at DSM programs, we're looking at making the use of electricity far more cost efficient. If there's a customer proposing large loads that are not very cost efficient, could BC Hydro, as part of a DSM initiative, talk to the customer even before the load is connected as a DSM initiative and have that result in a more efficient use of energy from the outset? And could the BCUC, as a regulator over the DSM programs, facilitate that so that we get much more cost-efficient use at the start?
We do have demand-side management programs for new construction that work with developers and proponents to improve the efficiency of their new build.
And so this could be done with anything that's being electrified?
The programs, I'm a bit fuzzy on them because I haven't been in the DSM group for a while, but the programs are available to new construction to the extent that I don't believe it is dependent on the facility being entirely electrified, though. But that's a little bit out of my area.
No, those are for housing construction, and this would be for an industrial project. But given that there's already a precedent for doing it, it's just something that I'd like BC Hydro to consider, and hopefully the commission to consider, because it may make a huge difference. The second question is around other jurisdictions having higher rates for data centers. Rate setting is a BCUC oversight for BC Hydro. Is it possible that BC Hydro and the BCUC could entertain rate setting for higher rates where it would seem to be an appropriate way of dealing with a particular set of customers?
Obviously, we're not going to go into detail on that in this particular proceeding, but if Hydro wants to make some kind of higher level comment, it's fine with us.
I'm not looking for detail, just the concept that it's a regulated issue and could be dealt with in that way.
The only comment I'll provide is that the allocation framework for data centers and AI does include a price component. So that is part of the call for demand process, and proponents do have a higher chance of winning that call for demand to the extent they are prepared to pay a price higher than tariff.
Their choice, but not a regulated rate setting at the moment. Correct?
I'm not sure about that. Maybe we can get back to you after the break as to how it's described in regulation. I'm not sure.
Sure. Anyway, I think both those points could be quite big issues for consideration. Thank you very much.
Thank you.
Are there any other questions either in the room or online from parties? Not hearing anything, I believe BCUC staff have some questions.
Thank you, Phil Sard for BCUC staff. And just a couple of follow-up things on the data center and AI overall topic that we've been talking about. I don't need you to jump to the slide, but just referencing the data center, I'll call it the data center regulation that we've been talking a little bit about. I recall earlier that you noted that this regulation also provides BC Hydro some discretion to prioritize projects that can curtail load. And without necessarily getting into the details of that, and I recognise that the call for demand is ongoing and the details are still to evolve, I'm curious from a forecasting perspective whether BC Hydro is making any assumptions in the data centre loads that you are projecting in your reference load forecast, that those loads that are forming part of that forecast are curtailable or not when looking at your peak demand forecast.
By memory, subject to check, the curtailment requirement is 10% of the load to be curtailable. We do not know yet which proponents will advance through the call for demand, and we also don't know how much of that subscription will be used up. So at this point, for this forecast, and to clarify what I mean by that, the allocation is for up to 400 megawatts for this call for demand. We have assumed 50% of that 400 megawatts reaches operation. So we have 200 megawatts associated with call for demand at this point in the forecast. That forecast approach does not make specific assumptions about which customers will advance and how much load they will curtail. Time will tell once we get through the call for demand and we know which customers did advance the potential magnitude of curtailment.
Thank you. And that leads neatly on to my next question was, I was just hoping that you could expand a little bit further on the basis for that 50% probability among that 400 megawatt cap, just to understand some of the key drivers for how that was arrived at.
Just going to go back to that slide.
I think it was 27.
Thank you.
Yeah.
This is a challenging sector to forecast. There's not a lot of information at the project-specific level about the business model or the profitability of the individual projects. The projects that were more advanced are reflected in category 1, that 350 megawatts. Those are the projects that are either already operational or that have paid their design deposit or facilities study agreement by January 30th. Considering all of the other proposals that we were aware of, 50% seems reasonable. Only time will tell if we got it right. We have seen there's very limited information on these types of proposals, and we've seen different utilities take different approaches to how they forecast it, and certainly some are applying heavier discounts than 50%. In Ontario, in their 2026, the Ontario System Operator in their 2026 planning outlook, they were showing 10,000 megawatts of AI data center load requests for 2035, and they've discounted that by 90%. So their long-term planning outlook has a range of discounts around 85%. Our assessment of the projects that are going through the call for demand is that that is too extreme. We do have certainly some credible and some viable operators there, and 50% seemed reasonable, but only time will tell if we've got that right or not.
Thank you.
And I think maybe I could just add to what Anthea was mentioning. The process that we are going through right now is doing the studies for that allocation framework, because there's proponents who have put forward their request for load. We are hoping that at the end of this year, we will have an assessment or a decision made in terms of which ones are moving forward. And as I've mentioned before, our load forecasting is a yearly exercise. So as we gather the data through this first allocation framework that we are going through, we'll get a better indication of whether we hit the mark on 50% or do we need to change that. And I think that will be reflected in our next year's reference load forecast, which is going to be done on a yearly basis. So I think this is a bit of a self-calibration that has to happen as you go through it, because none of the utilities have a lot of history in terms of how to deal with data centers. And this was our best estimate in terms of what the number is. And it's quite possible we might be off, either too optimistic or too pessimistic. And I think that'll evolve as you do the next year's load forecast.
And recognizing that it's an annual process for the reference forecast, are you also taking an annual refresh of some of your high load scenarios? And to the extent that's the case, I'm also just curious the extent to which these probabilities might vary under such a forecast specific to the AI and data center sector.
We do a set of load forecasts every year that's required for internal planning purposes. A reference, a high and a low. We are nearing completion of our 2026 high load scenario. It's not an IRP planning scenario, but we're nearing completion of it. And it does assume a higher probability for AI data center loads relative to this reference. And that allows us to test for internal planning functions, the possibility of higher load to this sector, and we use that for transmission planning in particular.
Thank you. And just one final question that I have is that I believe you mentioned earlier you could speak a little bit more about, if requested, forecasting approaches that are being undertaken in other jurisdictions. I know you've just mentioned one where there's a 90% discounting factor. And I recognise this is beyond the slide deck, and subject to any comments from our chair on this, the BCUC staff at least would be interested for you to expand a little bit upon that, and particularly through the lens of any approaches that you're seeing elsewhere that you feel like BC Hydro may consider adopting in future, or ones that you've discounted for any other reasons. But I do just want to check that this is okay. Yeah.
What we are seeing is that a lot of regions are looking at some kind of cap, which we are fortunate to already have. Ontario is examining that and proposing to bring one forward. Alberta already has put in their first cap, the 1200 megawatt cap. It was fully subscribed apparently to just 2 customers. And we're seeing the approaches in the US where they're putting in more stringent requirements around requests for a data center AI proposals, such as you have to prove that you own the land, you have to prove that you didn't put in a duplicate service request somewhere else. So we are seeing a range of different approaches. Here in Canada, the idea of having a framework and allocation seems to be the preferred approach. But we are ahead here in BC. We've also seen in Alberta the encouragement of self-supply. That also seems to be an approach that some system operators are taking. That's not something that BC Hydro is considering or would propose. Any customer can self-supply if they choose to, and our focus is on what the customer's request for services to us. But those are some of the approaches taken elsewhere. The Ontario Annual Planning Outlook, where they heavily discounted, that I mentioned before, where they discounted their AI data center loads by up to 85%. They're really struggling with the duplicate issue there. And with a new framework proposed to come into place to manage those types of load requests, that should help with the forecasting, I would expect.
And maybe that actually just prompts one final question in my mind, is that are there any specific steps that BC Hydro is currently taking with respect to duplicative bidding, or is that kind of captured in the overall probability adjustments that are being taken place for this sector?
I missed that question.
Sorry, if there are any specific approaches that BC Hydro is taking to address the issue of potential duplicative bidding from these sectors, or whether it is captured in the overall probability adjustment that is being taken for this sector.
Our call for demand process has a requirement of $25,000 per megawatt in order to get into the call for demand. So there's a requirement for a financial commitment from the proponents, and that it's a good design, and it does deal with some of the speculative proposals. And we did see some potential projects drop out and not enter the call for demand, possibly some of the speculative ones that weren't able to raise that level of money. So our call for demand process is well structured. I believe it has good tools in place to address some of the issues that the other regions are seeing.
Thank you. Those are all my questions.
Thank you.
Any questions from the panel?
Okay, so we're down to the panel. Do you have any questions? Do you have any questions? So my co-panelists don't have questions. Maybe I have one. Although I don't quite know if I'm going to frame this properly, and apologies or bear with me. Just as I look through this, the electrification of LNG, of that, to me at least, is one of them that everyone's pointed out looms large as a real challenge for BC Hydro. And I'm thinking more generally about forecasts that I've seen or been involved in doing over the years. And this is kind of a question for anyone on the panel, is one in which you're trying to say, how do we treat what politicians have promised to do or not to do, and especially if it looms large for the uncertainty that we have to address. So we have these, as I understand it through IRs and so on, or I can't remember where I saw it now, but that facilities have to be electrification ready, and And I'm just curious if you want to comment any more about how BC Hydro tries to deal with that, because you could have a scenario in which the political leaders that are there now actually don't opt to require electrification, or there's a political change and new political leaders don't opt to do that. And yet that kind of swing is so significant. And then also upstream oil and gas as well, just looking at your forecast. So we just wondered if there's any more comments you might want to make, any one of you, I guess, on that.
Yeah.
Thanks.
Maybe I'll start and then Anthea can jump in. I think I'll start with the upstream impact. So regardless of whether the LNG is electrified versus not, because electrification only takes a very small portion of their feed to consume, and the most of it actually is produced as LNG. So I think from a upstream perspective, the impact would be the same in terms of, and we are starting to see in the Peace region a lot of momentum happening on the upstream side, which has a downstream impact from an LNG standpoint. And there's a lot of reinforcement, a lot of thinking that's going into the planning for the Peace region that allows us to do that. And if you'll see in the Powering Growth plan that we announced yesterday, we talked about economic corridors. And one of the economic corridors is in the Peace region, where we are starting to see the upstream impact of LNG, which we are planning towards and making sure we have the capacity for that. I think from a LNG standpoint, yes, those policies are going to have challenges for us, especially from a load forecasting standpoint. But I think one thing that I can give as a comfort level is, if you look at what's happening on the transmission system in the North Coast, the new line is going to double our capacity, which means incrementally it gives you a huge lift and gives you that ability to actually plan for different scenarios, because you're going from almost 1,400 megawatts of capacity to 2,600 megawatts of capacity. So I think one project that you're doing from a perspective of the load forecast allows you to actually have that ability to withstand and serve additional loads if they were to materialize. So I think that is one way of managing the risk, is that transmission happens in an incremental fashion that can actually have a huge capacity that you can use for either LNGs that may electrify their compression, or they may just take the balance of plant load. So I think that is one way of managing that risk, is that we do plan for that, and the transmission that we are putting forward allows us that capacity that can pick up all those different scenarios.
Yeah, and I guess I was thinking more that, not that they do happen, but that they don't happen, that electrification doesn't happen to that extent. But yeah, that's fine. Thank you.
We already do have a number of customers that self-supply, and then in future will take electricity or may choose to take electricity. That's common in our oil and gas sector, and we do assess those projects based on the probability of electrification, recognizing that they may not all electrify. So there is an assessment of the probability that they'll proceed, and also the probability of electrification, where electrification is a choice. In some cases, it's a choice. In the North Coast region, we've got, one of the benefits of the North Coast region is that there's a number of large projects in that region that could develop. There's LNG, but there's also a number of very large mines. Now, we don't expect all of those things to develop all at once, but by using a probability and a risk adjustment approach, it captures the fact that very likely at least some of them will. If it's not an LNG, there's two very large mines with the same load in that same region. So that forecasting approach allows us to plan for an uncertain future where there does remain some policy and some business risk.
I think the other thing I would add is taking a phased approach on projects is part of our approach here. If you look at North Coast Transmission Line, we've actually broken that into 3 phases. So there's phase 1 that takes you from Williston to Glenannon, then from phase 2 is Glenannon to Skeena, then Skeena North is phase 3, which is again broken into segment 1 and segment 2. So I think the approach over there allows us to see how things are progressing. So for example, if you look at our board approvals right now, the board has given us approval in June to move forward with phase 1 of NCTL, which is the North Coast Transmission Line. In December, we will go back to them to talk about phase 2, depending on how the loads have progressed. So I think taking that approach gives us the ability to develop the system as the loads materialize, whether they are LNG loads or mining loads. And it allows us to actually take that approach where we can actually pause those projects depending on how the load is materializing and align it with the load forecast that we're starting to see. Because it is such a large project, you can't just take a binary approach of everything is approved versus nothing is going ahead. Taking that phased approach is the most prudent way of managing this.
So we're done on this phase. The panel, is there more questions?
Just mindful of the time, Mr. Chair. I'm wondering if this might be a good time to take the lunch break.
It would be. And then how about telling us what's going to happen after lunch then? What's the next stage?
Oh, well, assuming there's no more questions, I believe BC Hydro would just continue with its presentation.
Okay, great. So that's a perfect time. So we'll break until 1 o'clock, and then BC Hydro can start in again. Okay, thanks everyone. Do you have any preliminaries, or I can just pass it over to BC Hydro?
Subject to anything? No, I think, yeah, ready to
All right,
continue with the
back to
presentation.
the panel. Please go ahead.
Thank you. I do want to start with one clarification from earlier today when I was talking about the Alberta System Operator data center requests. If I was unclear, to be clear, the Alberta System Operator has had allocated a 1200 megawatt cap on data center connections that applies to load requests over 75 megawatts, and the magnitude of requests is 20,000 megawatts. I believe I indicated that was the magnitude of the forecast. If so, that's incorrect. It's the magnitude of requests. All right, moving on to the additional load scenarios. I'm going to start with the higher mining study that we provided in Appendix C to the May letter, and just talk a little bit about what this study is and what it shows and what it isn't. Because we did get some questions about this study from AMPC and from the Costco parties. This study is an examination of the economic potential for higher levels of mining activity in BC, and it also examines the role of electricity in enabling that economic development. Mining is an area of priority for both the provincial and the federal government to drive economic development and growth in the province, and mining is one of the large industrial subsectors that it does need electricity supply in order to proceed. We talked about some of the subsectors such as natural gas upstream and LNG, where the customers have a fuel choice. With large-scale mines, they do need electricity service to reach production. So we did examine mining, and the modeling work here was a collaboration between BC Hydro and Navius Research. Navius hold an economic model that can produce estimates of economic impact, jobs, etc., working together with our load forecast model. The results of that study illustrate that in a higher mining scenario, there could be an increase in high-skilled, high-paid mining jobs by up to 10,000 jobs, an increase in GDP, and additional capital investment in the province. The study demonstrates the role of electricity in enabling economic development. It's not, however, a planning study for the purpose of the IRP, so it doesn't have the load scenarios that were presented in our IRP have information on the location and the timing of system expansions. The higher mining study doesn't get into that level of detail. Rather, it illustrates the economic potential of additional mining and the role that that expanding the electricity supply can play in realizing that economic potential. We were asked about how much of the mining study loads are already in our planning load scenarios. And just going back, I probably should have covered that on the earlier slide. This slide here, which the filled line graph, the solid color at the bottom, the darker color, that's our 2025 reference load forecast for mining. And you'll recall from this morning that there wasn't a big change between the 2025 and 2026 reference forecast for mining. And then the additional mining potential that was modeled in this study is the light blue on the top. So relative to the reference forecast, it illustrates mining sector doubling, a little bit more than doubling. Our North Coast load sensitivity, that was one of the planning scenarios in the IRP, also examined a future with higher mining growth, because much of the mining potential in BC is in the North Coast, although not all. There are mine potential across the province. The higher mining study, about 2/3 of the load in the higher mining study is in the North Coast region, load sensitivity. Yeah, so that load forecast, the North Coast load forecast, has about 2/3 of the mining load in the higher mining study. I'm going to now move on to talking about the range of load scenarios that were developed as planning scenarios or filed as part of this integrated resource plan process. And before I get to that, I just want to revisit the uncertainty that comes with load forecasting. And we're seeing mixed signals, a lot of momentum towards growth, particularly in mining, oil and G, large industrial development. And then we're also seeing some downside risk, particularly in the near term. We did have population actually decline in BC recently. Population's a direct input to our electric vehicle load forecast. It's also important for residential and commercial forecasts. We use an external economic expert firm now called Signal 49, used to be called Conference Board of Canada, to provide our population and economic forecasts. And they are projecting that population growth will pick up again and return to positive, but we are seeing some of these downside risks in forecasting as well. So certainly load forecasting is uncertain. That's for sure. And this slide gets at that by showing the range of load scenarios that were either filed as planning scenarios or were developed in response and filed through the information responses. And I counted them up, and there are 7. There are 7 load scenarios here. So quite a range of futures, and illustrating in particular the need to plan for higher scenarios. The low load scenario, to just walk through this table, we've got our fiscal 2025 actuals, 58,000 gigawatt hours of energy and 11,000 megawatts of peak demand. And then we've got our 7 load scenarios here. The low continues that period of stagnation. And given that our, the big decline that we saw in the forestry sector, that's over now, I don't expect, the low load scenario does not have a high likelihood of materializing. The reference load forecast we've talked about a lot earlier today. So I'll just jump straight to the highest load scenario that was put on the record for in this proceeding. And that scenario, we labeled it the 2040 and 2050 GHG target scenario. And we talked a little bit more about it and presented it in our response to BCUC IR 1.4.3. We developed this load forecast working as a collaboration between BC Hydro and Navius. Navius Research have the model that can estimate greenhouse gas emissions, and working with them to calibrate our models between our load model and their economy-wide model. We developed this load scenario that roughly tracks our reference forecast to 2030, and then is targeted to meeting the 2040 and 2050 BC greenhouse gas emission targets. And as a reminder of what those targets are, those are economy-wide targets for the whole province. They are in the BC Climate Change Accountability Act. So they obviously go beyond just BC Hydro, and they're intended to cover the whole province. The 2050 target is an 80% reduction in greenhouse gas emissions on an absolute basis. So you can think of it as a net zero future. That's one way of thinking of it. I'm going to talk now just a little bit about what's in this load scenario. This load scenario approximately doubles the electrical system by 2050. From today, we're at about 11,000 megawatts to about 21,000 megawatts in 2050. So it's a doubling of the system over that time, whereas our reference forecast is about a 50% increase. Some visibility into what is inside the GHG targets load scenario. About a quarter of the emission reductions by 2050 come from the use of electricity that could otherwise be served by a fossil fuel. So about a quarter of the total emission reductions and about half of the load, so about 70,000 gigawatt hours of the 114,000 is from end uses that could otherwise be served by fossil fuel. Some of those are end uses that are already in place today, like home heating. A fair bit of that's already electric. And others are end uses where we're seeing rapid electrification, such as in light-duty transportation. There's some characteristics of this scenario, though, that are quite different from our reference load forecast, and I'll just highlight those. So we've got the bar chart on the left, that's the electrified share of vehicle stock. So those are all vehicles on the road. The tallest bar is the light-duty electric vehicles, and as we talked about earlier today, we also have predominance of electrified light-duty vehicles by 2050. And this scenario does as well. Where it differs from our reference load forecast is particularly in heavy-duty vehicles. So this scenario has heavy-duty vehicles. It's a bit hard to read on the chart, but it's the bar furthest to the left in the 4 bars that are shown. And it's got heavy-duty vehicles electrified at 50% of vehicle stock. And that's not represented in our reference forecast. We don't have the only heavy-duty vehicles that are electrified in our reference forecast are buses, which are reflected separately in this scenario. Buses are also shown here. So a lot more electrification of heavy-duty vehicles, and those draw quite a lot of peak demand. A charging station for a heavy-duty vehicle could easily be 20,000 megawatts, 20 megawatts. Moving on to building space heating, that's another area that's different from our reference load forecast. You'll see the residential is similar, at least in a similar range as our reference load forecast. But if you look at the commercial and institutional buildings, there's not much electrified space heat in that area right now, but in this scenario, it reaches 70%. So those are two of the key differences in electrification. Another difference between this scenario and our reference forecast is the emergence of new industries that play a role in decarbonization and that use electricity. This would include green hydrogen, as well as carbon capture for direct air capture and carbon capture and sequestration. And that accounts for about 20% of emission reductions and about just under 3,000 gigawatt hours of consumption in 2050. We do have some green hydrogen in our reference forecast, but not much. That industry's gone a bit quiet, although recently we have started to see some new service requests for green hydrogen and blue hydrogen. We're starting to see some of both of those come back. We did go through a period where a number of service requests actually withdrew. But in this GHG targets projection, we see a resurgence of green hydrogen and an emergence of a new sector, which is carbon capture. Because these targets are economy-wide, there's also a big role to play for parts of the economy that aren't related to electricity, and fully half of the emission reductions come from those parts of the economy. So I won't spend much time on this slide because it's not about electricity. It just helps tell the rest of the story of this future and addresses the fact that measures such as methane reduction are also an important part of decarbonization. And what's shown in this bar chart is transportation liquid fuel, and the change from today, where we've got gasoline and traditional diesel, going out to 2050, where it's pretty much gasoline has a very small role left to play, and it's pretty much a mix of diesel and renewable diesel for liquid fuels. I'm going to close off this section by just acknowledging that the GHG target scenario is one way that we could end up with loads requiring the electrical system to double, but it's not the only way. If we think about the type of load requests that are coming through now in the large industrial side, and also the potential for some of these decarbonization loads, such as electrification of ferries, heavy-duty trucks, those are large loads, and it is possible that we could come to a future where we don't get to that 80% emission reductions. That is an ambitious future, but it certainly is possible that there could be a pathway where we have additional decarbonization loads, we have additional large industrial loads that also lead to a higher load scenario. And that's one of the reasons that we do need to be prepared for higher loads futures. That's all I had for slides on the additional load scenarios.
Great, thank you. Go ahead.
Question from Mr. Quayle at Move Up.
Yeah, this is with respect to slide 47. With respect to slide 47, and I'll try to be brief, but looking at, if you could turn to that slide, the chart projecting the share of electric vehicles. And I'll just try to briefly put to you why it seems to me that these kind of forecasts fail to take proper account of the dynamics of a changing market. I'll try to be brief, but I think they're fundamentally flawed. And that is that there must be the relatively linear growth, if you look at the bar graph there on the left, of the penetration of electric vehicles. But as the market gets more dominated by electric vehicles, there are other forces at play that accelerate that process dramatically. And as the share of internal combustion vehicles becomes smaller and smaller, all of the infrastructures that make it possible to operate them start to recede. It's the opposite of the situation electric vehicles were on when they were early entrants and you couldn't get them charged anywhere. When 60% of the cars are electric, and that means presumably new cars, much higher than that because you've got all the old stock, where are you going to buy gasoline to fill an internal combustion engine? There's only one gas station now in the entire downtown peninsula, Vancouver already.
So, Mr. Quayle, then is your question simply that wouldn't they, although this is one scenario, wouldn't they agree that there should be nonlinearities in here?
Yes.
Okay.
Yes, and a significant acceleration of the rate of penetration of electric vehicles.
But you have to remember that, like, new stock would show you something different than total stock.
Yes.
New stock can be highly nonlinear, while total stock might look somewhat linear. But
yes,
okay.
But the impact then on the logistics of operating, when you're in the minority with your internal combustion engine running on gasoline, good luck finding somebody who can fix it for you, for example. Anyway, just put it to you that that's a significant conceptual flaw in the way that a lot of these projections are done because they don't actually imagine the dynamics of a different kind of market.
I might just add one thing. I know I'm not the witness here, but
I'd be interested in your...
I do build these models, and I believe that even if you were using the Navius model, there would be sunset elements in those models, which I've always put into my models, which means once you get below a certain market threshold of sales, the system collapses and those go right out the window. And that can even be in a model like this. Sorry, I shouldn't be doing it.
I have some more questions for you, Mr.
Do you want to add anything? Sorry, I didn't mean to usurp your response.
The modeling expertise is Navius's, not our own, but I do know that they use, for example, a logistic decay of the life of the vehicles. And although it's not readily apparent from the bar chart, you do see a bit of that S-curve on light-duty vehicles if you look closely. It is there, and I think the fact that it's not more dramatic is that you've got that existing stock that has to turn over. And they did see, and that it shows up on the slide. a continued role for gasoline into the future. It gets smaller, but there still is gasoline in use, and there still is traditional diesel in use, because some types of transportation, that really is one of the most practical and viable approaches. So in this scenario, there still is gasoline and traditional diesel and renewable diesel all the way out to 2050.
And I'll just be just a moment longer, but also getting into a scenario where half of the market of the new vehicles even is electric vehicles assumes we're no longer importing 3% of our electric fleet from China. I mean, it means that things have happened. Either the protection that's happened to the domestic manufacturers has worked and they've driven down their price. People aren't going to be paying thousands of dollars more to keep a legacy internal combustion industry alive indefinitely. So things are going to happen in terms of the reasons why you dump your old beater that's running gasoline and get a nice electric vehicle that costs you much less money and cheaper to operate. So it just seems to me all these projections are just wrong because they assume continuity, which is the problem with most of the projections that people make all the time, because that's the way, as Marshall McLuhan said, we look at the future through a rear view mirror. I'll stop at that and I'll have more questions for Mr. Jackard later.
Thanks very much. You're fine. Okay.
I believe the next question is from Mr. Lesney with the Clean Energy Association of BC.
It's already on. Okay. I'm going to just follow up on the conversation we had this morning. So I believe when we were talking about mining load and some of the other, is it correct understanding that BC Hydro plans for the reference study as your main plan, most probable, but also plans for the different types of planning? And I think you kind of indicated some are more probable than others. So when we look at slide 46, would it be fair to say that all of these various forecasts, BC Hydro has some depth of planning towards, depending on the probabilistic outcome of it?
Yes, that's fair to say. And my colleague later today will discuss how our near-term actions plan above the reference load forecast.
Yeah, just to clarify, if you look at the 7 scenarios that are listed there, the reference load scenario and the high load scenario, those are part of our near-term actions that are listed in our IRP. For the North Coast load sensitivity, we already have a transmission project that is going to meet the requirements. So we've talked about that in my opening slides. I think we talked about the fact that the combined high and North Coast in our response to that IR that came up is highly unlikely that both would happen at the same time because they're sort of factors that neutralize each other in those 2 scenarios. In terms of the greenhouse gas reduction targets, I would refer you to IR BCUC IR 1.4.5. In that, we actually talk about how we will actually pivot if that scenario is where the future is going in terms of our energy capacity and transmission. And I think if you look at our report that was outlined yesterday by the minister and our CEO, it talks about how the new capacity that's required under this scenario would be focused on. It talks about the new energy requirements for new calls that are in the future. And it talks about the transmission requirements over there. So I think there's elements of everything that is required for all these scenarios in our IRP and in the plan that was announced yesterday. The question is, how much planning do you do to get those optionalities still going? And depending on where the future goes, then you have to sort of either accelerate those or pull them back. I think that's where we are right now with our planning. And I think it's a very comfortable position to be in, given the fact that we do have a lot of options and we have all these scenarios that could unfold, and we are keeping all that optionality open for us.
Okay, I think that's helpful. I think another question I'd have, so we have responses in IRs and commentary related to the legislative emission forecast, which at one point was a scenario that was going to be part of the IRP, did not get originally published. And again, as you correctly put, the whole planning is a view to the future that we know from day one is going to be wrong, but it's to give off planning. And I think when it comes to some of the climate change, what would be helpful is to understand why, call it your business as usual. In other words, you're sticking with the legislation that exists, not to have that on the table. Not saying that that's the most likely plan, but to inform both policymakers, the regulators, and other stakeholders. And understand if you stay on this path, this is BC Hydro as the experts most likely spend, so that policymakers and stakeholders can then readjust to that. So it'd be interesting to understand why that was moved. And I have one last question, kind of tying this to procurement. So why was it not in the original 2025 IRP when it first was published, I guess, is the core question.
When we were developing the load scenarios for the 2025 IRP, at that time, taking our minds back, that was very early 2025, and we just entered into a trade war with our largest trading partner, and the economic gloom was quite strong. There was a real concern about affordability and a real focus on that as a concern, and a focus on ratepayer and affordability and managing rates for existing customers. The 2040 and 2050 targets load scenario, we have released it. We've released it in response to information requests, and today we're happy to talk about it more. And in response to information requests, we also did discuss our plans to meet those higher loads. And you've seen announcements, including that one yesterday, to help us prepare for that future.
Okay, thank you.
I think just to add to, I think your question was, why did we not include this as part of our IRP? If you look at our response to BCUC 1.4.1, that response actually talks about sort of the obligations under the Clean Energy Act, and we talk about different objectives over there. But I think there's a couple of things that we list over there in terms of the reason why we did not include that. One of them is, if you look at the 2024 Climate Change Accountability Report, it talks about the fact that we are not, as a province, not on track for meeting these requirements, especially 2030. So I think that is an indication of where sort of the next few years are going to take us. The second thing I would say is there's been a lot of development in the oil and gas sector and the industrial sector, which are pushing the climate change targets in a different direction. And we outline those in that response. So I think there's a number of practical things that we had to take into account when we are developing this. And as Anthea said, we have to balance the aspirations of the greenhouse gas reduction targets versus the affordability, and plan something that is practical and is going to be required. Because if you start looking at energy and capacity, and we actually looked at this when we were looking at the level of energy we're going to acquire in the 2025 call. And I can tell you, every 1,000 gigawatt hours of additional energy you acquire over the period of 30 years is billions of dollars of commitment we are making. So I think we have to be very practical and astute about how much affordability is key and how much do we acquire, and be practical about it. Because if you make a decision that is going to be oversupply of capacity and energy, that is extremely expensive if you're not going to use it. So I think that's the balance we are trying to find with our plan.
That was very helpful because it leads into my last question. So given these ranges, scenarios, and what the IRP is laying out, and we've talked about plans, I guess it'd be interesting to understand how BC Hydro sees their IRP signaling to not just developers of new projects to supply BC Hydro, but First Nations who are expected to partner and find the right arrangements to understand how this builds out. And given that risk profile, so BC Hydro went from no procurement for almost a decade to targeting 10 terawatt hours of new energy, and trying to understand how that might be spread out and be more consistent, so that as the ebbs and flows of the gloom or kind of nexus that we're in right now, and really a wider uncertainty, participants, and particularly local communities and First Nations that are partnering and having an influence on which projects, can understand less on a stop-go basis and more moving towards a fast and slow basis. So if we're overshooting, we're slowing down. If we're under, we're building up, but not big waves, which tend to lead you with leftovers. So I guess
trying to understand how BC Hydro sees this update and the IRP signaling to communities and developers.
Yeah, I think you raise a very valid point, and we actually see that in our capital plan also, because when we talk to our suppliers in our capital plan, they are looking for an early indication of what's coming so that they can supply us with the transformers, the circuit breakers, and all those things we require on our capital plan. Same thing in our vegetation management. Suppliers are looking for that confirmation of what's coming in the future. And I think we've done a very good job over the last 3-4 years in giving that long-term indication. Coming back to your question regarding the IRP, like as I mentioned earlier, the last call we had was 15 years ago. So we didn't have a reason to give any indication to the market because we didn't need the energy from a system standpoint. In the last 3-4 years, every utility has had to pivot, and the pivot has been very fast. And I think if you look at how successful our 24 call was and how successful the 25 call, I think we did an excellent job of trying to engage the community as well as the First Nations. And we are one of the only utilities in BC or in Canada that has actually taken that First Nations participation to a level that has not been seen before. We had almost 50% participation of First Nations in the first call. In the second call, it's at 51%. If you look at how the participation of First Nations is happening on the North Coast Transmission project, that's ownership that has never been explored before in BC. So I think we are sending the right signals. We are forming the right partnerships with our First Nations and our suppliers. And we are actually ordering equipment and things early on so that we can actually facilitate the IPP connections. We can facilitate the load interconnection process. And I think that is something that is unique. And most of the utilities are starting to do their partnerships. We are taking it to the next level now, in which we are exploring economic corridors, which was outlined in our announcement yesterday by the minister and our CEO. So I think those are things that we are doing differently that we haven't done before. And it actually sets us up nicely in terms of the uncertain future that we all are going to face as we go forward.
Okay, thank you very much.
The next question is from Mr. Craig online with the Commercial Energy Consumers Association.
Thank you. Can we go back to the EVs? I have 4 questions. The first question is, in your estimating for this, have you taken into account that the cost of EVs is declining rapidly? I think the new Tesla one is down at 24,000, and the costs of EV vehicles, I expect, will continue to decline. I've got 4 of these items. I'll do them one at a time, unless you want to hear them all at once.
One at a time is good. So this this GHG targets projection is a summary of it is attached to BCUC IR 1.4.3. So there's a little bit more information there if you're interested in. And it's from it was from February 10th, 2025. So it reflected information available at that time. So over a year ago now. I know that the Navius model does include costs and it does include economic decision making in it. It's also in this instance, it was calibrated to meet a greenhouse gas emission reduction target. So as I understand it, the model can solve for a variety of pathways considering cost information while having been calibrated to that target. To the extent which it considered the potential for cost declines for electric vehicles, that I'm not sure.
Okay, we can find out later. The second item is that self-driving transportation now is going to end up being the lowest cost method of transportation. And I'm wondering if you have anything in your forecast for electric vehicles that has to do with self-driving?
We don't, because self-driving, fully autonomous vehicles are prohibited under the Motor Vehicle Act in BC, and we had some commentary on that in our response to the Costco information request 1.4.2. I mean, we do obviously see some self-driving vehicles in other regions, and it's possible that the policies will change in future. But currently, the BC Motor Vehicle Act is very clear, and so we did not include that type of end use in our forecasts.
It seems for long-term forecasting that it's inevitably going to be an issue, and as politics changes, these kinds of things change.
I think that's
so
a point for. I think
as
that's a point for argument. She has answered. Yeah.
yeah, okay, let me move on. Have you also incorporated the large and small trucking loads that are now being electrified?
The GHG target scenario does, and you can see that here, that it does reach 50% stock for heavy duty vehicles, and looks like it's about 30% for medium duty vehicles. For our reference load forecast, in addition to light duty electric vehicles, the other main category are buses. We do have transit and school buses electrifying. So far, we're not seeing the medium duty electrify at scale. That might yet come. We have seen an uptake in some of the medium duty vans being electrified, but it's not yet at scale. So there's very little of that load in the reference load forecast. And it's possible that we've understated the future load growth for electric medium duty vehicles. That's possible. And if so, that would indicate that load may be higher than our 2026 reference.
Good, and I think it's possible also for the heavy duty loads, as those are just taking off now. The last point with regard to vehicles, which is another attraction of the electric vehicles, is that it's anticipated that they can earn the owner of the vehicle a living. So it's not just lower cost, but it also has a revenue potential attached to it. So those are just some points to be thinking about in terms of whether the long-term picture here is adequate, sufficiently adequate.
Fine, but that's not a question. So, do you have another question?
No, that's it. I'm just looking to see whether or not that was included, and I'm assuming not. So
we do have we do have, to clarify, we do have electric fleet vehicles in the forecast. So this would be ride sharing vehicles and other fleets that are electrified, and so and we have commercial electric vehicles as well. So those are vehicles used to earn a living.
well, a different kind of earning.
I think he's referring to the earnings of providing your battery at the critical peak times as part of earning money from your vehicle. Is that correct, Mr. Craig?
That's correct. That's one of them. The other one is the vehicles carry the ability to compute and can earn compute money as well, and a variety of other potential revenue sources. So the attractiveness is a big issue, and I think over the long term, it's going to have very substantial effects. So I just wanted to have that on the table so that we can have a look at that issue.
BC Hydro is doing vehicle to grid studies. That's at the early stage. I'm not aware of the other concept that Mr. Craig raised about the compute possibility, and that's not in our forecast.
Thank you for the opportunity to raise the issue.
Are you finished, Mr. Craig? Oh,
I am finished.
Okay,
I am
thank you.
finished.
Thank you.
Those were my 4 points. Thank
Thank
you.
you.
Next question is from the city of Richmond, and I would just ask that the speaker identify himself for the record before he asks his question.
Hi there. It's Nicholas Heap from the City of Richmond. I'm a sustainability project manager representing the local government interveners. I've got a few questions for you. Thank you for the opportunity to be able to put these forward. Slide 46 has a series of different load forecasts. As you noted, the greenhouse gas plan was the one that had the highest demand by 2040 and 2050. So when we look at 2040, for instance, we've got 98,000 gigawatt hours. Are we to imply from, infer from that that it is the marginal gap? It's like the, what, 6,500 gigawatt hours is the difference? Or are you, or are we taking it from the reference load forecast of 80,000 and that load forecast is actually 18,000 gigawatt hours? That is different from what you would be seeing in the high and north coast forecast.
I'll just clarify how to read this table, which I did kind of gloss over. So in the columns are the load in that year. F25 is there's only one number because that's our actual metered and measured load. So we know that's 58,000 gigawatt hours and 11,000 megawatts. And then F24 is the forecast for the total load under a scenario in that year. So in our reference load scenario, the total system energy requirement is 80,572 gigawatt hours, and the target scenario is 98,000 gigawatt hours. And similar below, each row represents a distinct scenario, a future projection for electricity consumption. So they're not a difference; they're an absolute number.
Okay, so that was the way I thought it worked. So that suggests that in a future where we have lots of mine development on the north coast and a continued electrification, through heat pumps and electric vehicles and so forth, that we would have to add both of those differentials together to get the combined demand of both of those scenarios?
No, you wouldn't add them together. The future that you've just described is most closely illustrated by the line item that's called combined high and north coast. And in that projection, we took the north coast load sensitivity. That was at the request of the commission, and we provided it in response to 1.3.2, I believe. We took our high load scenario and our north coast sensitivity and combined them. If you just add them, you will double count because there's the same loads in both in some cases, not always. So we did that calculation and filed it. That combined north coast, yeah, it is good. It's BCUCIR 1.3.2 if you want to look it up. It assumes very rapid electric vehicle adoption, and it also assumes the additional mining, additional oil and gas, LNG as well.
But it doesn't assume the implementation of the Clean BC measures that are reflected in the Navius demand forecast, which is what the 98,000 in 2040 covers?
It doesn't have all of the measures, and the one in particular that it does not have is the highest equipment efficiency standard, and we appreciate the input of our technical advisory committee. I believe certainly City of Vancouver was part of it in terms of raising the highest equipment efficiency standard and suggesting that we do model it and we do put an estimate of what it would consume, which we did so with City of Vancouver graciously gave us some input to that. And we present that load estimate on page 2-32 of the application, and it's about 8,000 gigawatt hours for highest equipment efficiency standard in fiscal 2050. So if you were interested, you could add that to the combined high and north coast load sensitivity to get to a future where there is full conversion of existing household from gas to electric space heat, additional mining and LNG development, rapid electric vehicle adoption.
I appreciate that clarification. And then there was also, I believe, adoption of the zero carbon step code and energy step code in additional municipalities that I don't believe was modeled in the reference or high load forecast. So would there be additional load? Were those measures to be implemented as well? That's not captured here.
Yeah, yes, not captured in the combined high and north coast. And we have the zero carbon building code in the reference where it has been enacted into bylaws by municipalities, and half of the expected residential counts growth are covered by those building codes, and 80% of new commercial floor area is covered by those building codes. But for the part that is not covered, we did provide an estimate of the additional savings again on page 2-37. So if you're interested in a future with that combination of high industrial load growth, rapid electric vehicle adoption, and full conversion from gas to electric heat, you could add the sum in table 2-6, which is approximately 10,000 gigawatt hours by 2050. You could add that to the combined high and north coast load sensitivity, and you'll get something close to you'll get close to the 2040 and 2050 targets load scenario if you do that, but it is important to note it's a different mix of customers, so that future would not meet the BC greenhouse gas emission target. It would be more like a high electrification and high industrial development future.
Okay, thank you very much. Appreciate that. The Navius model. You mentioned that there was increased amount of electrification of commercial buildings in the Navius model. Was there also a different amount of electrification for residential buildings in that model?
Yes, it is. It is higher in the target scenario. We did provide our the shares of electric space and hot water heating in the application on page 2-39. And these shares, although we've got a new load forecast, the shares are still approximately the same. Residential electric share gets to 62% in our reference load forecast, so approximately 60. And that's by 2050. And if you read off the graph here, you'll see that in the GHG target scenario is a little bit higher at 70. And we've presented the commercial shares as well. That's where the big difference is. Our reference gets to about 40% electric space heating share, and the target scenario, that's where you see the big difference. It's up above 60.
Great, thank you. Finally, appreciate all this information, much appreciated. When the reference load forecast was increased in your filing back in, was it April, May? There was no change to the high load forecast, and so there seems to be the reference load and the high load have moved quite close together. And so I just was wondering if you had a comment about what appears to be a lack of contingency when, as we've just explored, you can't imagine futures where we have load growth that is beyond what you're showing in your table of scenarios there.
The 2026 reference load forecast falls within the range that was presented in the IRP, so it's between the high and the low. We do have 7 scenarios on the record, and it wasn't clear that it would be helpful to add a 8th.
I think as Anthony had mentioned before, we are working on the 2026 high scenario and also the 2026 low scenario. But that is it. Sort of, as I said, we have an annual update on our load scenarios. We do that for all 3 levels, and that is currently in the works. But it was important for us to share the 2026 reference because we felt it was higher than the 2025 reference in the IRP, and we wanted to give an indication to the commission and to the interveners that the load is going up. So that's why it was prudent for us to do it in a timely fashion, and we included that as part of our IR responses. But the teams are working on the 2026 high scenario also.
Do you anticipate that you would be including the 2026 high load forecast within this IRP?
No, the process doesn't allow for it. I can share the preliminary results. It's not final, but we do have preliminary results, and they are coming in close to, in magnitude, close to that targets load scenario. By 2050, they're in that same range. They're not final yet, but they're coming in around that size. Importantly, they are a different mix of loads though than the targets. So there's more heavy industry. There's also continued electrification, but more heavy industry. Earlier today, we talked about the AI data center load. So the high scenario reflects where we're getting closer to filling up that 600 megawatts allocation. But we won't be filing it in this procedure because I think the procedure is winding up the evidentiary phase.
At the risk of asking too many questions, how does the 2026 high load forecast compare with the 2025 high load forecast, or the one that's in the IRP in the 2030s, in the early 2030s, which is where the new reference load forecast makes its closest approach to the high load forecast?
That I don't know.
Okay. All right. Thank you very much.
Next is Ms. Davies from the Association of Major Power Customers.
I think maybe if I could just add that there was a lot of discussion around the numbers, and I want to put things in context. So if you look at this table, the 2026 reference load forecast in 2050 is 87,000 gigawatt hours. And if you look at the combined high and North Coast scenario, that's 97,000 gigawatt hours in 2050. That's roughly a difference of 10,000 gigawatt hours. And if you look at the amount of energy we can procure through a competitive call, that's somewhere between 2 and 3 calls that we have to do in the next few years to get us to 2050. So I think we have to keep that in mind, that the numbers might seem different on this table, but the approach you end up taking to actually meet that gap is pretty straightforward. And if you start looking, and Sanjay will get into this eventually, this afternoon or tomorrow morning, is the amount of wind energy and the price curves around supply of energy is pretty flat in BC. And we have lots and lots of energy up to about 30,000 gigawatt hours that we can avail of if we move forward. So I think it's important to keep those things in mind when we start looking at the gaps, that it may not actually take a lot to close that gap, given the fact that we have a process, we have a structure, we have sent the signals to the market, and the IPP community is out there with different prospects around energy that can allow us to close that gap quickly.
I have a couple questions on the mining study, if that's okay. Slide 43 shows the load growth projections for the reference mining load compared to the light blue on the left side of the expanded mining scenario electricity impacts. I was wondering what the expanded mining scenario is based on.
Thank you. It is a mix of archetypal projects based on projects that we know about, that we have that have communicated with BC Hydro about their intention to develop, but they're not in development yet. We did select it to include mines from across the province, so it does have potential proposed new mines from across all of the 4 regions. Well, most of the potential is in the North Coast, which is why, as I mentioned earlier, about 3/4, considering the higher mining study, about 3/4 of that is already reflected when you consider our North Coast load sensitivity.
So you're saying that you consulted with actual potential mining customers to develop it?
The archetypal projects are based on projects that BC Hydro knows about, that they've either requested service, they're moving through our interconnections queue, or they've at the inquiry stage and they're not yet operational.
Do you have estimated or benchmarked timelines for when a customer is in that stage to when they ultimately take service?
We did do a study which we presented in the 2021 IRP about the typical time from when a project enters the queue until they reach production. And I'm going by memory, so I'm going to forget some of this, but not all of them reach production, so that's for sure. We do have a dropout rate. By memory, it's at least a third in mining, so not everyone makes it to production. And of the ones that do proceed to production, by memory, I think it was 3 years-ish from entering into the queue to reaching production. Some of these archetypal mines, and that would be measured from system impact studies, some of these archetypal mines are not yet at that stage. So they're still at the inquiry stage, so they haven't made it quite that far along.
Well, none of them would be in the queue, though, because if they were, they would be in your reference scenario. Am I incorrect in that?
No, that's not correct.
Okay.
Just going back to our reference load forecast approach, we do consider I'll just take you. I don't want to spend too long on this because we talked about it a lot in the last hearing, but in the reference load forecast, we do consider all project proposals that we're aware of, from concept all the way through to production. And we use the assessment framework that's shown on table A-1 of page 5 of Appendix A, and we assign a probability to projects based on their progress through those milestones. So it's possible that a project could be at 25% probability in the reference based on its early stage of development, but it could be represented at 100% in the higher mining study or in the North Coast load sensitivity.
Okay, so you can't quite stack them one on top of, add them together to kind of get an overall. There's some overlap, is what you're saying. Potential overlap.
There can be overlap, and that's why I would think about it in terms of the total gigawatt hours of mining potential that's represented in these scenarios, which we provided on the next page. So we've got 7,400 gigawatt hours of mining potential in this, we add 7,400 to the reference in the mining study, so it approximately doubles. So we can think of it conceptually that this is a future where the mining sector doubles relative to the reference. And what does that mean for the economy? That was the intent of the study. And the mining sector, there's a lot of things that would have to go right for the mining sector to double. One of those things would have to be expanded electricity supply.
And then just relaying this to the North Coast load sensitivity, and kind of looking back at the slide 43 for that kind of lumpy increase, kind of peaks around fiscal 37 and then again at fiscal 41. I'm just wondering what assumptions are included in the timeline for in-service, specifically with request to North Coast transmission line. Does it assume that day one of the asset up and running, all these customers are fully online, or does it pace them in? So I'm going the wrong way. Okay. I can. The projects are paced in. Not all of the archetypal projects here are in the North Coast. So we did select for regional representation. So there are archetypal projects, Vancouver Island, the Southern Interior, as well as the North Coast. So there is a mix. So not all of them are linked to transmission build out in the North Coast. As a general approach, though, for load forecasting, for planning scenarios like our North Coast sensitivity and our reference forecast, we do not put a load into the forecast before the bulk transmission is built. Like the transmission connecting the customer, or the NCTL itself? The bulk transmission. So the North Coast sensitivity considered the timing of the North Coast transmission line, so the bulk transmission, as an earliest for those customers that would rely on it, which is not all of the customers in the North Coast. They don't all need that transmission line to be complete to take service, but some of them do. And for those customers that would rely on that bulk transmission to be complete before they could energize, we took that as the earliest possible electrical service date. Okay, and did you assume that for those customers, their energy 100% comes online when that bulk transmission does? Or is it phased in? It's not assumed to be exactly at the time the bulk transmission completes. As we talked about earlier, for the timing of projects, large industrial projects, we do consider a range of information sources, including market experts who give us an assessment of when their view of when these projects will come into service. And that's one input that we consider. There's detailed market expertise on the expected timeline, even month over month for some of these projects from the market experts. So we do rely on that. We also rely on what the customer has told us, what we've learned from them, and any expectations around construction delays. Okay, thank you.
Next is Ms. Miss from Costco.
I apologize. So I have two follow-ups on higher mining study, slides 43, 44, which actually responds to our pre-submitted questions, and we appreciate it. So one question is, did Navios assessment of the economic implications, such as GDP impacts of expansion in the mining sector, also accounts for the negative economic impacts of any increase in electricity prices that could occur as a result of BC Hydro having to acquire additional resources to meet the increased electricity demand?
The model, as I understand it, does consider all segments of the economy, including electricity. So the impacts of the electrical system are reflected in the model. It does also have a price response in it. What the model, though, does not have, and we do not have, a rates forecast for the higher mining study. So we don't have a rates forecast for this, and that was not an input to this model.
And we discussed this slide 44 and considerably higher numbers. And follow-up would be, what is the likelihood that this will actually appear?
The higher mining study?
Yes, on slide 44, these numbers that you showed on slide 44. What is the likelihood that it actually happen?
We did not assign a likelihood to the higher mining study, and it wasn't developed with the intention of being a forecast. Rather, it's intended to illustrate the economic benefits to the province of BC in terms of jobs, GDP, and investment associated with expanded mining activity, and the link to expanding the electrical system in order to support that economic growth. We did not assign a likelihood to it. They are, though, all of the mining projects represented in this study are real projects. They are actual proposals at various stages of development, and every one of them, if you speak to their proponent, they'll say they're likely to proceed. So it's possible that this future could occur.
Okay, thank you.
Just while you're there, I just want to follow up on one of your questions. So you used the Navius model for this, and it is a general equilibrium model. So are you saying they turned off the electric sector of the electric component of the model? Because otherwise, it seems to me the model would give average increasing electricity rates over the longer term, and that would have some effect on demand, which was the question you asked, unless they somehow turned that off, which is very difficult with a general equilibrium model.
They did not turn it off.
Oh.
So the electricity sector is very much part of the model. If I misspoke, which I probably did, all I meant to say is that BC Hydro did not provide a rates forecast for this higher mining study, but the impact on the electricity sector of the economy is very much part of their model.
And so the cost of electricity would have gone up by some amount, whatever the marginal cost was in the model, correct?
Yes, that's correct.
Yeah. Okay, thanks.
I think what Anthea is saying is typically when you look at all these mining and LNG loads, we translate that into capital projects on our system. Those capital projects then feed into the rate model for BC Hydro to say this is the future rate that's going to happen. Because we did not go through that exercise of figuring out what the rate impact of these projects would be, because we haven't done the capital planning, that's the feedback loop that was not included in there.
Yes, and I understood that. I just wanted to make sure we were clear in answering the question that there would be some rate effect, and it would dampen demand by some amount, whatever it was, depending on elasticity. Great, thanks.
I believe RCIA.
Mr. Chubb, I want to just take a little step back and talk a little more philosophically. In some of the IR responses around EV forecasting and GHG forecasting with regards to EVs, one of the responses from BC Hydro said in the reference forecast, there was no credible path in the near term to hitting the legislated targets. Do you remember that IR response? Or the general concept of whether there was a credible path or no credible path to hitting legislated targets in the near term?
The 2030 BC greenhouse gas emission target, the BC government's climate change accountability report indicated that we're not on track to meet the 2030 target. And the modeling that we had done, working with Navius to develop load scenarios to meet the BC greenhouse gas emission targets, we were unable to find a credible path to meeting that 2030 target either. So both BC government, they came to the same conclusion about the 2030 target.
Okay, excellent. That's a fantastic summary. And then going further into the forecast, it appeared to us upon reviewing the forecast that you transitioned to what I'll call a target-based outcome, where you started to say, we will hit the targets. We haven't necessarily determined the path, but we're declaring we will hit the targets. And my question is, can you discuss a little bit how you decide when there is a credible path in the near term, and then you're going to hit targets in the longer term, and how you make that decision as to when you flip from what I'll call forecasting to target-based estimation, or I don't have a proper word for it, but hopefully you understand what I'm asking.
Well, just to clarify, for this GHG targets load scenario, we did calibrate it to the BC emissions target in 2040 and 2050. So that was a design assumption for that scenario. In terms of the reference load forecast, we look at individual electricity using equipments and technology. And when considering about government policy, we generally look for an enforceable regulation. If there's an enforceable regulation in place, then and it's an electricity using equipment, then it'll show up in our forecast. And that's the case, for example, for zero carbon building code. The reference forecast includes load associated with municipalities that have enacted zero carbon building code into their bylaws. What the reference forecast doesn't include is the provincial policy commitment, but that is not yet enforceable for zero carbon new construction province-wide. So that's the frame that we use for the reference forecast. Is the policy, is it enforceable in regulation? And obviously, does it affect an electric end-use equipment? So we're not considering in the reference forecast some of those other measures of emission reduction that were in the targets load scenario, such as methane reduction.
Can I just follow up? Because this is an area I'm interested in as well. Is that it?
Yep.
I was trying to think of why Hydro had done this as well. And I thought I read somewhere that it was also that the minister had finally said, we're going to pay more attention to what the federal vehicle regulations are, and that had been one of the reasons Hydro had pivoted to this, or am I completely off on that? And sorry for interrupting your...
That's a fair question.
Is the question specific to electric vehicles? I presume it is?
Sure.
Oh, okay. We did see the federal electric vehicle framework change, and we did see the minister announce that they would be following the federal target. So those two signals were enough for us to revisit the electric vehicle load forecast for the reference forecast, both that. Now the BC Zero Emission Vehicle Act targets, I don't believe that they've been revised yet. There were the regulations this spring, I believe, that we talked about earlier today to make it easier to get credits to help with the early year targets, the 26 target in particular. But we do have a number of statements from government saying that they will align to the federal target, and that was sufficient for us to revise the electric vehicle load forecast.
Okay, but so building on that, moving from when you have a forecast credible pathway to these enforceable targets, if I could label them as such, how far do your credible pathways go? Is it the 7 to 8 years that you talked about earlier today, or when do you make that transition, and how do you decide to make that transition?
Essentially as long as the regulation goes for. So if we think about the Electric Vehicle Act and policies there, that's a long-term trajectory with targets going out in time. So we consider those as far out as they go. Same for the zero carbon building code in municipalities that have enacted them. Similar for our AI and cryptocurrency policies. So as far out as there's clarity that it will be an enforceable regulation, to the best of our ability, we'll reflect that in the reference forecast.
Okay, understand with regards to the reference forecast. Now, the 7 load scenarios there, do they all in sort of the similar near term include those credible pathways, or is the credible pathway exclusive to the reference load forecast and the others use what I would describe as target-based forecasting then?
I wouldn't call it a credible pathway. It's more an enforceable regulation. That framework of focusing on enforceable regulations, that's really the reference load forecast construct. And that's been a process refined over years because accuracy is important for the reference load forecast. For the low load scenario, we assumed that some of those policies would actually be walked back. And for the 2040 and 2050 GHG targets load scenario, we assumed a much more aggressive greenhouse gas emissions policies would be introduced.
Okay, so that's 2040, but in what I'll call the more near term, the 2030, 2035 timeframe, how does your answer update? Do they all include credible pathways, or once again they're based on regulation?
The low load scenario, by memory, it has emissions policies being assumed to be repealed or retracted earlier than 2030. The GHG targets load scenario, because we couldn't find a path to the 2030 target, it follows the reference out to 2030. So it aligns, it was a previous reference load forecast, but it aligns with the reference load forecast, which generally follows if it's a policy, it's an enforceable regulation. So yeah, but the low has almost immediately, we repeal thank you. Yes, we did. Yes, that's a good reference. If you want to look it up, it's BCUC IR 1.4.3 that discusses that. And there's also a little memo attached to that where you can see the targets load scenario described in more detail.
Okay, no, thank you very much for that.
Thank you.
Next is Mr. Ince online with the Commercial Energy Consumers Association.
Hello, good afternoon. I've got a question about mining electrification and a comment that was made by BC Hydro about an hour ago. So this morning we talked about LNG, and given that almost every LNG plant that's in operation is run off natural gas, but BC Hydro made a comment to the effect that mining and mining expansions need to be electrified. And so the largest demands within a mining operation are digging and transportation and grinding. And those loads have traditionally been serviced with diesel or natural gas. And so first question is, strictly, do the mines actually need to electrify to operate? And but the substantive question is, could these mines be up and operational in terms of producing ore before electrification using traditional fuel sources and be electrified at a future date? Is that a feasible scenario? Thank you.
Just to clarify with respect to the LNG, while it's true globally that LNG terminals do generally self-supply their own fuel, here in BC, we have a number of LNG terminals that are all electric. Cedar, wood fiber, they're both all electric. So in BC, the all electric approach is is not uncommon for LNG. For mining, they do use diesel. That's correct. And I suppose conceptually, if it were possible to get a natural gas pipeline to the mine, I suppose it's possible that they could generate their own electricity on site. I'm not aware of that ever happening in BC. Large-scale mines in BC do take electrical service. I'm aware of one smaller scale mine in the north that ran off diesel for a number of years, but it's a very, very challenging to make a go of a large mine without electrical service. And what we've seen here in BC is that the availability of electrical service is a key advantage to developing a mine in BC, and it's required for the large scale mines to go ahead. And these are mines in the hundreds of megawatts, so they're the big ones.
So can I tack on another question about LNG? Is it feasible that LNG operations could get up and running using natural gas traditionally, and then at a future date electrify? I've done enough engineering to know that the electrical driver equipment is smaller than gas. So retrofitting a plant with electricity drivers in terms of space should be feasible.
It's technically feasible for an LNG plant to use gas to self-supply. Here in BC, though, if an LNG terminal has its environmental assessment certificate, it's ordered all of its equipment and engineering system, it would be very challenging to switch to a different fuel source at that stage. But yes, if you're a brand new LNG terminal in concept, natural gas is available to that type of operation, and yes, it's technically feasible that they could entirely self-supply, and you do see that globally.
And one more follow-up question. I seem to remember that Minister Dix submitted a letter of April of last year regarding the electrification of LNG, that electrification would not be required unless the electric supply was available off the grid. What's your interpretation of that, and how does it affect your LNG forecast?
I believe you're referring to the policy clarification that was addressed in our response to BCUC IR 1.2.6 regarding service to new LNG developments and the net zero new industry. I think that's what it's called, the net zero new industry policy. It is our obligation to provide service to our customers when they request it, and it is our commitment to do so as well. The customer may choose to self-supply, that's their choice, and we do know that some customers do, and they'll self-supply until such time as electricity is available. That's already common in the oil and gas industry, and it's our commitment to provide electrical service, though, if it has been requested.
Thank you.
Great, thank you. Next.
Are there any further questions from parties, either in the room or online? Okay. Not hearing any, and I believe there are no questions from BCUC staff on this section. So are there any questions from the panel?
No, we have no questions either. So where are we headed now?
I think if the panel's comfortable with it, BC Hydro could continue with their presentation.
Okay. Yep. Please go ahead, and then in about 20 minutes or so, we'll take a break. Is that works out for everyone? You're good?
Yeah.
Oh, all right. Please go ahead.
Yeah. So Ms. Chubb talked about the load forecast and the scenarios, and I'm going to walk you through the supply side of things. I'll describe how much resources we need, the options available to meet that need, the consideration in selecting resources, and the resulting near-term actions. As I go through my slides, I'll focus first on energy and then on capacity. And I'm going to start off with the slide that briefly clarifies what I mean by need, because it's a term that I'll be using multiple times throughout the presentation. System need is the gap between projected future load and the resources that we already have in place or actively pursuing. This gap ultimately determines how much resources we need to plan for in the integrated resource plan. As an example, the graph on this slide shows the 2026 reference load forecast, which is the line at the top there, compared against the resources that we have in place right now, or that we are pursuing, that we are actively pursuing. When there's a gap between the line and the resources stack, that means we have a need and that we need to take action in the integrated resource plan to make sure we can fill that gap. This slide shows the gap for energy for the 2026 reference forecast and the 2025 reference forecast. So it's essentially the lines relate to the difference between loads and resources. And when the number is negative, it means the load is higher than the resources. And as you can see, the need in the 2026 reference forecast is greater than the 2025 reference forecast by around 2,000 gigawatt hours, and it persists throughout the planning period. The next question becomes, so what do we do about this need? And the first thing that we do is we always look at demand side management options to meet that need. They not only provide system energy and capacity, but they can also provide loss savings, because the savings happen at the customer meter. They can also reduce or eliminate or defer or eliminate the need for infrastructure as well. In the IRP, in the filing that for the 2025 IRP, we identified 2 demand side management measures that were part of our near-term actions. They are Energy Efficiency Program B and Customer Solar A. PowerSmart 2.0 is our customer-facing package of DSM over the period fiscal 28 to fiscal 30 that implements these measures from the 2025 IRP, as well as the continued implementation of the DSM that we started in the 2021 IRP. There was a workshop question from the Commission on how about the relationship between the numbers quoted in the PowerSmart 2.0 as well as what appears in the IRP. I can confirm that the numbers are aligned. To allow that comparison, we first recognize that all the numbers that are mentioned in the PowerSmart 2.0, so taking the 2200 gigawatt hours of energy savings as an example, they are savings at the customer meter. To compare that to our load resource balance, which is at the system level and includes losses, we need to multiply that number by around 11% to account for the fact that these will help reduce system losses. So when you take that combined effect into account, the numbers quoted in PowerSmart 2.0 equate to about 2,450 gigawatt hours that you see in a load resource balance. The next thing that you need to do to make this comparison is to look at the actual savings that happen in the period 2028 to 2030, which is the period that PowerSmart 2.0 refers to. In the load resource balance, there are some savings from the codes and standards that occur in fiscal 26 and 27, the savings which continue and are reflected in the load resource balance. So to make that comparison, we take those savings out. And so that's the 650 gigawatt hours that we reduce from the savings that are shown in the load resource balances. And then again, you get to approximately 2,450 gigawatt hours, illustrating that the numbers are consistent between PowerSmart 2.0 and the IRP load resource balances. It's a pretty similar calculation for the capacity side of things. And I can confirm that PowerSmart 2.0 places us on track to achieve both the energy and capacity savings from the IRP. This slide shows what's the need remaining after these DSM measures are put in place. And that's the green line bar at the very top there. And as you can see, there's still a gap between the loads and resources. And this is another view of that, which shows the DSM programs have brought the bold line, which is the need, closer to the x-axis, but hasn't completely eliminated that. So now we have to look at supply side resources. Most of the bids into the 2024 call, as well as the 2025 call, were wind and solar projects. And we believe that these resource types will continue to be the primary source of energy into the future as well. The submissions into the call and our resource options database include that there's a vast potential of these solar and wind resources available within the province to meet that need. The IRP has two actions that allow us to acquire the supply side resources that are required to meet the need. The first one is to acquire 5,000 gigawatt hours of energy from clean or renewable resources by fiscal 2034. We are progressing towards acquiring this target of 5,000 gigawatt hours. And there are two main streams to how we go about delivering that target. The 2025 call for power has already secured contracts for 4 wind projects, contributing around 3,500 gigawatt hours. And once you take attrition into account, 2,500 gigawatt hours that appears in our load resource balances. As an extreme, through subsequent calls, partnerships with developers, and projects arising out of negotiations with First Nations impacted by the North Coast Transmission Line, we expect to bring about an additional 2,500 gigawatt hours. So these two streams in total combine to getting us the 5,000 gigawatt hour target that we set out by fiscal 2034. This slide shows that, illustrating the extract at the top shows the 5,000 gigawatt hours of total through the two streams. And what it also shows that when we acquire 5,000 gigawatt hours by fiscal 34, it does result in a time-limited surplus of energy. While there is a surplus of energy under the reference load forecast, it puts us in a really good position to meet high loads should such high load scenarios unfold. In the next two slides, I will be talking about the implications of buying more and buying less, and how we have managed the implications of buying more and buying less and arrived at the 5,000 gigawatt hours of target. So this is an extract of table 3.8 of our IRP. What it shows is we acquire this 5,000 gigawatt hours and the reference load scenario unfolds. So this 5,000 gigawatt hours will be surplus for a limited time. And as load grows, this surplus keeps going down. Now, typically the price that we acquire the energy is less than what you do with the surplus energy, which is to sell it to the US and Alberta markets. So given that you are buying at a price which is somewhat higher than the price that you would get for that price for that electricity in the markets, there will be rate and cost impact. And this is what this table shows. What we've done is we've looked at different acquisition volumes. So we've looked at, okay, what if we acquired a bare minimum of 2,000, 3,500, 5,000, and so on. And this shows what would be the impacts compared against a baseline of acquiring a minimum of 2,000 gigawatt hours. So focusing on the 5,000 gigawatt hour number, as an example, we see that just because that number will result in a short-term surplus, there will be a rate impact of roughly 1.6% by fiscal 24. So the what we want, so when you look at this view, what you want to do is not go too much further down, because as you go further and further down, your rate impacts and cost impacts go higher. Now, let's take another view at the acquisition volumes. Now here, again, reminding that this is assuming we acquire this and the reference load forecast unfolds. The next view shows, okay, we acquire 5,000, but the high load scenario or the North Coast load sensitivity unfolds. And what that shows is what we acquire won't be enough, and it won't be enough by a wide margin. There would be energy deficits in pretty much every year under the high load scenario and the North Coast load sensitivity. So focusing on the 5,000 gigawatt hours again, it shows that by, say, fiscal 40, we would need 6,200 gigawatt hours more in addition to the 5,000 gigawatt hours that we've acquired. And here, the tension is, well, you don't want to go with a smaller number. You don't want to move to the top because, say, if you went with the bare minimum of 2,000 gigawatt hours, you're looking at, needing to acquire 4,400 gigawatt hours more in a very short period of time by fiscal 34, in addition to the 5,000, just to meet these high load scenarios. So the tension here, you don't want to move up. And in the previous slide, you don't want to have a bigger acquisition number. So what we've tried to do is balance these two considerations and come up with a 5,000 gigawatt hours as an appropriate balance. And as we were doing that, we thought about the potential consequences of being short, which is what this slide shows. And being short of energy and unable to meet load can have a dampening effect on economic development and electrification progress. And that we believe having that negative impact is greater than the time-limited impact of small rate impacts in the near term. And what I also want to say is the rate impacts that you saw in this previous slide, if it did happen that we found out we had acquired this 5,000 and it was the reference load forecasting that was unfolding and it seemed like that for a long period of time, we do have the option of reducing the demand side management measures that I mentioned previously. And by doing that, you can eliminate most, if not all, of the 1.6% rate impacts that I have shown here. So as such, we believe 5,000 gigawatt hours of acquisition was the right place to go with. So Ms. Jab talked about how the 2026 load scenario is now indicating load growth could be higher. So as if that trend continues, we would need to acquire more energy. And we have another action in the IRP, which says, okay, if that is happening and our load resource balances indicate the need for energy, we would likely do another call as early as 2028 to acquire that energy. And to show that illustratively in the load resource balances, we assume that that next call is going to be very similar to the 2025 call and it's going to get us 2,500 gigawatt hours. That number, of course, will change as we get more and more information, but we did want to signal in the load resource balances that if need does continue to go up, yeah, we will be taking additional actions to acquire more energy. Now, let's talk about capacity. And again, this is a very similar picture to the energy side of things. The dark blue line shows the need that was foreseen under the 2025 reference forecast, and the line below shows what is the view under the 2026 reference load forecast. And as you can see, there's an immediate need as high as 200 megawatts under the 2026 reference load forecast. So overall, the 2026 forecast increases both our near-term urgency related to capacity as well as the longer-term capacity requirements as well. There was also a workshop question from the Commission about the period before fiscal 30. The table at the top shows the surplus deficits that could be expected for the period fiscal 27, 28, and 29. While there is a surplus in fiscal 2027 that goes down quite quickly, and we are pretty much at load resource balances in fiscal 28 and 29. What I do want to note, the Commission question asked us to show the gap without both island generation and MacMan. This does include MacMan simply for the reason that we do have an existing electricity purchase agreement with MacMan that expires in October 2029. But the picture does not include the capacity contribution from island generation. So next I'm gonna focus on these the resources that we have to meet that need, and focusing on the near term first. And as with energy, we focus on demand side management measures first. As part of the 2025 IRP and the actions from the 2021 IRP, we are already undertaking significant DSM efforts related to capacity focused DSM, including time of day offerings, demand response programs, and industrial load curtailments. These are expected to yield close to 350 megawatts by fiscal 2030. Again, 350 megawatts, which is a pretty significant number. Additional demand side options that can provide capacity are very limited. In our resource options database, we have demand response program B that we have identified. It can provide around 28 megawatts once you take into account that these are available only for a short, for a limited number of hours during the day, and it is also quite costly. Batteries are another resource that's generally talked of as having fairly short lead times. We do have a 50 megawatt battery project on Vancouver Island that is an initiated resource from the an action from the 2021 IRP. And as we progress with this project, our experience has shown that similar to us thinking about batteries, pretty much all utilities across North America are having that same thought at the same time. And the battery project that we had initially thought could take around 3 years is probably going to take 3 to 5 years, and there is a real risk that that range could be exceeded as well. So again, when you look at the near-term deficit that on capacity that needs to be met, batteries are not really available as a solution. We do have 2 gas-fired generating facilities on our system with existing electricity purchase agreements. The MacMan facility in Taylor, BC, and the island generation facility on Vancouver Island. Our electricity purchase agreement with the MacMan facility expires October 1st, 2029, and the one with island generation expires in October 31st of this year. They can provide around 400 megawatts of dependable generation around the clock and during our winter peak. Within the spectrum of resources that we have, these are the only capacity resources that can provide the required megawatts with sufficient certainty and are also cost effective. And as given that these are the only viable options, we have an updated near-term action in our 2025 IRP, which was identified in the May 28th submission. And that is to continue the operation of the island generation gas facility and the MacMan cogeneration facility to provide approximately 400 megawatts of dependable capacity. Obviously, these are GHG emitting facilities and unclean resources, and I would like to clarify their anticipated use. The McMahon facility will be used only until 2034. That is in alignment with the time when the federal clean energy regulations limit the use of natural gas facilities. The McMahon facility is estimated to produce around 340 kilotons of GHG every year. And that is calculated based on standard published emission factors, and this is a number that we publish through our annual reporting every year. The island generation facility will only be used when needed for peaking. We operate it only when we really have to, and we expect the emissions from this facility to be around 10 kilotons per year. And that is reflective of recent history where it's operated as a capacity resource. We are not at this time determining the long-term role of island generation within our system. And in our load resource balances, we have shown it capacity throughout the planning period. Its role over the longer term will be evaluated in future IRPs based on system as well as regional needs. It is on the Vancouver Island and applicable policies at that time. On this slide, I want to start off with an answer to a question from the Commission, which is around the 500 megawatts of capital outages that we have set aside to carry out outages at our generating facilities. And the question from the Commission was whether reducing that allowance can avoid the need for island generation and McMahon. Our heritage system, it's aging, and we do need to carry out outages quite frequently to replace end-of-life components. Reducing this allowance as a potential alternative to island generation and McMahon, so not taking outages for a few years and not renewing island generation and McMahon, does carry several risks. Our loads could trend higher than the reference load. And if we have reduced the outages and we don't have island generation and McMahon, we have nowhere else to turn to because we've reduced the allowance that we had and now load's gone higher and we don't have any other options. The second reason, it's illustrated by the numbers on this slide. So this again is an extract from our load resource balances, and it shows the resources that we have started to acquire but haven't come into service yet. So these are things like the 2024 call for power, the battery pilot that we have going on the island, the demand side management measures, again the 2025 call for power, as well, and so on. So again, these are projects that we've started, or demand side measures that we've started, but haven't come into service yet. There's around 700 megawatts of capacity from these resources. There is always the risk that some of this capacity could be delayed. And again, if we had reduced the outages and hadn't renewed the McMahon and IG island generation capacity, again, we would have little alternatives if these resources were delayed. And finally, and I believe most importantly, we need to think of the reason we have the capacity outage. As I said, we are, like, our system's aging, and we have this outage allowance to replace units that really need replacing. And Mica 1, 2 units are a really good example. So these units are like 40 years old, and the turbine runner blades on them have cavitation damage. So every 3 years, over the past few years, we have had to take out the turbines, do preventive maintenance. And at some point, if you keep doing, not replacing them and keeping them going, there's a real risk that you could have a failure at one of these units. Worst case, it could be a catastrophic failure, which not only takes that particular unit, but reduces the output of the entire microgenerating facility as well. So given all of those reasons, we believe that reducing the capital outages is something that you really need to hold off until you have absolutely no other alternatives left. And that's why we believe that proceeding with island generation and McMahon is the appropriate course of action. And as I wrap up on this particular near-term action, I want to reiterate the certainty that island generation and McMahon bring us existing facilities. Now, we could contemplate, okay, let's try doing batteries and maybe really push and see if we can get them in 3 years, even though indications are it's going to take probably 5 years or more. Having said that, we are talking about capacity. Our peak load happens when it's sub-zero temperatures here in Vancouver, and it's -40 in places like Prince George. The Arctic outbreaks that bring these peak loads can last as long as 2 weeks. In 2024, on January 11th, the Alberta system hit its peak load. On January 12th, the BC Hydro system hit its peak load that same year. On January 13th of 2024, the Bonneville Power Authority to the south of us hit its peak load. The Alberta system operator issued multiple energy emergency alert level 3s, which is the last step before forced load shedding. There were also entities in the US Pacific Northwest who were placed either on an energy emergency watch or were issued energy alert level 3s. BC Hydro did not have any issues, but if we did, it's safe to say we probably weren't going to get much help from our neighboring jurisdictions. And that really gives us a sense of how important it is to have capacity with certainty within the province. And so through our near-term action, what we are trying to do is get the capacity from IG and McMahon, while at the same time making sure that we are taking action to bring clean capacity resources over the longer term. And with that, I believe this might be a good time to pause for a break or for questions.
No, that makes sense. That would be good timing. Mr. Bear, is there anything I need to do before setting a break?
No, I think if this is the time that works for the panel, this certainly works from my perspective.
Okay, so we'll start again at 3:15. All right. Thank you very much, panel. Thanks for your presentation. You're now waiting for questions. Is that right? Or is that where we are?
That's right. And before that, yes, Ms. Japp would want to make a clarification.
Thanks. Yes, I want to make a correction. Earlier, I was speaking from memory, and I was referring to the Q study that was discussed in the 2021 IRP proceeding, and you can find it in Exhibit B49 of that proceeding. And I was discussing the number of projects that enter our interconnections queue that actually make it into service, and I misquoted that study. 2/3 of the projects that entered the interconnections queue did not make it into service. I think I had it mixed up. I think I said 1/3, but it's 2/3. So 1/3 proceed to making it into service. And the 3 years that I cited from entering the queue to reaching in service, that study included a number of expansions and brownfield projects, so mine expansions. So it reflects that mix, and it wasn't entirely new projects. Thank you.
Great, thank you. Whoops. Mr. Bear, please go ahead.
So I believe before the break, Mr. Craig for the CEC Online had his hand up. Were you still looking to ask a question, Mr. Craig? We'll move on to people in the room then. Next will be Mr. Lusney for the Clean Energy Association of BC.
Hello again, and thanks again for a great presentation. If we could go to slide, I think it's 58. If my rough calculation is correct, 58, sorry. There we go. That BC Hydro is assuming for the 33.5 terawatt hours that there were experience of roughly 30% attrition rate. And is that expected to continue for all renewable energy procurements? And also, how did you come to that assumption?
It's a very good question. As I mentioned before in my remarks, we haven't done a call for energy for 15 years. Our experience when we did the last call was that 30% of the projects that were given the EPAs or energy purchase agreements did not move forward with actual interconnection to the system. So when we did the 2024 call, we assumed that it will be a 30% attrition, and we carried that 30% attrition into the 25 call. Given that we haven't seen any attrition on the 24 call, all 10 projects are moving forward. We don't have any other benchmark than the call that we did 15 years ago. I would say there's a couple of things that one should keep in mind when you compare the last call versus the 24/25 call. One is what we are finding is that the quality of the proponents for these two calls is actually quite technically superior compared to the one-off projects that bid into the last call 15 years ago. So I think that gives us comfort that the industry has matured. They actually gained a lot of international experience, and the companies that are coming to BC have diversified their portfolio, and they're bringing those learnings to BC. So I think that's a positive thing that we have seen. And second thing I would say is there's a lot of financial backing that's provided for these proponents through the Canada Infrastructure Bank, which gives that financial security that was not there for the call that happened 15 years ago. So I think there's a couple of very strong things that have been embedded in these two calls that give us a comfort that perhaps the attrition may be different, but at this point we don't have anything else to base it on except for the fact that we had 30% attrition before.
Okay, that makes sense. And I would say no, not only has the industry matured, some of the actual proponents themselves are better financed than BC Hydro, just given who they are. Sorry. Go ahead.
No, please.
Okay.
Yeah, I did want to point out information request, the response to an information request where we discussed this, where we talked about the basis for the 30%, as well as what factors could influence this attrition rate, such as like potential tariffs. So that's BCUC 114.2.1.
Okay, excellent. Carrying on with that kind of thought, can we go to slide 65? So did I hear correctly, because of BC Hydro's challenge with their pilot 50 megawatt and the timelines of 3 to 5 years or more, that the expectation from a capacity point of view that battery energy storage systems are not a viable option now? I guess just trying to understand the timeline, 3 to 5 years, and risk that it's greater exceeded.
In our information responses, we did submit 3 verifiable timelines from recent projects that had battery projects that had verified start to in-service dates, and those were in the 6 years plus.
Yeah. And I was looking at the response to the information request where we detail that. So this is the response to BCUC IR 110.4, and I want to say this is not a BC Hydro problem. So there we've listed three examples. So from Ontario, where it took like 7+ years to get a battery, Massachusetts 8 years, and Maine 6+ years.
Okay, I think one of the questions for it in hearing that is looking at both the experience you've had with renewables and the maturity of that sector, the same with the battery sector. So Ontario has put in just under 3 years over a gigawatt, and that is where competitive pressures and the allocation of risk away from the system operator, or in the same case what would be the balancing authority here is BC Hydro. And so this comes back to the other kind of question of, there is a difference in both capability and risk tolerance between the Crown Corporation on behalf of ratepayers and private entities coming forward. So I think just trying to understand the comments on the timelines, and then with the 450 megawatts, is that expected to be a procurement activity or an internal BC Hydro build? Yeah. And how that risk is incorporated into the IRP.
So we are in the early stages of developing our procurement strategy. As I mentioned before, for the 50 megawatts, we have actually identified a substation on Vancouver Island, southern part, where we can actually locate that battery. And given the fact that Vancouver Island has a net deficit on the generation, because most of the load is served from transmission coming from mainland, it makes sense for us to locate that battery or a capacity source there. It is close to strong transmission system. That's why we chose that location. As we go through our discussions with the market regarding the initial is going to be a request for interest that we are going to be going to the market in the next month. Based on that, we will actually cull the numbers down to proponents that we feel can meet our requirements, and then there's going to be a formal RFP in the fall timeframe. And we expect that we'll be able to award the procurement for that by the end of the year. That's the timelines right now. And it's quite possible that we may be surprised with this 3 to 5, and the market is such that they may respond back with a more favorable timeline. At this point, we haven't tested that. One thing I can say is we have tested the battery market on our non-integrated systems, which is the NIA, and we are working closely with the First Nations in terms of reducing the diesels there. And our experience over there with the battery suppliers that we talk to, it is a challenging field, especially because it's non-integrated. And we are not seeing the timelines that we had expected there in terms of the projects. I hope that's not the case for the integrated system, because there's a lot more experience with larger grid scale batteries. So, but we'll know more in the late summer, early fall timeframe.
Okay, so I think the only comment, and not really a question, but it's a comment on that, is the more prescriptive the design and where you're going, the less flexibility, and it can lead to issues. And the experience right now in Ontario with the third line of supply to Toronto is that they've overly designed the procurement and left very little for both technical options, but also partnership options. So again, back to being too tight means that the communities and First Nations are somewhat locked in.
I think the other thing we are looking at is over here, it talks about the 450 megawatts. we are keeping that optionality open. So we are starting off with 50, depending on how the load materializes, what the responses from the proponents is. I think we'll then land on the actual number, but we are starting off with a 50 megawatt, which was identified in the 21 IRP, but with an optionality of expanding it if the high load scenario becomes the reality.
Okay. Can we go to slide 60? I believe it's the table. So first up, I do want to very much commend BC Hydro on this analysis and this look. This is not just innovative; it is a 2 or 3 levels down to giving insight to stakeholders in the commission on the challenges of planning the system, the uncertainty that's involved. So I think that's great. There is some issues. One is in assuming a net cost to utility. I mean, BC Hydro has an affiliate trade electricity marketing. My assumption is that they do not lose money on most years. So when having excess, that they can make a profit at times. But more importantly, the net utility cost seems to go up linearly as you have excess, and I would have expected it to have gone up exponentially. In other words, if you have some excess, your power marketing should be able to find the highest value if they are worthwhile. If you have a lot of excess, now you're running further down the demand curve.
So maybe
I'll just add on to that, because you've landed right on a question that I was going to ask as well. It was just how you got the price estimates for sales of any surplus. Like what were the assumptions you did? I do appreciate this question.
Yes. So I'll talk about how the net utility costs was derived, and that feeds into the rate impact analysis as well. So what we looked at was
what I was asking though is like the value you got for the
Yes.
surplus, the assumption.
Yeah.
Okay.
Yes. And so we looked at the surplus that is there in fiscal 40, and then we looked at the price of mid-C, less any wheeling and losses associated with that, and that was the revenue that was assumed to be achieved for that surplus. We did test that out. So we had this analysis shows the numbers under our mid-market price forecast. We did do analysis, a sensitivity analysis on a low and a high, which is presented in Appendix H of the application, which showed, okay, what if the revenue from the market sales of energy is higher than our mid price, and alternatively, what would it be if the market prices were lower? So it showed that range. So the numbers there, the middle column is essentially buying energy at our long run marginal cost, so around $97 per megawatt hour, and then disposing it at the market price. To the question on how this compares to the revenue that PowerX generates, this again is a view of this acquisition and the fact that we buy energy at $97 per megawatt hour, which is our long run marginal cost for energy and the best estimate that we have for clean energy acquisition, and compare that against the revenue that we would get for that same energy if it sold it into the market. It is not an estimate of PowerX revenue. It's just comparing that energy being bought at a certain price, sold at a certain price. And given that, yeah, it's just incremental volumes, it goes up linearly. And in terms of this volume compared to the markets themselves, it is like, given these are really small amounts, they really would not impact the revenue that we get. So if we were trying to sell like 6,500 gigawatt hours of surplus against 5,000, that incremental 1,500 is so small given the grand scheme of things in the market that it would not change the price that we're getting.
Thanks. Sorry.
Okay. I think the key message over here is that what we are selling here is energy. Unfortunately, the energy market is such that if your marginal cost is what Sanjaya talked about, the actual price you get for energy is less. If it was capacity, that's a different issue, because that's where the revenue comes in from the capacity side, not the energy side.
Yeah, and I know not part of the scope, but I mean other jurisdictions with Crown Corps like BC Hydro are looking to have blended and firm products to sell, to be able to add to meet their internal needs, but then also maximize their revenue. And I guess is it right in my assumption that the calculation doesn't include any of the value if you oversupply in the short term to allowing faster economic development? So we've had talks about the ability or challenges of connecting industrial customers or allowing industrial customers to ramp more quickly. Do you have both the wires, transmission adequacy, and then the energy adequacy? When you have some excess, you can allow those customers to move on their own economics, not have to wait for BC Hydro to build out or expand the system. But that's not included in kind of this rough analysis.
Between this slide and the next slide, that's the picture that we are trying to paint. So in this slide, we say we acquire 5,000 gigawatt hours, and there's really load is not showing up, and here's what we've got to do. But I think what really answers your question is the next slide, which says, okay, if we had acquired 5,000, well, by fiscal 34, that would not have been enough. And if it was not enough, that might be impinging on our ability to interconnect our customers. So this really paints the picture why we should not be buying a small volume of energy, but really trying to make sure that we position ourselves to not only meet the reference load forecast, but have the flexibility to move up and meet high load scenarios.
Okay. You can stay on this slide because this is where my next question goes. One of the things that appears to be missing, and so just trying to get an understanding, there's the planning need of the system, which is like an annual, this is how much consumption I have, this is how much energy I have committed, these are my shortfalls. And I think, again, a great piece of analysis to show why you landed at 5 gigawatts, even though your reference was lower because of the risk of it. But there doesn't seem to be kind of a longer term plan, given the various scenarios that you have on the load side, to how the procurement roadmap would follow up. So what would be the step functions? Because you're not adding new energy on a year by year basis, you're procuring and adding it kind of in 3-year chunks or whatever. So how that view would come in, then I have a follow-up question.
Sure. I think we've referenced this IR before, which is BCUC 1.4.5, where we actually talk about if the load scenario goes beyond what we have discussed in our plan, how we would actually go ahead and deal with the energy capacity and transmission. And I think from an energy perspective, because that's what you're focusing on, our approach is we can actually replicate the calls on an ongoing basis. And in the IR responses, we have talked about the fact that the next call for energy could be 2028. The timing of that would vary depending on where is early in the year or latter part of that year. But I think that's what we think is a 2-year cycle, which gives us that ability. And in that 2-year time period, we know how much energy is required, how the load forecast is going. So I think our approach towards energy is very straightforward. There's a lot of energy in the market, which you have seen from the 2 calls. There's a lot of potential out there that we've talked about, and we can actually take advantage of that through these replication of the calls that we can do in the future on a 2-year cycle. And at the same time, we are exploring our own development as well as looking at partnerships with First Nations, because we are building a lot of infrastructure in BC. And if you look at the North Coast transmission line, that comes along with a discussion around energy in that area, along with the transmission. And as we build more transmission lines, we need to explore those. And the example that comes to mind is when we built 5L83, which was the ILM project in 2014. We actually worked with a couple of First Nations to talk about energy procurement in that area at a small scale. And one of those projects actually connected to our system last year. It's a 15 megawatt solar plant that was connected. So I think as we build the infrastructure around our province in terms of the linear requirements on transmission, that also allows us another avenue to work with the First Nations in terms of the energy requirements that can be combined together with that infrastructure.
Okay.
If I could add something, as Ajay said, we could replicate the calls on a frequent basis, and I think we've given a pretty clear indication of that in this IRP. So this particular slide, which describes, okay, going beyond the 5,000 gigawatt hours, what would we do, right? So here we've said we could get an incremental 2,500 gigawatt hours by fiscal 2037 through a call as early as 2028. And I think that sets a really clear signal, okay, this is what we would do if load does keep growing.
I think the question I have, so that all makes sense. And I think one of the challenges that comes in is how BC Hydro landed on a single 5 terawatt hour call versus breaking down and going, and this is back to the point I made on setting up for fast and slow versus stop and go, and having more consistent procurements, which are laying out, but having an amount that is manageable for the communities that are involved and have to stakeholder, and for BC Hydro itself in terms of building out the system and the challenges in connection, because it's not just on the generation side that this comes. You are building it for load where there's load connection. So I guess if there can be any insight on how the 5 terawatt hours was landed on versus say a 3 and 3 terawatt hours, when you kind of look at that table, that kind of seems to make, and like as a commitment, we're going to do one this year for 3, then we're going to do another 2 years for 3, and then another 2 years for 3, and we'll speed up and go faster as we learn more each year.
So I think the 5,000 gigawatt hours that was procured in the 24 call, as I said, it was after a hiatus of almost 15 years.
Yeah.
So we wanted to send a signal to the market that we are there to actually acquire a substantial amount of energy. Because under a certain amount, you don't get that market traction. So I think 5,000 was the starting point for us to send that signal. When we started looking at the 25 call, initially we had talked about the 5,000 gigawatt hours again in terms of the approach. As we were developing that, we also had other opportunities at our disposal. So if we had gone with another 5,000 gigawatt hours through the 25 call, we would have over procured because there's other options we are looking at. So it became a balance of trying to figure out what that level is, and we landed on 3,500. And the other thing to keep in mind is, in our opinion, anything less than 2,000 gigawatt hours of a call doesn't send the right signal. So you won't get that interest from the market to actually bid in the prices, bid in the projects that we are looking for. So I think there's a bare minimum that you need to test the market with, and under 2,000 is something that we feel is not going to send the right signal.
Yeah, probably not the right form, but I'll say that it's actually the longevity and consistency and not the one-time calls, because there's setup, and in particular in Canada and even more so in BC, the relationships that you're trying to build with First Nations and the design requires timeline and runway for it, and therefore knowing that you're going to have multiple shots at something means you can get a project that works best for the two partners. And that
fully agree with you.
Okay. The last kind of question in all of this, just to be clear, the expectation for the values that have been put forward, the expectation for BC Hydro is all existing EPAs are renewed and continue to operate for the foreseeable future. I believe that's in there, but I just wanted to make sure.
Yeah, that's our assumption in our load resource balances. I think like our contract management team does make adjustments where they believe if some project does not have the capability to continue, of course they will take into account. But yes, the continuation, the renewal of EPAs, existing EPAs, is the assumption in the load resource balances.
And there's no assumption that they would be part of any competitive procurement or repowering, or, and we've talked about firming capacity, the ability to make adjustments to provide better operability of firming services.
The acquisitions here that is in the IRP are for greenfield projects.
Okay, but the repowering is just, or not repowering, the EPA renewals just continued operation.
Yeah, so the assumption is they would be continue as they
I think your question is, as those EPAs come up for renewal, is there a call for power, or is it, those are one-off discussions that happen? So as their term comes up for renewal, we have a team that actually specializes in those renewals, and we'll have those discussions. And if everything points to the same level of energy, or same in the same spectrum of energy that they have done before, acquired before, then we would move forward with those commercial discussions.
Yeah, you're starting to see other, because we've never really had this renewal of generation before. Now this is the first time all jurisdictions are coming at this, and you're starting to see a bunch of other jurisdictions look at it and say, okay, I'd like to have similar competition, both from existing sites that could repower, existing sites continue to operate, sustainment capital versus a new build. And then to manage that risk, and you talked about before, when you make a contract signing, at least the way we do it now, it's 30 years. One way to balance ratepayer risk is to say, okay, I'll take a bunch of 30 years, similar to how a government does its bond, but I may look at taking 10 years for certain ones and 20, which will allow you to better manage your uncertainty of your load forecast. Okay, thank you.
Next is Mr. McLaren online for the First Nations Energy and Mining Council.
Yeah, good afternoon. Thank you. I think a lot of what I was going to ask was just covered, but I do have one thing if we go back to slide 58. Yeah, thanks. And on this one, I just wanted to ask, so for the second tranche of 2,500 gigawatt hours there, my question is BC Hydro agnostic in an IRP context to which of those three procurement styles are ultimately chosen, like future calls for power, partnerships with third-party developers? Because it seems to me, as we've discussed already, like those would have different characteristics and implications for both their ability to satisfy BC Hydro's planning objectives, but also like provincial policy and legislative objectives, and would also have different cost profiles. So I'm just wondering if you can comment on that.
So I think if you look at the three streams that are in that right-hand column, I would start off with saying the NCTL project, which is the bottom bullet. That is something that is an active project, is moving forward. So anything that's driven through partnerships in that project would be quite important for us, because that project is important, as we discussed before, in terms of the load serving capability for BC Hydro, for the mining as well as LNG projects. So that is the fundamental thing that we'll be exploring as first. We also want to look at our partnerships with third-party developers, and this is again a new approach we are taking. We don't have much experience in wind development on our own side, but we want to see the competitiveness of that versus what we are seeing in the two calls we just finished. And I think after that, if there's still need for energy, that'll then drive the future call. So I would look at that as a timing that we can play with, because we have the ability to actually, as I said, either early 2028 or late 2028, and the level of energy we procure would be a discretionary number in that future call. But I would say that the First Nation discussions with the North Coast transmission line is absolutely critical for us, and also the exploring of third-party developers to look at our own wind potential.
Okay, I think that answers my question. Thank you.
Next is Ms. Worth online with Costco.
Thank you. Leah Worth, for the record, WORTH, asking question for Costco et al. I was just wondering, because we've had, in the application, we had the reference of the $97 per megawatt hour for the LRMC. And I was just wondering if you could put on the record what the average energy purchase agreement cost was in dollars per megawatt hour based on the 2025 call for power. And then what would the resulting LRMC be based on that in 2025 dollars?
For the 2025 call, we actually haven't submitted those energy purchase agreement pricing to BCUC. We are expecting to do that sometimes in August. And that is when we will be able to share those average prices for the 2025 call.
Okay, all right. I'm just wondering, we obviously at this point we don't know, but let's sort of just follow the trends, which is everything's getting significantly more expensive as we go along. So if we've got the higher 2026 reference load forecast, and then potentially a higher LRMC that would come from the call, and again, that's an assumption. I'm just wondering why the system supply load balance in Exhibit B8, why it doesn't include an acceleration of the Energy Efficiency Program B.
Sorry, could you repeat the exhibit number, please?
The exhibit number? Oh, it's the system supply load balance that's in exhibit B8. But you know, it's basically just sort of the system supply load balance. And I'm just wondering, you know, if we've got this sort of situation where things are accelerating, we have a potentially higher LRMC, we've got this higher reference load forecast for 2026, why we don't also see an acceleration of that energy efficiency program B.
And so just to clarify, I think she wants you to initially accept her premise that your long run marginal cost will be going up significantly. So that's what I think I was just hearing from Ms. Worth.
Well, I'm asking for an answer based on sort of that assumption, which is, you know, I don't think it's out of line. I'm not asking you to accept that that is indeed the case. Obviously, it's premature for that. But if that was the case, or if that's a reasonable assumption for BC Hydro to act upon, and Hydro agrees with that, then I'm just wondering, why don't we see this acceleration of that program?
Yeah, so as Mr. Kumar mentioned, we will be sharing the bid prices of the 2025 call later this year. In terms of the energy efficiency B and more broadly demand side management programs, so that is what we're trying to do under the Power Smart 2.0 that I mentioned. So with that, we are in fact going quite strongly with implementing both the energy efficiency measures from the 2025 IRP, which is Energy Efficiency Program B, and Customer Solar, and as well as the initiated programs from the 2021 IRP. There isn't really much room to accelerate energy efficiency. There can be very little, and when you look at Energy Efficiency Program B, like the volumes are really small. So in fiscal 30, you have 207 gigawatt hours. In fiscal 31, 269 gigawatt hours. So again, acceleration might, if possible, might result in like maybe 20 gigawatt hours coming sooner. It certainly won't do much for the energy load resource balances. But again, the Power Smart 2.0 is really what we're trying to do and trying to get these savings as quickly as possible.
Thank you. That was it for me. Thank you.
Next is Mr. Manhas for the Association of Major Power Customers.
So other folks have touched on a few of the questions I was intending to ask. I'm going to jump around a little bit. If we could go back to slide 60. My first question was with respect to the first column in this table. So we've heard from you about the attrition factor that's built into the assumptions around the calls for power. So when we look at the 3,500 gigawatt hours in this table, is that actually based on 2,500 applying the attrition factor, or is that based on actually procuring 3,500 gigawatt hours of energy?
The numbers in this table are post-attrition factors. So the 5,000 is a post-attrition number.
Okay, and so to the extent that attrition is lower than BC Hydro is anticipating, the rate impacts that we see here would be higher in F2040, correct?
I think the attrition is such that, yes, definitely it could be lower, but there is the possibility that it could be higher as well. And the 30% that we've used is based on our experience from previous calls as well as experience across other Canadian jurisdictions.
But perhaps I misheard, but I think Mr. Kumar was speaking earlier about some of the factors that were leading you to believe that there may be less attrition than was anticipated originally.
Yeah.
Is that correct?
I think what I was trying to convey, and perhaps I should have been more clear, is because the call happened in 2024, we don't have enough time since the call happened to actually make that determination. Early indications, as I said, the quality of the proponents is stronger. There's financial backing that was not there before. But I think typically attrition happens as now the time is coming to that point where we would start seeing some attrition on that. But we haven't seen that. So I think it's still early for us to comment on whether 30% is right or not. But I think that's the best information we had when we made that decision around the gross number versus the net number.
Okay, thank you. And if we go to the last column in the table, I note the rate impact there is for F2040. I just want to confirm the surplus energy would be coming online starting around F2034, correct?
That is correct. The call is the way we structured the near-term action is to get the amount by fiscal 34. That's how the near-term action is worded.
And the rate impacts in fiscal 2034 would be higher than what we see here in this table?
That would depend on the load that was unfolding and whether that actual volume of 5,000 gigawatt hours came into service. So yes, if the 5,000 gigawatt hours came into service exactly as planned in fiscal 34, and if the reference load forecast was exactly as it is and unfolded in fiscal 34, yes, the rate impacts would be higher than the rate impacts in fiscal 40.
Okay, and I think we've heard a fair bit about the uncertainty in planning. The further you go out, the harder it is to forecast. You'll agree with me, though, that the reduced rate impact in fiscal 2040 relative to fiscal 2034 is based on continued load growth in that period between fiscal 2034 and fiscal 2040, correct?
Yes, and again, recognizing this is just the reference load forecast. And with the load growth that's expected under the reference load forecast, yes, the surplus keeps going down, and it is a very time-limited volume of surplus. And yes, by fiscal 40, it's lower than the surplus in early years, which I showed you in another slide. It's again quite important to recognize this is under the reference load forecast, and load could always be higher, and recent indications are that load could be trending high as when you look at the the 2025 reference forecast and the 2026 reference forecast. I do also want to say that this is an extract from the 2025 IRP filing, which was using the 2025 reference load forecast. If we just put the same numbers through the 2026 reference load forecast, these numbers would be much, much lower. And by fiscal 40, you probably would not even be having that rate impact, but we have not carried out that analysis.
Okay, thank you. And I just wanted to confirm this rate impact is limited to the cost of energy procured and doesn't include any incidental costs or additional costs that BC Hydro is incurring over that period of time to build out the system.
Could you explain what you mean by incidental additional costs?
Incremental, for example, costs associated with expanding the bulk system to accommodate flows of energy.
So again, this analysis focused on looking at the impacts of this particular near-term action, and it is limited to that.
So I think just to clarify, because what you're trying to get at is there's an interconnection cost associated with connecting these IPPs to the system. And I was just confirming with Sanjaya, the marginal cost that we use for calculating the net utility cost includes the interconnection and any impacts on the transmission system. So it's not just the bid price from the IPPs. The bid price is escalated for the interconnections and the transmission system based on our experience. And then we compare that to what we get in the mid-C to calculate the net utility cost. So I just want to clarify that there's an evaluation that is including all the transmission and interconnection.
Okay, thank you. And one question about the mid-C assumptions that were in the analysis. I know when this application was filed, the question of geopolitical risk was a big question. Was there any sensitivity analysis done around potential restrictions, trade restrictions in terms of energy sales to mid-C as part of this analysis?
In terms of trade restrictions, the answer is no. But what I would like to say is we did test out a range of mid-C prices. So we tested, these numbers are based on the mid market price forecast. We tested out the impacts under high market price forecast as well as a low market price forecast. Now those highs and lows could come on due to a variety of factors. It could be, trade restrictions, different generation build-outs, but they represent, okay, what is the uncertainty associated with that? And those numbers are in Appendix H of our application.
And so it is ratepayers at the end of the day who will be bearing that market risk of what prices BC Hydro can obtain for this power to the extent it's necessary to export it.
So again, going back to what we are trying to do is we recognize, and that is what we've tried to illustrate, that if we do acquire this volume of energy, and if the reference load unfolded, yes, there is some rate impacts. And of course, those rate impacts would be on the ratepayers. Those could, of course, say, if we looked at the higher market price forecast, those rate impacts would be lower. And again, like I mentioned, if we replicated this analysis with the 2026 load forecast, those rate impacts would not be there at all. But again, we definitely recognize the uncertainty around this analysis.
I think I just want to make a comment here in terms of how planning is done for energy and capacity. So if you look at 2040 under the 2026 load forecast, by 2040, we are expecting the load from an energy perspective to be about 80,000 gigawatt hours. So as a utility, we cannot precisely manage our system energy to 80,000 gigawatt hours. That is just too tight a risk for any utility to take, because anything that changes from the reference load forecast means you're in a deficit. A deficit means you're not actually meeting your self-sufficiency requirements that are part of the Clean Energy Act. So I think it behooves a utility to have some level of cushion when it comes to energy and capacity, because you don't know what that uncertainty in the future looks like. So I think given the fact that you're talking about a base of 80,000 gigawatt hours of energy by 2040, I think the incremental surplus that we are talking about is actually something that a good utility practice would require some BC Hydro to actually have, so that we have that flexibility on the system.
You'll agree with me, though, that the current procurement of energy is not necessarily to be done today in order to achieve forecasts that are for 2040, correct? Like the timelines are not such that you need to be procuring today for 2040.
So the tension we have is, if we can bring resources today, energy and capacity, yeah, we wouldn't be needing surpluses at all. We can just see what the load is unfolding and we can bring them as needed because they have a lead time of 0. But as Mr. Kumar said, well, there is the fact that, these energy projects to a lesser extent, but capacity projects have much longer lead times as do transmission projects. So we've got to look at the future and we've got to see what our obligations are. We've got to meet the needs of our customers. We've got to meet self-sufficiency requirements, right? And we do have to think of all of that. And honestly, planning is such that, well, it's an uncertain thing. So we just make the best decision based on the information that's available at this time. And so that is what we've done.
I think the other thing to keep in mind is the timelines for new energy are somewhere from 5 to 6, 7 years, even when you start a call. So there's a wide variance of timelines depending on how much progress has been made for some of those plays that are part of the call. And the other thing we have to remember, and Anthea talked about this, the impact of BC Hydro's power on the province is immense from an economic development perspective. And we need to understand that the role of BC Hydro is actually now to look at economic development and be a facilitator for all these things that are being talked at the provincial level and at the federal level. You don't want to be in a situation where you are short of energy and capacity because you're just running things too tight on the system. So I think all that in terms of looking at the impact, look at the announcement from the minister and our CEO yesterday. There's a huge burden on BC Hydro to actually facilitate that economic development. And for us, we need to plan that, and we need to have enough energy, we need to have enough capacity and transmission capacity for us to actually facilitate that role. And I think that's what we are trying to find, the right balance with these near-term actions and making sure that we have that ability to actually move quite fast. And even the case in point is, you look at the reference load forecast in the 25 IRP versus the 2026 reference load forecast. Within a year and a half, our life has changed from a reference load forecast, and the numbers have increased. So I think that is how the market is moving right now, and we need to have that flexibility in our near-term actions and our procurement of resources that allows us to actually facilitate that role in the province.
And to be clear, I wasn't disputing any of that broader context. My question was just narrow and specific to the question of 2040 and the relevance of today's energy procurement.
Well, and just if I can throw in something for all, yeah, I think this is a case where I understand why you're trying to provide that broader context and rationale for what you're doing, but you've said it several times, so we're with you on that now. And I think his question was quite specific, and you kind of answered it fairly quickly with saying some things are short run, some things take longer to build. You know, maybe you're going to do a nuclear plant or whatever. So I'll just encourage us to do that as we go forward. Thanks.
Thank you. And that does lead into my next series of questions, which I think are my last. We had talked earlier about the question of off ramps, and I said I'd come back to this after this presentation. And so if I heard things correctly, essentially the concept is that energy procurement's being dialed up, and to the extent that load doesn't manifest the way that it's anticipated in the near term, DSM can be dialed down to offset. Is that correct?
Yes. So if certainly once we acquire this energy and it looks like there is a surplus of energy for a while, the moderation of DSM is definitely an option to manage that surplus.
And I understand there is a DSM potential study that's being undertaken this year. Is that correct?
That's correct.
And is it expected that DSM potential study could increase the options available to BC Hydro to use DSM to actually manage some of the energy and or capacity shortfalls it's seeing in the short term?
I really couldn't comment on the study that hasn't been completed yet.
It is possible, though.
Yes, it could be possible, but like as I mentioned several times, we are undertaking huge volumes of DSM, both on the energy and capacity side. To think there's more is, I mean, anything's possible, but it is highly unlikely. But I would really want to wait for the DSM potential study to be completed later this fiscal before commenting on what it might show.
And my final question is, given the priority in the Utilities Commission Act to consider demand-side options before energy procurement, did BC Hydro contemplate or make any efforts to accelerate the timeline of that DSM potential study in order to inform what's happening in this IRP?
I would say that that DSM study would then inform our next IRP, which is contemplated in 2028. This IRP is driven by the last DSM study that drove these timing and and the level of expenditures that we're putting forward. I think the next study would actually drive our next IRP, which is expected in 28.
And what was the timing of that last study?
We'll have to get back to you on that.
Thank you.
Next is Mr. Ince online for the Commercial Energy Consumers Association.
Good afternoon. Staying on slide 60, I've got a question on the cost of oversupply. And so, I don't want to delve into BC Hydro's market price forecast. There's markets to the south and east of us in which BC Hydro sells on a regular basis. But, and there's different price scenarios that you could construct. But does BC Hydro have any plausible business case for overbuilding its system and selling for export for profit? Is notwithstanding that probably would require some high-level approvals, but is there any economic business case for BC Hydro to build for export?
I wouldn't want us to spend too much time on this. Is it?
Yeah.
When I think about the IRP context
yes.
we're doing right now, we don't have a government policy to build for export, and
Yeah.
I am aware of a lot of jurisdictions, including in Canada, that have built for export. But anyway, so please keep it quite short.
Yeah, and that was exactly the response I was gonna give. That that is not part of the IRP, and we've explained that in our concordance table in Appendix I.
So what I'm trying to get at is the risk of oversupply, and so it seems like it's a loss and a ratepayer a cost increase. Increasing exports means increasing rates. Is that a fair statement? Under almost all plausible scenarios.
Could you clarify your question, Mr. Ince?
Do you see any plausible scenario whereby increasing the exports would increase the net revenues of BC Hydro, or they would decrease the net revenues of BC Hydro?
I think there's lots of assumptions there. I'm not sure when you say increase in the exports, what would be the source of the energy. So without that, I'm really not able to comment on the question.
Yeah, I mean, I shouldn't be a witness, but I have looked at ex post studies related to Quebec, Manitoba of long-term contracts. One can certainly do that, but I don't think that's the topic right here.
Okay. The next question is follow-up to question to Ms. Worth, and I think we're all looking forward to the next long-run marginal cost coming out of the 2025 call. So BC Hydro in the past has indicated that it treats DSM up to the long-run marginal cost. It will accept tranches of DSM up to that benchmark price. So it's treating supply and demand on a efficient, integrated way. In that, I assume the most efficient planning perspective would be to stack up supply, and so megawatts and negawatts in a supply curve, and then pick the lowest to the highest cost. So is BC Hydro still doing that? Is its expectation that it'll accept DSM up to that long run marginal cost?
So a process of how we arrived at the DSM volumes that we did, the programs that we've decided to pursue as the near-term actions, that's detailed in Chapter 3 of the IRP, Mr. Ince, where we've looked at different levels of DSM. We've identified the trade-offs and laid out the rationale for what we are doing as near-term actions.
Okay, a policy question. Does it make sense for BC Hydro to treat DSM and supply-side solutions any significantly different from an economic basis? So a hypothetical case that $100 a megawatt hour of supply side versus $100 per megawatt hour on demand side, would BC Hydro favor one over the other significantly?
We always look at demand side management measures first as a mean of supplying, and also in terms of the consequence tables that are outlined in chapter 3 of the IRP. It lists out like how these options, both demand side management and supply side options, measure in terms of environmental impacts, economic impacts, rate impacts, and so on.
Thank you.
Next is Mr. Quayle for Move Up.
I actually crossed this stuff out, but I think it might have become useful again. Anyway, just going to put, so, oh, by the way, on the question of DSM, there was a really interesting paper presented to a Campit conference years ago by an economist comparing the efficacy of DSM programs with the impact of the natural evolution of the energy efficiency of different devices that I commend to people. Anyway, I just want to put a couple of propositions to you about the entire resource planning process. I forget who wrote it. It was very late. Anyway, I put it to you that the purpose of the whole IRP scenario exercise is not a prophetic one. It's not about predicting actual outcomes, but rather about giving BC Hydro an opportunity to demonstrate that it has the strategic capability to respond to a range of plausible future challenges in the context of uncertainty.
That is correct.
And so, for example, a fine granular assessment of the individual scenarios, I put it to you, misses the point, and especially the main planning problem, which is that the future is inherently unknowable, and the amplitude of uncertainty today is much greater than we are used to.
Taking away my summary comments.
Okay. Further, wrapping all of this in context is that now we appear to be engaged in a process of economic planning by the federal and provincial governments on a scale that maybe we haven't seen since the Second World War. I don't know, leave that to Rick. But there is an economic planning process coming up that is an intrinsic part of the national strategy of surviving the threats that are facing us because of the realignment of global alliances and trade.
I would agree with that.
Would you agree with me that that has a bearing on, for example, weighing the relative downside of overbuilding a bit and underbuilding a bit?
That is the essence of the uncertainty that we talk about in our IRP.
And I put it to you that trying to divine the likelihood of particular scenarios or cost details coming true over the long run is not a useful concept and is actually not a useful part of resource planning. Would you agree with that proposition? If you think I've gone too far, go ahead.
I was going to say we were following, but okay, sure, go ahead.
I mean, we do have to consider affordability for
Yes.
customers, obviously. And although uncertainty increases over the long term, we do know that over the near to mid-term, we have an increasing need, especially for capacity, and we have to take action to address that.
So aside from the scenarios, which are a farther outlook, there's also near-term actions, and that's bundled in with this process as well. Stuff you've got to do now because look where we are right now. Right? You agree with that proposition?
That is correct.
Okay, I'll leave it at that.
Thank you, Mr. Quayle.
Next is Mr. Heap from the City of Richmond.
Hello again. Thanks. For slide 67, about Island Cogen specifically, how many hours per year do you expect Island Cogen to be providing peak load capacity services in its extended operation?
On average, very, very few. There might be years in which island generation might not have to run at all. It is pretty much, so compared to say hydro facilities where you can run water through the dam, running gas plant, there's a cost to it, right? You got to burn gas, which takes money. So this is our capacity option of last resort. So very, very few hours.
Okay. Would it be possible to provide something like a capacity duration curve that that you're expecting? Because I'm assuming it's not going to be like on at 400 megawatts or nothing, right? Wouldn't there be?
Yeah. So what we've shown in the load resource balance gives you an indication of the upper bound, and like if we had no other resources, here's what it would run. So it would run for like produce around 150 gigawatt hours. So that would be around 6 weeks maximum. Again, recognizing that is a very unlikely scenario in which we don't have any other resources.
And just for the record, you can find that in Appendix A to our May letter. We provided the capacity load resource balance and the energy load resource balance.
Okay.
You can see the runtime from there.
Okay, thank you. But in reality, I mean, it wouldn't be a matter of running it full on at 275 megawatts. There would be presumably a lot more times when you were running it at 25, 50, 100 megawatts, because that's all you needed, and there would be a very, very few number of times where you actually needed the maximum capacity.
There would certainly be plant restrictions on what capacity you could run it at. Like since it's a gas plant, you wouldn't be able to run it at say 5 megawatts, for example. But yes, certainly, I think it's more the time that you run it, which is limited, rather than the megawatts you run it.
Yeah, no, that makes sense to me. At the risk of making a naive comment, I would suggest that when it comes to meeting capacity on Vancouver Island, your problem isn't so much sourcing batteries, because if I'm not mistaken, there's already 400 megawatts of batteries on Vancouver Island. They're in cars, right? And so it's not necessarily getting the batteries, it's getting the power out of the batteries. And so I would suggest that, well, sourcing things for a battery, like a fixed battery bank, might be one way of doing it. Another way of doing it might be to have a vehicle to grid program, and you do have a number of years of runway on that. So, just suggesting that that there's maybe more than one way to skin that cat. Anyways, any thoughts?
Yeah, just like Mr. Quayle stole Mr. Kumar's thunder for the closing, you're stealing my thunder for the next part of my presentation. So we do talk about how we are doing pilot program on vehicle to grid studies as part of looking at more capacity options.
Great, glad to hear it. Thank you very much.
Next is Mr. Craig online for the Commercial Energy Consumers Association.
As I was listening to this, you had quite a number of things that could be variable, and your planning was being done to manage that. I may have missed it, but there's two variables that I didn't hear, which is the variable amount of water that we may or may not have in a given year or back-to-back years, and the variable amount of peak winter temperatures that can, and then the joint probabilities of all of those things. Can we get that data as part of the process?
So I have heard and read some about this already, so please be brief in answering this. Thanks.
This is all accounted for in our planning criteria, Mr. Craig. So we've in our in chapter 2 of the IRP, we lay out our energy planning criteria, the water conditions we look at, the variability around that, and the same thing for the capacity planning criteria as well.
Thank you.
And you mentioned earlier about climate change, water conditions, what's gone on. So what data we have so far? So that's on the record, Mr. Craig, if you want to look back from today's transcript.
Next is Mr. Magnus online for the Clean Energy Association of BC.
Thank you very much. I just wanted to seek a point of clarity on the comments regarding the upcoming battery RFP. I think there was an RFPOI as well that was introduced today in the discussion. I understand that 50 megawatts was put forward as the target amount, but I wanted to confirm that first, and then secondly, to confirm it would be specifically an RFP for batteries, or whether it would be something like we've seen in Ontario, more technology agnostic. Thank you.
Yeah, so the 50 is the minimum capacity that we expect to acquire through this procurement process. Could be higher depending on the proposals and the discussions with the proponents, but that is the amount we are targeting as a minimum. In terms of the technology, it is going to focus on batteries. There could be technologies within the batteries that the proponents can put forward in terms of their own sort of proprietary technology that they are using, but otherwise it's focusing on batteries only as far as this RFP is concerned.
Okay, thank you. And yeah, Clean Energy BC was involved in the design of the calls for power, and we look forward to working with your team on the RFP for capacity, specifically for batteries as we move into the fall. Thank you.
Thank you.
Next is Ms. Miss from Costco.
I actually have one clarifying question from pre-submitted questions. I didn't find a response for that. It would be question 4.1, and it's a long one, so maybe if you will look at it, so I wouldn't recite it. But the basic question here is, we looked at Exhibit B8 and your Appendix A, and some numbers confused us a little bit with respect to whether you change your requests, and we'll ask to confirm that BC Hydro has not changed the determinations it is seeking the Commission to make pursuant to Section 44.1. 9 of the Utility Commission's acts from those set out in the cover letter, page 1, from Exhibit B1, because we noticed that numbers in surplus are different from this Appendix A in Exhibit B-8 from Exhibit B-1, Appendix B, Table B1. I'm not citing everything, but it's all set in our pre-submitted question 4.1, and we want to answer with that.
With respect to the conclusive determination, we did put in some commentary on that in our cover letter for the workshop slides. And as this is a regulatory legal matter, if our Chief Regulatory Officer, Chris Sanvey, is able to speak to it, that would be an option. But we did submit a clarification in our cover letter on that.
Yes, we noticed that you addressed question regarding additional capacity, but we want to address energy. Whether your request regarding energy changed.
It did not change. We're still requesting a conclusive determination for energy of 5,000 gigawatt hours. Would Mr. Sanvey care to? Okay, I got that right. Thank you.
And I think I see Ms. Worth online may have turned her camera on. I'm not sure if she had a question that she wanted to ask. Oh, I guess not. Any other parties in the room or online that were wanting to ask a question now? And not hearing anybody, I think BCUC staff had a couple of questions.
Thanks very much. If I could get you to switch to slide 58, and I just want to have a follow-up or a few follow-up questions with respect to, I'm going to call it the three different pathways for additional resource acquisitions. We've heard so far that you've discussed at a high level the prioritization of these different pathways as identified on the screen here. And I may have heard this already, but I just want to be sure for clarification purposes that is it my understanding that any acquisitions from either future calls to power, partnerships with developers, or partnerships with First Nations would be from greenfield facilities?
That is the early indication.
Thank you. And looking at the, as I understand, the first one of those in your prioritization, which was the partnerships with First Nations impacted by the North Coast Transmission Line. I'm just looking to get a slight expansion on the sort of meaning and status of this particular acquisition pathway, and not looking for details on any specific projects, but just kind of looking to get an indication of, is this representative of energy projects that BC Hydro is currently in negotiation with, or is it something that's sort of more conceptual at this stage as a plan to pursue?
Yeah, so there are active discussions happening as we speak on those partnerships, because the North Coast transmission project is a real project that's moving forward. So as part of those, there are active discussions. I can't get into the details around the commerciality and the size and the location, but these are actual projects we are discussing, not concepts.
Thank you. And hopefully the reasoning for this will come clear with my next questions is that if you can go to the next slide, which illustrates, there we go, the updated load resource balance and showing some of the volumes of energy that are projected through the period fiscal 2030 to 2035. And I particularly want to sort of focus my questions on the earlier years in that horizon with respect to the additional energy acquisitions. And I just would like to get BC Hydro's sort of view on the degree of confidence that for looking at the volumes in fiscal 2030, 2031 as an example, the degree of confidence that you have that any of these additional resources will be deliverable in the context of the lead times that you otherwise have identified in the IRP for greenfield resources.
So again, as Mr. Kumar mentioned, like we cannot get into project specific details, but what I can say is like, so typically we assume wind projects would take 5 to 8 years, with average 6 years is what we quoted, but we have seen examples where projects could come into service much earlier than that. So there are a couple of examples from outside of our province where projects have come into service like in 3 years or less. So there's a project in Saskatchewan which came into service in 2025, and another in Alberta in I believe 2024. So certainly there's the possibility that there could be projects depending on where they are that could come in earlier. I do also want to say, like, so with the 2024 call, like the new process of getting these renewable energy projects permitted through the BC Energy Regulator, that got kicked off. And as more and more projects come in, the better that process will be. So projects that come in later would have a much smoother ride than obviously the first project that came in. Just again on that same topic of like having this steady stream of projects, things like getting equipment to build the wind farms. So right now, like these wind farms need turbine blades which are 80 meters long, right? And it's really tough to ship those through either the Port of Vancouver or the Port of Prince Rupert, because you just cannot get it out of the port. Now, for the very first projects, the wind turbine manufacturers are going to look at a map of BC and then try to figure out, okay, how are we going to get these turbines to the site? But as more and more projects get into service, that process, well, it's already well established, right? So we do have a certain optimism that projects that we initiated later would actually have shorter lead times. Again, it's to be proven, but certainly there's lots of reasons to be optimistic. So the short answer is yes, there's certainly uncertainty around those early years, but again, there is certain promise as well.
And maybe just to build upon your interpretation of that promise and how it relates to the current state of affairs, do you see that, talking about maybe the supply chain opportunities, I'll call them there, that BC has reached a level of maturity that would lead you to believe that that is a high or a status that we are kind of moving into in terms of facilitating those shorter lead times?
Certainly, there's, as I mentioned, there's lots that are positive, but and on the side, like taking batteries as an example, there's obviously things that are happening in a North American or global context of, say, transformer shortages, which BC might not be able to influence. But the examples I gave, such as, well, BC energy regulators, something happening in the province, transporting within the province, yeah, something that's happening in the province. So those things are certainly positives. There might be things that are beyond BC Hydro's or BC's control for that matter.
Okay, thank you. And I have just one other question, which is changing track, and I don't need a slide on the screen. I don't believe this one was addressed, but in the BCUC's pre-filed questions, we had, I think it was 6.3, a question which was asking around how BC Hydro accounts for the greenhouse gas emissions from the McMahon cogen facility. And just the premise for this question was under the understanding that in addition to electricity supply that this facility provides for BC Hydro, is it also serves thermal load, and you can correct me if any of that is wrong, but we're just seeking to understand how the emissions from this facility are attributed to BC Hydro's electrical supply versus the thermal load that facility also supplies.
Yeah, I did attempt to answer that question, and I apologize if I didn't fully clarify what you were asking for. But what we do with there, and we have an historic emission of around 340 kilotons. That's calculated based on established emission factors. So those established emission factors were published by the Climate Action Secretariat. I understand that that might no longer be an entity, but like those, we use those factors for each plant. So we have a set of established factors for McMahon, for IG, and we use that. We look at the generation that was produced in that year, and then we do that calculation, and we provide that number as part of our annual reporting.
Okay, thank you. That's all I have.
Any questions from the panel?
No, the only just this very last question landed right in an area that I'm very interested in as well, and so I'll look again at your answer to that. It's just, and you might not know this as well, that there has been a real history of trying to define cogen and whether or not it's clean or isn't, and how do we figure out the incremental amount that went to electricity generation as opposed to an industrial load or even municipal district heating. And so it's interesting now, since BC Hydro has just raised the issue of continuing on with these plants, how you would define them and thinking about them within the context of the Clean Energy Act and the regulations and so on. I don't know if you want to elaborate any further on that, but it's something we can also get to. I may bring up a bit later as well. So if you're fine there, go ahead.
Yeah, and again, I'm not, I don't have the knowledge of how these emission factors were derived. But again, as you mentioned, so with the cogen facility, there's some emissions attributable to the steam generation, some attributable to the electricity generation. And in coming up with the emission factor that's attributable to McMahon, I think they looked at, okay, how much of the natural gas is actually getting used to electricity. and then that was the basis. Again, yeah, that's the extent of my knowledge.
Okay, so suggestions, Mr. Bear?
Well, I see you looking at your watch, Mr. Chair, and I'm also mindful of the time. We seem to be making good progress, and one option would certainly be just to call it a day here, or BC Hydro could continue with its presentation if you'd prefer.
Right. So we know where we're at. We could launch into the next part of your talk, or it's true. It's 20. What is it? Whatever it is, almost 20 to 5. It sounds pretty safe that we're going to get through everything tomorrow, perhaps even. But it also sounds pretty safe that we're not going to get through everything today. So I'm leaning towards saying, why don't we take the moment right now to end for the day, unless someone has any problem with that. So that would mean we would start again at 8:30 tomorrow morning. You'd go through the final segment, I guess, of your slides, and then we'll take questions with that. So it's been a good day. I want to thank all participants. I think people have done a real good effort at running this very efficiently and effectively, and I've been impressed with that, with the strategic focus of the questions people have asked, and I want to thank them all for that as well, and thank the Hydro panel for being so clear and so well prepared, and with also concise answers. So on that, do you want to say anything else about logistics, Mr. Bear? I guess that's 8:30 tomorrow morning. There's nothing else to say.
Nothing else from me.
BC Hydro, everyone's fine? All right, then we'll stand adjourned until 8:30 tomorrow morning. Thank you, everyone.
Thank you.
Thanks, panel.